कुछ ही समय में हम कार्यक्रम की शुरुआत करेंगे, इसलिए मैं आप सबसे अपना-अपना स्थान ग्रहण करने का अनुरोध करती हूँ। I'll start.
मीटिंग चल रही है उसे बुला दे ये एक रेखा आ गया
जैसे ही कुछ ही समयों में हम कार्यक्रम की शुरुआत करने वाले हैं, मैं आप सबसे निवेदन करती हूँ कि अपना स्थान ग्रहण करें। No, I will continue with this. As we are about to start the program, I request everyone to be seated, please. हाँ हाँ हम कार्यक्रम के मुख्य अतिथि माननीय मंत्री महोदय डॉक्टर महेंद्र नाथ पांडे, भारी उद्योग मंत्रालय, भारत सरकार से वर्चुअली हमसे जुड़ने की प्रतीक्षा में हैं।
नमस्ते। हाँ, next, एक छोड़ दो। हाँ,
सुप्रभात। मैं शर्मिष्ठा यहाँ उपस्थित सभी लोगों को केंद्र विनिर्माणकारी प्रौद्योगिकी संस्थान सीएमटीआई में आईआईएससी और सीएमटीआई के सहयोग से भारी उद्योग मंत्रालय भारत सरकार द्वारा आयोजित रोबोटिक्स पर राष्ट्रीय सम्मेलन में आपका हार्दिक स्वागत करती हूँ। अब मैं संयुक्त सचिव श्री विजय मित्तल, भारी उद्योग मंत्रालय भारत सरकार एवं आईआईएससी के निदेशक प्रोफेसर गोविंदन रंगराजन से अनुरोध करती हूं कि वे कृपया डायस पर तत्संबंधी स्थान ग्रहण करें। धन्यवाद। रोबोटिक्स पर इस राष्ट्रीय सम्मेलन में हमारे मुख्य अतिथि माननीय मंत्री महोदय डॉक्टर महेंद्रनाथ पांडे, भारी उद्योग मंत्रालय भारत सरकार, राजधानी दिल्ली में पीएमओ द्वारा निर्धारित मंत्री परिषद की बैठक होने के कारण इस कार्यक्रम में सम्मिलित नहीं हो पा रहे हैं, लेकिन वह वर्चुअली हमारे साथ जुड़ने और सभा को संबोधित करने का प्रयास करेंगे।
कमाल के साथ।
By the time of hello, hello. By the time our honorable minister joins virtually, we'll be playing a video on CMTI.
Manufacturing sector has played a stellar role in growth and development of an industrialized nation, having a key role in the economic development. Manufacturing industries, for their sustainability in the global market, need to be innovative, responsive, and cost competitive. CMTI, Central Manufacturing Technology Institute, is an autonomous R&D institute under the Ministry of Heavy Industries. Manufacturing sector has played a stellar role in growth and development of an industrialized nation, having a key role in the economic development. Manufacturing industries, for their sustainability in the global market, need to be innovative, responsive, and cost competitive. CMTI, Central Manufacturing Technology Institute, is an autonomous R&D institute under the Ministry of Heavy Industries. CMTI is primarily focused on developing science and technology-driven solutions. With decades of diligent technology development, CMTI has built a comprehensive foundation and evolved as a center of excellence in the field of manufacturing, special purpose machines, nanotechnology, ultra-precision engineering, smart manufacturing, and technology for sensors. CMTI has rechristened itself into Central Manufacturing Technology Institute in the early 90s to embrace innovation and evolution, to promote and accelerate technology development and create sustainable environment for future.
Welcome to Central Manufacturing Technology Institute, Bangalore. CMTI is a national R&D institute under Ministry of Heavy Industry, Government of India. So we are 60 years old institute, established in 1962 as a Central Machine Tool Institute. Since inception, we primarily do the design and development of machine tools and development of manufacturing processes for various applications. We CMTI have 4 kind of activities, we develop the technologies which are futuristic. We develop the machines and automation solutions and also provide the services to the industry to meet their requirements. And we also offer training programs both for working professional as well as students and faculties. As of now, we have about 54 technologies which are ready for commercialization. All these 54 technologies are new to India, and we look at these technologies be utilized by industries that will generate the economy for the Indian industry. We serve the product development team with respect to manufacturability evaluation, and we also develop the process which are it is process specific or the product specific. And also we're working on the design and development of capital goods, that is machine tools, automation systems, subsystems, and then we train these manpower to integrate these solutions which we develop into their manufacturing line. We primarily work on addressing the 4P challenges, that is the challenges related to product design, process design, production equipments, and the people training. So while addressing these 4P challenges, we closely work with our customers, stakeholders, so that this technology developed within the country could be utilized for the benefit of Indian manufacturing sector. Currently, our focus domain is to develop ultra precision
I regret for the technical glitches. Our IT team is working on it. I request our IT team to resolve the issue as soon as possible.
Manufacturing sector has played a stellar role in growth and development of an industrialized nation, having a key role in the economic development. Manufacturing industries, for their sustainability in the global market, need to be innovative, responsive, and cost competitive. CMTI, Central Manufacturing Technology Institute, is an autonomous R&D institute under the Ministry of Heavy Industries. CMTI is primarily focused on developing science and technology-driven solutions. With decades of diligent technology development, CMTI has built a comprehensive foundation and and evolved as a center of excellence in the field of manufacturing, special purpose machines, nanotechnology, ultra precision engineering, smart manufacturing, and technology for sensors. CMTI has rechristened itself into Central Manufacturing Technology Institute in the early 90s to embrace innovation and evolution, to promote and accelerate technology development and create sustainable environment for future.
Welcome to Central Manufacturing Technology Institute, Bangalore. CMTI is a national R&D institute under Ministry of Heavy Industry, Government of India. So we are 60 years old institute established in 1962 as a Central Machine Tool Institute. Since inception, we primarily do the design and development of machine tools and development of manufacturing processes.
Our Honorable Minister will be shortly joining. इतना ठीक है इतने दूर में अति प्रतीक्षित घड़ी आ पहुंची है। हमारे बीच हमारे मुख्य अतिथि माननीय मंत्री महोदय डॉक्टर महेंद्र नाथ पांडे, भारी उद्योग मंत्रालय, भारत सरकार, माननीय राज्य मंत्री श्री कृष्णपाल गुर्जर, भारी भारी उद्योग मंत्रालय, भारत सरकार जी वर्चुअली हमसे जुड़ चुके हैं। साथ ही श्री कमरान रिजवी, सचिव, भारी उद्योग मंत्रालय, भारत सरकार भी वर्चुअली हमसे जुड़ गए हैं। मैं आप सभी से अनुरोध करती हूँ कि मुख्य अतिथि और सभी गणमान्य व्यक्तियों का तालियां बजा की गड़गड़ाहट के साथ स्वागत करें। अब मैं श्री संजीव कुमार गुप्ता, अंडर सेक्रेटरी, भारी उद्योग मंत्रालय, भारत सरकार से माननीय मंत्री महोदय डॉक्टर महेंद्र नाथ पांडे, भारी उद्योग मंत्रालय, भारत सरकार को स्वागत करने का अनुरोध करती हूँ। कृपया ताली बजाते रहें। साथ ही मैं उनको श्री कामरान रिजवी, सचिव, भारी उद्योग मंत्रालय, भारत सरकार का भी स्वागत करने का अनुरोध करती हूँ। धन्यवाद। अब मैं डॉक्टर नागा हनुमैया, डायरेक्टर CMTI को श्री विजय मित्तल, भारी उद्योग मंत्रालय, भारत सरकार को स्वागत करने का अनुरोध करती हूँ। अब मैं डॉक्टर नागा हनुमैया, डायरेक्टर CMTI को प्रोफेसर गोविंदन रंगराजन, निदेशक IISc को स्वागत करने का अनुरोध करती हूँ। धन्यवाद सर। प्रकाश की किरणें आशा की किरणें हैं, तो आइए हम संसार के किसी भी प्रकार के अंधकार की छाया को दूर करने और ब्रह्मांड में के सुनहरे पन्नों को पढ़ने के प्रतीकात्मक रूप से ज्ञान की रोशनी जलाएं। हम 2 दिवसीय राष्ट्रीय सम्मेलन का शुभ आरंभ करने के लिए अब सत्य और ज्ञान के प्रतीक के रूप में अपना पारंपरिक शुभ दीप प्रज्वलन समारोह के लिए अग्रसर होंगे। ईश्वर की असीम अनुकंपा और हमारे माननीय मंत्रियों और सचिव जी के आशीर्वाद से आज हम रोबोटिक्स पर इस राष्ट्रीय सम्मेलन की मेजबानी करने में सक्षम हैं। हमारे मुख्य अतिथि मंत्री महोदय डॉक्टर महेंद्र नाथ पांडे, भारी उद्योग मंत्रालय, भारत सरकार, माननीय राज्य मंत्री श्री कृष्णपाल गुर्जर, भारी उद्योग मंत्रालय, भारत सरकार, और श्री कमरान रिजवी, सचिव, भारी उद्योग मंत्रालय, भारत सरकार की शारीरिक अनुपस्थिति होने के कारण उनके बिहाफ में मैं दीप प्रज्वलन करने के लिए श्री विजय मित्तल, संयुक्त सचिव, भारी उद्योग मंत्रालय, भारत सरकार, प्रोफेसर गोविंदन रंगराजन, निदेशक IISc को प्रोफेसर अमरेश चक्रवर्ती, IISc बैंगलोर, डॉक्टर नागा हनुमैया, निदेशक CMTI, एवं श्री प्रकाश विनोद, सेंटर हेड SMPM CMTI से दीप प्रज्वलित करने और प्रतीकात्मक रूप से सम्मेलन का उद्घाटन करने का अनुरोध करती हूँ। साथ ही मैं अपने सहयोगी श्रीमती निसर्गा से मंच पर आके शास्त्रीय गीत गाने का आह्वान करती हूँ।
अजं निर्विकल्पं निराकारमेकं निरानन्दमानन्दमद्वैतपूर्णम् परं निर्गुणं निर्विशेषं निरेहं परब्रह्मरूपं गणेशं भजेम परब्रह्मरूपं गणेशं भजेम गुणातीतमानं चिदानन्दरूपं चिदाभासकं सर्वगं ध्यानगम्यम् मुनिध्येयमाकाशरूपं परेशम् परब्रह्मरूपं गणेशं भजेम परब्रह्मरूपं गणेशं भजेम जगत्कारणं कारणज्ञानरूपं सुरादीन् सुखादीन् गुणेशं गणेशम् जगद्व्यापिनं विश्ववन्द्यं सुरेशम् परब्रह्मरूपं गणेशं भजेम अजं निर्विकल्पं निराकारमेकं निरानन्दमानन्दमद्वैतपूर्णम् धन्यवाद।
धन्यवाद आप सबों का। आशा नहीं है मंजिल पाना, सपनों को सच कर लेना, पर नामुमकिन नहीं है ये बिल्कुल, बस दृढ़ निश्चय कर लेना। भारत के प्रधानमंत्री श्री नरेंद्र दामोदर मोदी जी के आत्मनिर्भर भारत के विजन को बल देते हुए भारी उद्योग मंत्रालय देश के इंफ्रास्ट्रक्चर को मजबूती देने के साथ मैन्युफैक्चरिंग को भी बढ़ावा दे रहा है। भारी उद्योग मंत्रालय देश में रोबोटिक्स और ऑटोनोमस यानी स्वयं प्रणालियों के विकास में गति ला रहा है, ताकि भारत के लिए वैश्विक नेतृत्व तैयार किया जा सके। एक मजबूत विज्ञान और प्रौद्योगिकी बुनियादी ढांचे का निर्माण करना जो शिक्षा जगत, स्टार्टअप, उद्योग और अनुसंधान एवं विकास प्रयोगशालाओं के लिए सुलभ हो, और यही सरकार की प्राथमिकता है। तो आइए एक संतोषजनक मुस्कान के साथ रोबोटिक्स पर इस 2 दिवसीय राष्ट्रीय सम्मेलन की शुरुआत करें। अब मैं संयुक्त सचिव श्री विजय मित्तल, भारी उद्योग मंत्रालय जी से स्वागत अनुवादन और सभा को संबोधन करने का अनुरोध करती हूँ।
Thank you. Honorable Minister for Heavy Industries, Dr. Mahendranath Pandey, Honorable Minister for State for Heavy Industries, Shri Krishnapal Gurjar Sir, Dr. Govindarajan, Director IISc, respected Secretary Heavy Industries, Shri Kamran Rizvi Sir, esteemed dignitaries, distinguished guests, ladies and gentlemen. I, with immense pleasure and utmost honor, would like to extend a heartfelt and resplendent welcome to each and every one of you at this national conference of robotics on this beautiful city, in this beautiful city of Bangalore. दोस्तों, जैसा आप सभी जानते हैं, हमारे माननीय मंत्री डॉक्टर महेंद्रनाथ पांडे जी, जिनका प्रेरणा स्रोत, जो हमारे लिए हमेशा हर कार्यक्रम के लिए एक प्रेरणा स्रोत रहते हैं और जिनका मार्गदर्शन MHI को निरंतर रूप से मिलता रहता है, वो इस कार्यक्रम में आना उनका सुनिश्चित था, लेकिन किसी अपरिहार्य कारणों की वजह से आज वो फिजिकल रूप से यहाँ उपस्थित नहीं हो सके, हमारे साथ ऑनलाइन जुड़े हुए हैं। तो इस कार्यक्रम में सबसे पहले मैं माननीय मंत्री जी का एक बार फिर जोरदारी से स्वागत करता हूं और चाहता हूं कि कंप्लीट हॉल उनको जोरदार ताली बजा के स्वागत करे। इसी तरह हमारे माननीय राज्य मंत्री जी श्री कृष्णपाल गुर्जर साहब, जो इस कार्यक्रम में आने के लिए उत्साहित थे, वह भी अपने किसी अपरिहार्य कारणों की वजह से नहीं आ सके। हम जानते हैं माननीय राज्य मंत्री जी 2 विशिष्ट मंत्रालयों का अपना निर्वहन करते हैं, ऊर्जा मंत्रालय तथा मिनिस्ट्री ऑफ हेवी इंडस्ट्रीज। अब उसके अलावा वो समाज सेवा में सदा व्यस्त रहते हैं, लेकिन वो भी आज हमारे साथ ऑनलाइन या जुड़े हुए हैं। मैं चाहता हूं कि सारा हॉल उनका भी तालियां बजाकर जबरदस्त तरीके से स्वागत करे। इसी क्रम में हमारे सचिव महोदय जिनके मार्गदर्शन में इस पूरी कॉन्फ्रेंस को तैयार किया गया, मुझे याद है लगभग आज से 2 माह पूर्व जब ये बात हुई थी कि देश में इस समय कैपिटल गुड्स इंडस्ट्री और मिनिस्ट्री ऑफ हैवी इंडस्ट्री के तत्वाधान में एक नेशनल कॉन्फ्रेंस ऑफ रोबोटिक्स करने का विचार आया था, तो सर ने सहर्ष उसको स्वीकार किया था और सिर्फ स्वीकार ही नहीं किया था, तब से पिछले 45 दिनों से लगातार हमको इस कार्यक्रम को आयोजन करने के लिए अपना मार्गदर्शन दिया था। मैं चाहता हूं कि एक बार हम लोग उनका भी इस कार्यक्रम में बहुत जोरदार तालियों के साथ स्वागत करें। Friends, so as we gather here today, we are well aware of the profound impact Sophia, the renowned powerful humanoid robot, has made in the world, inspiring and capturing the admiration of countless individuals. As a nation, we have shared the collective dream of attaining an advanced state infused with safety. It is in harmony with this shared vision that we had assembled today, commemorating a significant milestone in our relentless pursuit of technological advancement and harnessing the power of robotics to propel our nation towards a future. In Ministry of Heavy Industries, our journey for enhancement of competitiveness in capital goods started in the year 2014. We all are aware when we introduced the enhancement of capital goods scheme 1, and we supported industry, academia, and all of them came together to identify their projects for research and development. Ministry of Heavy Industries sponsored those projects with a total capital investment of almost 900 crore. And I am very happy to say that all of us who are sitting here from the esteemed institutions like IIT Kharagpur, IIT Delhi, IISc Bangalore above all, and many other startups who came forward for those various R&D projects took us and rather gave us the motivation to come out with a capital goods scheme 2. And in the capital goods scheme 2, we again had a total budget of 1207 crore, out of which with the active participation of all the industry, we have already projects worth 910 crore in our hand, out of which in the very first year, I am very happy to announce that in the very first year, there was an active participation by all the industry partners, and we could actually gainfully utilize amount of 231 crore rupees in the very first of years of its induction for various development activities. Friends, through this enhancement of capital goods industry, competitiveness of capital goods industry, we created 15 CEFCs, Industry 4.0 advocacy centers, as we call them, summer centers, and various centers of excellence. These centers of excellence and CEFCs are working on various projects related to automation, related to Industry 4.0, related to robotics, related to various systems, subsystems of robotics, and creating an environment, conducive environment in the country, which will pave way for this automation and robotics in the country, with an overall aim of creating a higher productivity, lower cost, and increasing the competitiveness of our industry. So this conference, wherein we have designed 5 panel discussions, and these discussions held here, which will be held here, will give us a good takeaways from this gathering, which will take us to the way forward for this robotics. The panel led by 5 distinct groups, the exhibition showcasing the various robots, which will be inaugurated very soon, and the competitions designed for startups and researchers, all shall contribute to a deeper understanding and effective implementation of knowledge and ideas. In the end, I really want to express my heartfelt gratitude to CMTI, to IISc, especially Director IISc, for collaborating with MHI, to each and every one of you for coming here in good numbers to enrich this event with your gracious presence. Your contributions, I am sure, shall truly enhance the depth and richness of this gathering. So thank you all sincerely once again. Let us continue to collaborate, innovate, and work towards the growth and progress of our robotics industries and our nation as a whole. Friends, together we can definitely achieve greater heights. Thank you. Jai Hind.
थैंक यू सर। रोबोटिक्स कॉन्फ्रेंस के लक्ष्य के बारे में संक्षेप में बताने और सुंदर रूप से इस सभा को संबोधन करने के लिए आपका बहुत बहुत धन्यवाद। अब मैं माननीय सचिव भारी उद्योग मंत्रालय भारत सरकार से सभा को संबोधित करने का अनुरोध करती हूँ।
माननीय भारी उद्योग मंत्री भारत सरकार आदरणीय डॉक्टर महेंद्र नाथ पांडे जी, माननीय राज्य मंत्री भारी उद्योग आदरणीय कृष्णपाल गुर्जर जी, माननीय निदेशक इंडियन इंस्टीट्यूट ऑफ साइंस प्रोफेसर गोविंदन रंगराजन जी, संयुक्त सचिव भारी उद्योग विजय मित्तल जी, ऑर्गेनाइजिंग कमेटी के सभी सम्मानित सदस्य, distinguished guests, esteemed participants, ladies and gentlemen. Let me at the very outset say that it is my honor to be addressing a distinguished gathering of national experts on robotics, practitioners and members of the industry. There is no doubt that robotics is changing the way we are living our lives and that the story has just begun. अगर हम इस बात को देखें कि साइंस और टेक्नोलॉजी की दुनिया में ऐसी कौन सी चीज है जिसने कि लेखकों को और फिल्म निर्माताओं को दोनों को उत्साहित किया है, तो साइंस और टेक्नोलॉजी ने बहुत तरक्की करी है, लेकिन एक विषय ऐसा, रोबोटिक्स ऐसा विषय है जिसने कि साइंस फिक्शन राइटर्स को और फिल्म निर्देशकों को इतना प्रोत्साहित किया है, इतना उनको मोटिवेट किया है कि अगर हम देखें संक्षेप में तो जो सबसे मशहूर साइंस फिक्शन राइटर है आइजैक एसिमोव, उन्होंने सन 50 में 3 लॉज ऑफ रोबोटिक्स बना दिए। तो बीच में ब्रेक हो गया था हमारा। तो आइजैक एसिमोव के 3 लॉज ऑफ रोबोटिक्स थे। जब रोबोट के बारे में किसी साइंटिस्ट ने बनाने का सोचा नहीं था, उस वक्त आइजैक एसिमोव ने लॉज ऑफ रोबोटिक्स बना दिए, और वो लॉज ऑफ रोबोटिक्स आज भी इंसान को मोटिवेट करते हैं कि कैसे रोबोट्स को और आज्ञाकारी और बेहतर बनाया जाए। लेकिन जब मैं आईआईटी दिल्ली में पढ़ रहा था 1989 में, तो इस विषय को पढ़ाया जा रहा था, तो स्टार वॉर्स फिल्म आई थी। तो स्टार वॉर्स फिल्म को अगर आप स्मरण करें तो उसमें 3 तरह के पात्र थे। एक पात्र इंसान थे, दूसरे पात्र एलियंस थे, और सपोर्टिंग रोल में रोबोट्स थे। जिन लोगों ने देखी हो पिक्चर तो R2-D2 नाम के 2 रोबोट्स उसके अंदर दिखाई देते थे। लेकिन जैसे जैसे टेक्नोलॉजी का एडवांसमेंट हुआ तो अब नई पिक्चर आई जो बहुत बड़ी ब्लॉकबस्टर पिक्चर बनी, उसका नाम टर्मिनेटर सीरीज है। अब टर्मिनेटर सीरीज में क्या हुआ कि उसमें इंसान है, लेकिन उसके हीरो, नायक और खलनायक दोनों रोबोट्स हैं। तो इंसान का सेकेंडरी रोल हो गया। जिन्होंने पिक्चर देखी हो तो आर्नल्ड श्वार्ज़नेगर नायक के रोल में, लेकिन रोबोट है, और ऑपोजिट साइड से विलेन भी रोबोट है, और रोबोट और खलनायक दोनों एक ही तरफ हैं। और रिसेंट पिक्चर देखा जाए तो ट्रांसफॉर्मर्स पिक्चर की सीरीज है, जिसमें इंटरेस्टिंग बात यह है कि इंसान तो है लेकिन रोबोट्स इस प्लेनेट के नहीं, दूसरे प्लेनेट के हैं। आउटर स्पेस से आए हुए रोबोट जो हैं वो पृथ्वी के ऊपर अपना रोल प्ले कर रहे हैं। तो ये दिखाता है कि साइंस एंड टेक्नोलॉजी जो है वो ह्यूमन इमेजिनेशन से पीछे है। इमेजिनेशन आगे चलती है, टेक्नोलॉजी उसको कैचअप करती है, और अब तक का इतिहास ये रहा है कि टेक्नोलॉजी ने साइंस फिक्शन को सही बताती गई है। तो इस प्रकार से अगर देखा जाए, सोचा जाए, तो निश्चित रूप से रोबोटिक्स की शुरुआत अभी शुरू ही हुई है। अगर हम देखें कि रोबोट्स ने हमारी जिंदगी में क्या काम किया आज तक है, तो हम कल्पना नहीं कर सकते कि मैन्युफैक्चरिंग, खास तौर से ऑटोमोबाइल मैन्युफैक्चरिंग, रोबोट्स के बिना संभव नहीं है। इलेक्ट्रॉनिक्स की मैन्युफैक्चरिंग, मोबाइल सेट्स, कंप्यूटर्स, ये रोबोट्स बना रहे हैं। हेल्थ केयर, लॉजिस्टिक्स, सर्विस, एग्रीकल्चर और डिफेंस, इन सभी क्षेत्रों को रोबोटिक्स ने पूरी तरह से तब्दील कर दिया है। और आज की जो वर्कशॉप है, ये इस वर्कशॉप का विषय जो इसका जो इतनी बड़ी वर्कशॉप जो हम इकट्ठा हुए हैं, उसका एक जो मूल उद्देश्य है, सेंट्रल पर्पस ऑफ दिस मीटिंग टुडे इज कि हाउ टू मेक इंडिया अ ग्लोबल मैन्युफैक्चरिंग हब फॉर रोबोट्स। To understand the context, let us look at the size of the robotics industry in the globe. Today, $50 billion worth of robots are manufactured annually. अगर हम उसको रुपए में कन्वर्ट करके देखें तो 4 लाख करोड़ रुपए का इसका साइज इंडस्ट्री का है, और ये 12% प्रति वर्ष के हिसाब से बढ़ रही है। 2032 में ये 12 लाख करोड़ की इंडस्ट्री हो जाएगी। इस इंडस्ट्री में जो लीडिंग कंट्रीज हैं, उसमें जापान, जर्मनी, साउथ कोरिया, चाइना और यूनाइटेड स्टेट्स हैं। इसमें भारत ने कदम रखा है, लेकिन अभी पहला कदम है इसके अंदर। इसमें अगर देखें कि दुनिया में रोबोट सबसे ज्यादा कहाँ इंस्टॉल्ड है, तो 78% रोबोट इन 5 कंट्रियों में, और इन 5 कंट्रियों में भी प्रथम स्थान चाइना का है। तो अगर हमको ग्लोबल मैन्युफैक्चरिंग हब बनना है, तो रोबोटिक्स से हमको परहेज नहीं कर सकते। रोबोटिक्स हमारे लिए एक पहला कदम होगा कि हम ग्लोबल मैन्युफैक्चरिंग हब बने। India has taken a lot of strides in this area. Our Honorable Prime Minister has given the call for Make in India, Digital India, Atmanirbhar Bharat. All these are laying foundations for various industries, including automation and robotics. Now, what is the size of Indian market? Indian market today is 6,000 crore rupees annually. It is growing at a rate of 7% per year, and it is going to reach 8,000 crores in next 3 years. So it is a sizable industry. But as I said, this is the first step, and it is poised to grow even much more. If you look at the India's ranking in the robotics world, then India ranks 10th in the world in utilization of robots. Today we have 33,000 robots working in the country. Every year around 5,000 robots we are adding to our workforce, and it is as diverse as I said, from defense to manufacturing to agriculture to service to support all kinds of industries, and no area has been left out from India's efforts. So this growth rate of use of robots is 16% in the country. So this is growing very fast. So there is a huge potential that remains with us. If you look at the penetration of robots per 10,000 people, globally 141 robots are there for 10,000 people, but in India it is at 7. So we can scale it up 20 times. But question that arises is that India, with a population of 140 crore people, does it need robots? Or that we should, like, say, avoid robotics because we have to provide employment? That is a central question that we have to answer. To get an answer to that, we have to understand what the robot does and how it helps us. So first of all, that robots work in dangerous places where human beings or human lives cannot be put. For example, in welding, in painting, in defense sector. Robots are now used for bomb disposal squads. Robots are used to remove mines. Robots are used in all kinds of defense applications. There are a lot of applications for robots in the nuclear industry, for underwater recovery systems, for a dangerous environment like paint shops. So robots are something that human beings have to live with, and India also has to live with robots and utilize them Second is that robots, they remove drudgery. That human existence is at a higher level. They should not be doing repetitive jobs. Human beings must be doing higher order thinking jobs, value addition jobs. They should be working together with robots. So that is the second place where robots are needed. And third is that productivity, accuracy and productivity. The job robot can do, it can do it 5 times, 10 times more than what a human being can do in a day. And also that accuracy of a robot is much more than that of a human being. So given all these things, robots are something that we have to utilize, harness for our country's growth, and that with the vision that Honorable Prime Minister has of making India a global, well-developed country by 2047, robotics has to play a key role in that. Now, to understand that what are the key steps we should be taking in this area. So first step to my mind comes that preparing society to understand robots and accepting robots in their day-to-day existence. So that means that awareness creation, IEC activities, engaging with people, stakeholders, building an awareness and building policy advocacy for advancement of robots. The second is that creating a creating training programs so that when robots come, people are ready to use that. Now this is one big gap, that robotics was students study in the classroom. Once they face an actual robot, I have seen them perplexed. So how should our education program be such that it trains people for the actual robots which are found in the workplace, designing curriculums, training education institutions across the country, and preparing students for the future ready robotics. That is another area. Third area is that research, that we should not be satisfied that we are using robots. Using robot is a lower level activity. The higher level activity is manufacturing robots. So how do we manufacture robots? As Vijay pointed out in his speech, that Ministry of Heavy Industries gives support to education institutions, like we have given to the esteemed Indian Institute of Science. We have helped to set up cameras. So these are the institutions where cutting edge research goes on, where new areas are being persuaded, and startups are being incubated over there, so that they can make those robots which will make the manufacturing a different world. So that we are not an importer of robots, we are a manufacturer of robots, we are an exporter of robots, we are at the cutting edge of robotics, we are finding newer areas where it can be used, and that in the Committee of Nations, Indian robotics is kept at the highest level. So, and the last point is that what should be the role of government? One of the role of government is to organize workshops, bring the practitioners together, facilitate exchange of ideas. But the government, as you know, that through our various schemes, for example, the production linked incentive schemes, we are promoting Make in India efforts. So we can think in terms of how to attract investments in the field of robotics, how to promote research in the area of robotics, what kind of incentives, tax breaks, grants can be given to companies so that they can become world beaters. So all these are the topics which will occupy the participants in the coming 2 days. This is a great opportunity. I would say that I am grateful to our Joint Secretary, our Indian Institute of Science, for gathering together the best minds in the country, and that they are all gathered for a day and a half. So it is a sufficient time where there can be exchange of ideas, sharing of best practices, networking, and preparing for future partnerships. Due to a very important engagement at the level of Government of India, I could not join this workshop, and I believe that the loss is entirely mine. But I shall be joining in some of the sessions as time permits, and I would like to learn as much as I can from this workshop, so that whatever are the key learnings, we can carry it forward and make sure that this workshop becomes the foundation for transformation of robotics in the country. Now at the end, I would like to again express my deep gratitude to CMTI, Indian Institute of Science, the organizing committee, for their complete participation, guidance, coordination in making and assembling together such a wonderful panel that we have today. I extend my heartfelt best wishes for a very fruitful and a very meaningful deliberations in this workshop. Thank you very much. Jai Hind.
रोबोट्स के महत्व के बारे में सुंदर रूप से बताने के लिए आपका बहुत बहुत धन्यवाद महोदय। अब मैं श्री गोविंदन रंगराजन, निदेशक IISc से सभा को संबोधित करने का आह्वान करती हूँ।
Pressed that by mistake. Okay. Honorable Minister, Ministry of Heavy Industries, Honorable Minister of State, Ministry of Heavy Industries, Secretary, MHI, Conjoint Secretary, MHI, and other dignitaries. It's an honor for me and a pleasure to be here. And this is a very important event for the country. And it's apt that this event is being organized by IAC and CMTI under the aegis of MHI. This is very essential because robots are becoming a necessary capital good. And as mentioned by both the Joint Secretary and the Secretary, the Make in India and Atmanirbhar Bharat are crucial platforms these days on which the progress of the country is based on. So therefore, the support for this area is also very critical. And we also see that it is essential. It is because the penetration of robots in the Indian industry is rising. Also today, robots in the form of cobots are also finding applications in the domains of education, healthcare, service and retail sector. For example, in Japan, many old people, they don't find any caregivers, and the caregiving is given by robots. So they treat them as companions, not just as tools. That is what we are evolving to. Of course, we are a young nation, age-wise, but still, ultimately, we'll also get there, where there'll be a lot of old people. And so it's going to be very critical. And not just that, even in healthcare, right now we have the problem that we don't have enough skilled doctors. So maybe robots can plug in that gap by providing a physical presence to the doctor in examining the patient. So all these things can be done through haptics and so on once you have the robot in place. So I think it is important that we pay important attention to this area, even though, of course, it is organized by MHI. I would also say one should not neglect the research part of it. It should not just be manufacturing robots. Without the intelligence, the robots are useless. So, they'll just be hammers without the intelligence endowed by the research. So I think it's good, for example, machine learning algorithms like reinforcement learning are very critical in making robots very functional and agile. It's also not just, artificial intelligence in general helping robots function better and giving them intelligence, but it's also the other way. There is yet another way of thinking about artificial intelligence, which says that just by training these algorithms on mountains of data, a lot of all the text and so on is not going to help. What is missing is the sensory information. That is how children learn about the world. So how do you incorporate the sensory information in these artificial intelligence systems? And the natural way to do that would be through robots. The artificial intelligence system relies on the robots to gather information about the world around it, and then acquire that experience of living in a physical world. So that may be a very critical piece in case artificial intelligence is really, taking a very prominent role in this world. So I think it's a two-way street. Artificial intelligence, of course, helps robotics, but robotics also, I think, would help artificial intelligence in a big way
by providing the sensory inputs to the artificial intelligence systems. So I think we need to, as I said, pay importance to all aspects: research, development, training. We have an MTech in robotics, so we also contribute our might to developing human resources for this. And more importantly, we need to develop indigenous systems, software systems, and hardware systems in the country. Here, of course, given the great emphasis laid by the Honorable PM on Startup India, I'm sure the startup ecosystem will play a big role in taking this forward. IC has several groups across departments working on cutting-edge problems in robotics, such as flexible robotics, cobots, vision and AI, and mobile robots. So all these are expertise that can be made available to anyone who's willing to collaborate with us. And whether it is a heavy industry or a startup, whatever, whoever is interested will be very happy to collaborate and help. So with this, let me conclude by saying I hope this event will come up with a plan for the country to further progress in this very important area. And I hope you have a very productive meeting. Thank you.
Thank you, sir, for stressing on the importance of artificial intelligence and sensory information, and emphasizing on how the Startup India will play a bigger role in the development of the country. अब मैं माननीय राज्य मंत्री भारी उद्योग मंत्रालय भारत सरकार से सभा को संबोधित करने का अनुरोध करती हूँ।
आज के इस कार्यक्रम के मुख्य अतिथि आदरणीय डॉक्टर महेंद्रनाथ पांडे जी, केंद्रीय भारी उद्योग मंत्री, मंत्रालय के सचिव श्री कामरान रिजवी जी, संयुक्त सचिव श्री विजय मित्तल जी, IISc के डायरेक्टर प्रोफेसर गोविंदन रंगराजन जी, CMTI के डायरेक्टर डॉक्टर नागा हनुमय जी, आज के कार्यक्रम में उपस्थित विशिष्ट अतिथिगण, सम्मानित प्रतिभागियों, देवियों और सज्जनों, मैं आज CMTI और IISc के सहयोग द्वारा आयोजित रोबोटिक्स पर राष्ट्रीय सम्मेलन में आपके समक्ष उपस्थित होकर सम्मानित महसूस कर रहा हूं। यह सम्मेलन विशेषज्ञों, शोधकर्ताओं और उद्योग अग्रणियों को ज्ञान साझा करने, विचारों का आदान प्रदान करने और भारत में रोबोटिक्स के भविष्य की परिकल्पना करने के लिए एक अनूठा अवसर प्रदान कर रहा है। भारत अपने कुशल श्रमशक्ति और समृद्ध विनिर्माण विरासत के लिए विश्वविख्यात है और रोबोटिक्स को भी खुली विचारधारा से अपनाया है। देश को उत्पादकता, दक्षता और गुणवत्ता मानकों में सुधार के लिए स्वचालन यानी ऑटोमेशन की अपार क्षमता का एहसास है। रोबोटिक्स ने विनिर्माण के एक नए युग का मार्ग प्रशस्त किया है, जहां मानव श्रमिक और मशीनें आपसी सहयोग से अधिक सुव्यवस्थित और प्रतिस्पर्धी उद्योग बनाने में कारगर साबित हो सकती हैं। यह सम्मेलन आर्थिक विकास को संचालित करने, उत्पादकता बढ़ाने और हमारे नागरिकों के जीवन की गुणवत्ता में सुधार लाने के लिए रोबोटिक्स की शक्ति का भरपूर उपयोग करने की हमारी प्रतिबद्धता का प्रमाण है। रोबोटिक्स में हाल ही के वर्षों में कृत्रिम बुद्धिमत्ता, मशीन लर्निंग और सेंसर प्रौद्योगिकियों में प्रगति के लिए बहुत तेज वृद्धि देखी गई है। रोबोट ने विनिर्माण, स्वास्थ्य सेवा, कृषि, पर्यावरण व संचालन जैसे कई उद्योगों में अभूतपूर्व परिवर्तन लाया है। रोबोटिक्स ने हमारे काम करने के तरीकों में और हमारे आसपास की दुनिया को समझने के तरीके में क्रांति ला दी है। इस सम्मेलन का विषय विनिर्माण में रोबोटिक्स, विनिर्माण क्षेत्र में स्वचालन और रोबोटिक्स के बढ़ते महत्व को दर्शाता है। यह विनिर्माण उद्योग में दक्षता, उत्पादकता और प्रतिस्पर्धा बढ़ाने के लिए रोबोटिक्स की परिवर्तनकारी क्षमता के प्रति हमारी प्रतिबद्धता को दर्शाता है। यह सम्मेलन रोबोटिक्स में ज्ञान का आदान प्रदान करने सर्वोत्तम प्रथाओं को साझा करने और उन अभिनव अनुप्रयोगों का प्रदर्शन करने के लिए एक मंच प्रदान करता है जो विनिर्माण परिदृश्य को नया आकार दे रहे हैं। इस विषय के माध्यम से हम सहयोग और प्रकृति को प्रेरित करने का लक्ष्य रखते हैं जो डिजिटल युग में विनिर्माण के भविष्य का आकार देगा। भारी उद्योग मंत्रालय अपनी कैपिटल गुड्स स्कीम के तहत विश्व स्तर पर प्रतिस्पर्धी विनिर्माण क्षेत्र बनाने के लिए कई पहल कर रहा है। 25 जनवरी 2022 को योजना के चरण 2 के शुभारंभ के साथ यह कहना सुरक्षित होगा कि इस योजना के रोबोटिक्स, स्मार्ट मैन्युफैक्चरिंग और उद्योग 4.0 के क्षेत्र में निवेश करके तेजी से तकनीकी उन्नति का मार्ग प्रशस्त किया है। योजना के चरण 1 के तहत MHI ने कुल 33 परियोजनाओं को क्रियान्वित किया है। इनमें से 2 परियोजनाएं AMTDC IIT मद्रास द्वारा सेंटर ऑफ एक्सीलेंस और PSG कॉलेज कोयम्बटूर द्वारा सेंटर ऑफ एक्सीलेंस रोबोटिक्स के क्षेत्र से संबंधित थी। योजना के चरण 2 के तहत MHI ने IISc बेंगलुरु द्वारा कैमरास एक्सेलेटर, AMTDC IIT मद्रास द्वारा इंडस्ट्री एक्सेलेटर और शास्त्रा विश्वविद्यालय तंजौर द्वारा इंडस्ट्री एक्सेलेटर जैसी परियोजनाओं को मंजूरी दी है। रोबोटिक्स के लिए विशेष ज्ञान और प्रशिक्षण की आवश्यकता होती है। इस संबंध में MHI ने स्मार्ट एंड एडवांस मैन्युफैक्चरिंग एंड रैपिड ट्रांसमिशन हब उद्योग केंद्रों को स्थापित किया है जो रोबोटिक्स के और स्वायत्त प्रौद्योगिकियों के लिए अगली पीढ़ी के उन्नत विनिर्माण क्षेत्र में लोगों को प्रशिक्षित करते हैं। इन केंद्रों में उद्योग 4.0 के माध्यम से प्रशिक्षण और कौशल कार्यक्रम की सुविधा उपलब्ध है। इसमें CMTI, CIFC, IIT, CIFC, IISc बेंगलुरु में और CIFC समर्थ उद्योग टेक्नोलॉजी फोरम SUTF C4I4 पुणे में शामिल है। मैं उन सभी प्रतिभागियों, आयोजकों और प्रायोजकों के प्रति आभार व्यक्त करता हूं जिन्होंने इस सम्मेलन को संभव बनाया है। मुझे विश्वास है कि इस आयोजन के दौरान साझा किए गए ज्ञान, भागीदारी और सम्मेलन के दौरान उत्पन्न विचार भारत में रोबोटिक्स के भविष्य को आकार देंगे। सभी का धन्यवाद और साथ ही में सम्मेलन में 2 दिनों के दौरान आप सभी के लिए एक सफल और प्रेरणादायक सत्र की कामना करता हूं। बहुत बहुत धन्यवाद।
सुंदर संबोधन के लिए आपका बहुत बहुत धन्यवाद। अब मैं हमारे मुख्य अतिथि माननीय मंत्री महोदय डॉक्टर महेंद्र नाथ पांडे, भारी उद्योग मंत्रालय, भारत सरकार से सभा को संबोधित करने का अनुरोध करती हूँ।
आज भारत और दुनिया के सुविख्यात तकनीकी के एक बड़े केंद्र के रूप में बेंगलुरु शहर में आयोजित रोबोटिक्स सम्मेलन के इस बहुत ही महत्वपूर्ण मौके पर वहां पर इससे जुड़े हमारे माननीय ऑनलाइन जुड़े माननीय राज्य मंत्री भारी उद्योग एवं ऊर्जा श्री कृष्णपाल गुर्जर जी, विभाग के सचिव श्री कामरान रिजवी जी, बेंगलुरु में उपस्थित होकर सहभागिता दे रहे हमारे संयुक्त सचिव श्री विजय मित्तल जी, वहाँ पर अभी प्रोफेसर गोविंदन रंगराजन जी, निदेशक IISc, डॉक्टर नाग हनुमैया, निदेशक CMTI, श्री विजय कृष्णन वेंकटेशन, अध्यक्ष CII कर्नाटक, प्रोफेसर अमरीश चक्रवर्ती IISc बेंगलोर, श्री विजय प्रताप सिंह CEO सीमेंस मोशन कंट्रोल और सभी विद्वत पैनलिस्ट और विद्वत उसमें प्रदर्शनकर्ता सभी सहभागी। आज मुझे बेहद प्रसन्नता है आप सबसे जुड़ने पर। आज यहाँ पर विजय मित्तल जी ने अपने दायित्व की मर्यादा के नाते हम सब वहाँ प्रत्यक्ष, आज हम और MOS और रिजवी साहब जुड़ने वाले थे। हम सब आप सबसे मिलकर बेहद खुशी का अनुभव होता, लेकिन उन्होंने मित्तल जी ने दायित्व की मर्यादा से हम लोगों के अपरिहार्य कारणों का उल्लेख किया। मैं चूंकि इतना महत्वपूर्ण सम्मेलन है, हम सबकी प्रत्यक्ष उपस्थिति हम सबकी भी प्रबल इच्छा थी, लेकिन हम और रमेश रिजवी साहब आज देश में मंत्रिपरिषद की अत्यंत अपरिहार्य बैठक होने के कारण आज आपके भी प्रतिभाग नहीं कर पा रहे हैं। इस नाते से आप सबको ऑनलाइन हम सब अपनी शुभेच्छा और अपने विचार निवेदन कर रहे हैं। आज के सम्मेलन की शुरुआत बहुत ही बेहतर दीप प्रज्वलन के समय जिस परम ब्रह्म की सृष्टि में, चाहे भारत हो या दुनिया के कोई देश हो, जहाँ अरुण की लालिमा से जो वो सृष्टि शुभारंभ होती है, उसकी वंदना से इतना महत्वपूर्ण सम्मेलन शुरू हुआ। हम सबको बहुत ही प्रेरक रूप से यह सदैव उत्साह भी बढ़ाएगा, स्मरण भी रखेगा। सभी विशिष्ट अतिथि, सम्मानित प्रतिभागियों, दिव्यांग सज्जनों, आज टेक्नोलॉजिकल रूप में हम सब यहाँ उपस्थित हैं और यहाँ जिन चीज़ों पर आज हम चर्चा कर रहे हैं उसमें आईआईएससी बेंगलोर और प्रौद्योगिकी संस्थान, हमारा जो केंद्रीय मैन्युफैक्चरिंग प्रौद्योगिकी संस्थान CMTI के सहयोग से भारी उद्योग मंत्रालय द्वारा आयोजित ये जो कार्यक्रम है, ये अद्वितीय तकनीकी कौशल प्राप्त करने और विनिर्माण पद्धतियों में क्रांति लाने में अत्यंत उस दिशा में महत्वपूर्ण उपलब्धि साबित होगा। भारत सरकार हमारी अर्थव्यवस्था को वैश्विक रूप से अग्रणी बनाने की दृष्टि से प्रमुख विकास क्षेत्रों में रोबोटिक्स और आर्टिफिशियल इंटेलिजेंस की पहचान की है। रोबोटिक्स मैन्युफैक्चरिंग में स्वचालन और दक्षता लाता है, जो भारतीय उद्योग को अनेक तरीकों से सशक्त बना सकता है। रोबोट अपनी बेजोड़ परिशुद्धता से गति और निरंतरता के द्वारा उत्पादकता में वृद्धि और त्रुटियों को कम करते हैं, साथ ही वे संसाधन का समुचित उपयोग करते हैं। इससे उत्पादन में नेचुरली आप सब जानते हैं वृद्धि भी होती है, लागत भी कम आती है और मैन्युफैक्चरिंग में जो एक कंपटीशन है वो प्रतिस्पर्धात्मक हमारी बढ़त को भी वो प्रदान करता है। आज इस रोबोटिक को अच्छी तरह से अपनाया जाए तो भारत अन्य देशों की तुलना में बहुत ही आगे बढ़ सकता है। यह सम्मेलन उद्योग विशेषज्ञों और शोधकर्ताओं और नीति निर्माताओं को एक साथ लाने और संपूर्ण ज्ञान को साझा करने और एक सहयोगी दृष्टिकोण का पता लगाने के लिए एक अनूठा अवसर प्रदान करेगा, एक अनूठी सोच प्रदान करेगा। इस सम्मेलन के विचारों के आदान प्रदान और अभूतपूर्व अनुसंधान का प्रदर्शन करने, आने वाली चुनौतियों और अवसरों के बारे में विचार विमर्श करने के लिए निश्चित तौर से एक बहुत ही महत्वपूर्ण उपयोगी मंच है आज है। मैं सभी प्रतिभागियों को, सभी पार्टिसिपेंट्स को इस सम्मेलन के दौरान सत्रों, कार्यशालाओं, विचार विमर्श में सक्रिय रूप से संलग्न होने के लिए अपनी ओर से भी उनको निवेदन और उत्साहवर्धन करता हूँ, प्रोत्साहन करता हूँ। आइए हम सब सहयोग को बढ़ावा देने, साझेदारी को विकसित करने और हमारे मैन्युफैक्चरिंग क्षेत्र की बेहतरी के लिए रोबोटिक्स और स्वायत्त प्रणालियों की क्षमता का उपयोग करने के मार्गों का जो निर्धारण करना है, जो अपना वेग डिसाइड करना है, उसके लिए इस मंच का सदुपयोग करें, लाभ उठाएं। साथ ही मैं आपसे सीमाओं से परे सोचने की, बहुत सी की संभावनाओं की कल्पना करने का आग्रह करता हूँ, जो हमारे सामर्थ्य में है, जो हमारी क्षमता में है। आइए हम इसके लिए एक सतत, समावेशी और लचीली मैन्युफैक्चरिंग इकोसिस्टम बनाने के लिए इन प्रौद्योगिकियों का लाभ उठाने के बारे में विचार करें, जो केवल हमारे उद्योगों नहीं बल्कि पूरी सोसाइटी को लाभान्वित करेगा। रोबोटिक्स के क्षेत्र की वृद्धि और विकास के लिए तथा अनुकूल वातावरण बनाने के लिए भारी उद्योग मंत्रालय ने अनेक पहलें की हैं। भारतीय रोबोटिक्स इकोसिस्टम ने इसमें हमारे अनुसंधान और विकास की जो प्रणाली हमारी R&D है, कैपिटल गुड स्कीम फेज 1, फेज 2 के तहत मैं विजय मित्तल जी की और उसको सपोर्ट देते हुए रिजवी जी की बातों को जोड़ते हुए आंकड़ों पर नहीं जा रहा हूँ, जिसका उल्लेख डिपार्टमेंट ने जो 1207 करोड़ रुपए से इन स्कीमों को जो सपोर्ट दिया है, डिटेल उसमें मित्तल जी के संबोधन में आ चुका है और रिजवी जी ने डिपार्टमेंट के सचिव महोदय ने उससे अपने को प्लस किया है। और मैं कैपिटल गुड स्कीम के उन फेज 1 में 8 सेंटर ऑफ स्किल एक्सीलेंस, 15 कॉमन इंजीनियरिंग फैसिलिटी सेंटर से एक मशीन टूल पार्क जो कि आपके वहीं कर्नाटक के तुमकुर में स्थित है, उसकी स्थापना की गई है। उसके काम को और प्रगति देने की और उसके चीज़ों को उत्साहवर्धन की आज ज़रूरत भी है। और निश्चित तौर से वो रोबोटिक्स का सम्मेलन कुछ नए रिसर्च और जनरेट करेगा, नए आइडिया जनरेट करेगा, जिससे तुमकुर का जो हमारा पार्क है, हमारी बड़ी महत्वाकांक्षी योजना है, उसको और बल मिलेगा, ऐसा मेरा विश्वास है। आज की इस चर्चा में कैपिटल गुड स्कीम के दूसरे फेज में अभी तक 8 सेंटर ऑफ एक्सीलेंस, 8 इंडस्ट्रीज एक्सीलेटर, 6 टेस्टिंग सर्टिफिकेशन सेंटर की तकनीकी क्षमताओं में वृद्धि, 3 कॉमन इंजीनियरिंग फैसिलिटी सेंटर्स एवं 2 प्रोजेक्ट्स। ये आज की चर्चा में कौशल विकास के क्षेत्र में 46 कौशल स्तर के लेवल 6 क्वालिफिकेशन पैक के एवं उससे ऊपर के क्वालिफिकेशन पैक्स को बनाने के लिए अनुमोदित किए गए हैं और इससे हम लोगों ने स्किल मिनिस्ट्री के संग भी इसको कोऑर्डिनेट किया है। मैं इन आंकड़ों के इन तथ्यों को देना इसलिए जरूरी समझता हूँ कि आप इस की रोशनी में अपनी चर्चाओं में निश्चित तौर से मूल्यवान सुझाव और मूल्यवान आइडियाज देंगे। इन प्रोजेक्ट्स के लिए ये खुशी की बात है कि गवर्नमेंट ने जो चीज़ें बनाई 80% हम सपोर्ट करते हैं, 20% इंडस्ट्री फ्रेंडली पार्टनर्स करते हैं और इसमें लोग आगे आए भी हैं, जैसे हमारे किर्लोस्कर ग्रुप्स, विप्रो 3D, लक्ष्मी मशीन वर्क्स, ज्योति CMNC, HMT मशीन टूल्स, ऐसे डिजाइनर्स लिमिटेड, इनके द्वारा अनेकों भारतीय कंपनियां, मैं उनको धन्यवाद के साथ स्कीम में जुड़ने के लिए और उत्साहित करता हूं और उनको और बेहतर आमंत्रण करता हूं। इस स्कीम के तहत रोबोटिक्स के लिए की गई नई पहलों में कैमरस एक्सीलेटर ISC बेंगलुरु में, AMTDC IIT मद्रास में, मशीन टूल्स एंड प्रोडक्शन ऑफ सेंटर ऑफ एक्सीलेंस PSC कॉलेज ऑफ टेक्नोलॉजी कोयम्बटूर में, सेंटर ऑफ एक्सीलेंस शास्त्रा विश्वविद्यालय तंजौर में, प्रौद्योगिकी विकास के लिए इंडस्ट्री एक्सीलेटर शामिल है। ये संस्थान मुख्यतः रोबोटिक्स और उनकी प्रणालियों के आधार पर नई प्रौद्योगिकियों को विकसित करने के लिए सक्रिय रूप से काम करते हैं। मैं एक एग्जाम्पल इसमें जोड़ना चाहूँगा। अभी हमारे HMT ने अभी हाल में, जिसको हम सबका सौभाग्य रहा कि माननीय प्रधानमंत्री श्री नरेंद्र मोदी जी के कार्यक्रमों से वो स्कीम वाराणसी में IIT BHU से कोऑर्डिनेट करके लॉन्च की गई, मशीन टूल्स डिजाइन पर सेंटर ऑफ एक्सीलेंस जो IIT BHU के संग HMT द्वारा मंत्रालय की कैपिटल गुड स्कीम में विकसित की गई है। इसके लिए इसमें जो चीज़ें आने वाली है, मैं सारे जो प्रोजेक्ट्स हैं उस पर डिटेलिंग जाके एक ताज़ा जो हम लोगों ने शुरू किया उसका थोड़ा सा आपको रोशनी डालना चाहूँगा सारे पैनलिस्ट के सामने, सारे इसमें विशेषज्ञों के सामने और अनेक सम्मानित रंगराजन जी जैसे अन्य विजय कृष्ण जी से विद्वान लोग वहाँ हैं, उनके बीच के हैवी ड्यूटी CNC हॉरिजॉन्टल बोरिंग और मिलिंग मशीन के लिए रैम टाइप फ्लोर डिजाइन एंड सेकेंड व्हील हेड ट्रेवर्स टाइप के साथ CNC हैवी ड्यूटी रोल ग्लाइडिंग मशीन और तीसरा रोलिंग स्लाइडिंग संपर्क में घर्षण का मापन। ये 3 डिजाइनों के लिए अभी हम लोगों ने ये जो हाल में किया। मैं ये बताने के पीछे आपको ये जितनी चीज़ें हैं, ये अगर ये कुल प्रोजेक्ट, ये जो 45 करोड़ का ये प्रोजेक्ट है, अगर 2030 तक ये प्रोजेक्ट अगर कंप्लीट होके और अपने उपयोग में सार्थक होता है तो आप कल्पना करिए देश को कितना बड़ा लाभ इसमें मिलने वाला है कि ये अपने आप में अपने लगभग 50 मिलियन अमेरिकी डॉलर का आयात कम करेगा। ये आत्मनिर्भर भारत की जो माननीय मोदी जी की परिकल्पना है उसमें ये मशीनें हम भारत में विकसित करेंगे। तो ये इतनी बड़ी ये सोच डेवलप हो रही है और आपका सम्मेलन उसमें प्लस करेगा। और इन सब चीज़ों पर मैं आप सबसे जो चर्चा शेयर कर रहा था, इसमें हम आपका आह्वान करते हैं, आइए हम सब मिल करके सरकार, उद्योग, शिक्षा जगत को एक मंच पर लाएं और एक संपन्न सिस्टम, एक बिल्कुल कॉम्पिटेंट सिस्टम का निर्माण करें जो अनुसंधान को बढ़ावा दे और हमारे कार्यबल को सशक्त बनाए और भारत को वैश्विक मैन्युफैक्चरिंग उत्कृष्टता में अग्रणी बनाए। मैं आशा करता हूँ आने वाले कुछ वर्षों में रोबोटिक्स और ऑटोमेशन का ऐसा इकोसिस्टम तैयार होगा जिससे माननीय श्री नरेंद्र मोदी जी का जो वर्ष 2047 तक 100 वर्ष आज़ादी के जब भारत पूरा करेगा, उस समय एक विकसित देश बनाने का जो सपना है, जो हमारे विजन लीडर ने, अब तक लोग सरकारें एक परंपरागत चलाते थे, लेकिन मोदी जी सरकार को बेहतर चलाने के साथ इंफ्रास्ट्रक्चर हो, गरीबों की भलाई हो, सरकार के लिए नए नए कॉन्सेप्ट हो और प्लस विजन देना। लीडर का मतलब केवल सरकार मात्र चलाना नहीं है, विजन देना। उस विजन में आज की जो युवा पीढ़ी है, 2047 तक हम दुनिया के वैश्विक मंच पर कैसे आ सकते हैं। मैं आपको आज से सीधा जुड़ा विषय नहीं है कि लेकिन मैं आपको छोटा सा एग्जांपल दे रहा हूं। अभी माननीय मोदी जी ने वाइब्रेंट विलेज का एक प्रोग्राम दिया है। मैं यहाँ सभी यंग जेंट्रिन्स हैं और सभी सीनियर प्रोफेसर हैं, उनके पास अपनी व्यवस्थाएं हैं, संभव नहीं है सभी देश की सीमाओं पर जा सकते। हम मंत्रीगण वाइब्रेंट विलेज में जा रहे हैं और खास करके चाइना से जुड़े गाँव के जो 19 जिले 19 जिलों को चिन्हित किया गया है। और क्या विजन है हमारे प्रधानमंत्री का कि देश की सेना, देश के आईटीबीपी के जवान, बीएसएफ के जवान और ये सब तो देश की सीमाओं पर खड़े हैं, लेकिन 1 किलोमीटर 2 किलोमीटर 10 किलोमीटर की दूरी पर जो 1000 500 600 ये जो नागरिक वहां निवास करते हैं, वो भी भारत के सैनिक है। केंद्र की हर योजनाएं, राज्यों की हर योजनाएं उनके पास पहुंचनी चाहिए और उनके पास जा करके हमें उन्हें मॉरल सपोर्ट देना है कि पूरा देश आपके साथ खड़ा है, क्योंकि आप एक प्रतिस्पर्धी और अत्यंत मायावी देश के सामने सीमा पर डटे हुए हैं। लेकिन मैं इन बातों का उल्लेख इस विद्वानों के सम्मेलन करने के पीछे जो मेरा हेतु है, मेरा उद्देश्य है, वो ये बात प्रत्यक्ष शेयर करना है कि वहां पर जो चीजें आज से 10 साल पहले 20 साल पहले होनी चाहिए थी, वो आज मोदी युग में हो रही हैं। वहां सड़कें, वहां पुल, वहां पुलिया, वहां हर प्रकार की फैसिलिटीज, और कॉमन पीपल फील कर रहा है कि चाइना के टक्कर में हम आज वहां खड़े हैं और मजबूती से आगे बढ़ रहे हैं। तो ये मैं बात इसलिए शेयर कर रहा हूं कि जिस नेता का सोच ऐसा है, वही आप जैसे विद्वानों के माध्यम से 2047 में भारत को विकसित भारत की परिकल्पना कर रहा है और उस परिकल्पना को साकार करने के लिए आप जैसे लोगों का आज का यह सम्मेलन सबसे उपयोगी हो सकता है, ये ऐसा मेरा विश्वास है। तो मैं आज आप सबको अभी हाल में मैं आप सबको अवगत करना चाहूंगा कि स्वयं माननीय मोदी जी ने अभी 30 जुलाई को दिल्ली विश्वविद्यालय के अंदर एक शताब्दी समारोह जो था, उसमें उन्होंने स्वयं जब एजुकेशन के बहुत से विषयों को फोकस करते हुए रोबोटिक्स को बहुत बल दिया। उन्होंने कहा कि रोबोटिक्स आज हमारी शिक्षण व्यवस्था का सबसे इंपॉर्टेंट पार्ट है और रोबोटिक्स इज नॉर्मल नाउ। आज रोबोटिक्स प्रयोग में आम रूप से हो रहा है। मोदी जी ने अभी हाल में जो बड़ा सक्सेसफुल मोदी जी का अमेरिका का दौरा हुआ, उस अमेरिका के दौरे में मोदी जी ने आर्टिफिशियल इंटेलिजेंस तथा रोबोटिक्स पर भारत और अमेरिका के बीच सारी संभावनाओं पर चर्चा किया और इस उनकी चर्चा का प्रतिफल है कि ये निरंतर विशेष बल दिया ताकि दोनों देश इस पर साथ साथ कार्य करने की सोच डेवलप करें। दोनों देश के एक विकसित लोकतंत्र अमेरिका और एक विकसित के साथ साथ बड़ा लोकतंत्र भारत, दोनों देश मिल करके इस पर लगातार सोच डेवलप करें। अभी हाल के सक्सेसफुल अमेरिकी दौरे में मोदी जी ने बल दिया। तो अंत में मैं आज आप सबके विचारों से अपने को जोड़ते हुए और मेक इन इंडिया और आत्मनिर्भर भारत का कंसेप्ट देना, और केवल कंसेप्ट देना नहीं, सारी पॉलिसीज पर एक्ट करते हुए, प्लानिंग करते हुए, पूरी सरकार की सामर्थ्य का उस पर फोकस करके इसको एग्जीक्यूट करते हुए, डिलीवर करते हुए जो नरेंद्र मोदी जी का विजन देश को आगे ले जाने का है, उसमें आज का यह सम्मेलन बहुत महत्वपूर्ण पड़ाव और देश की मंजिल को सफलता की तरफ ले जाने का बहुत सहायक सिद्ध हो सकता है। इस विश्वास के साथ अंत में आज आपकी उपस्थिति के लिए आप सभी को धन्यवाद देते हुए, आपकी प्रतिबद्धता और उत्साह और तकनीकी प्रगति को अपनाने और मैन्युफैक्चरिंग क्षेत्र में प्रगति लाने के प्रति आपके समर्पण को यह दर्शाता है कि आप कितने कटिबद्ध हैं। आइए हम सम्मेलन का अधिक से अधिक लाभ उठाएं और एक दूसरे को प्रेरित करें और भविष्य की दिशा में नए रास्ते बनाएं, जिससे रोबोटिक सिस्टम हमारे उद्योगों को और ऊंचाइयों पर ले जाए। और भारी उद्योग मंत्रालय आप सभी इसके विशेषज्ञों के साथ प्रतिपल प्रतिक्षण आपके संग खड़ा है। आपके सुझाव, आपके जो निष्कर्ष, आपकी जो चर्चाएं आज उसमें आएंगी, उन चर्चाओं के जो सार तत्व निकलेंगे उस पर हमारा मंत्रालय सक्रिय रूप से सपोर्ट के साथ काम करने को वचनबद्ध है। इन्हीं शब्दों के साथ आप सबको बहुत बहुत धन्यवाद, साधुवाद देते हुए शुभकामनाओं के साथ सभी को बहुत बहुत नमस्कार।
A treat to the eye and food for the mind. सामर्थ केंद्रों, एमएचआई एसोसिएटेड संस्थानों, विभिन्न भारतीय स्टार्टअप द्वारा विकसित रोबोटिक्स और ऑटोमेशन सिस्टम पर आधारित प्रदर्शनी के उद्घाटन का समय आ गया है। प्रदर्शनकर्ताओं में शामिल है सामर्थ सेंटर, विज, एसएमडीडीसी सीएमटीआई, आईआईएससी, सेंटर फॉर इंडस्ट्री 4.0 लैब्स पुणे, AIA Foundation for Smart Manufacturing, IIT Delhi, COE in Advanced Manufacturing Technology, IIT Kharagpur, MHI Associated Institutes, AMTDC, IIT Madras, BHEL, Capital Goods and Strategic Skill Council, Indian startups, companies associated with Art Park, iHub, IISC, Gati Robotics, Chirat Robotics, Vishwa, Algofet, Comrado Aerospace, and UAVIO Labs, and Indian industries who are working on robotics like Swaya Robotics, Ati Motors, M2 Next Solutions PVT Limited, Fronis India PVT Limited, Autobots, and also we have a stall for robotics competition. अब मैं हमारे मुख्य अतिथि श्री माननीय मंत्री महोदय डॉक्टर महेंद्र नाथ पांडे, भारी उद्योग मंत्रालय, भारत सरकार से अनुरोध करती हूं कि वे प्रदर्शनी का औपचारिक रूप से उद्घाटन करें एवं प्रदर्शनी में मौजूद स्टॉलों का वर्चुअल आभासी अवलोकन करने का आह्वान करती हूं।
वीडियो जूम आउट कर।
Thank you. I would like to mention here that robotic competition stall is also being exhibited in the exhibition, and presentation of robotics competition will take place in parallel at MNP building, seminar hall with demonstration. अब समय है धन्यवाद प्रस्ताव का। इसके लिए मैं श्री नागा हनुमैया, डायरेक्टर CMTI, को मंच पर आने का आह्वान करती हूँ।
आप सभी का ये 2 दिन का सम्मेलन में आप सभी का स्वागत करता हूं। माननीय मंत्री जी डॉक्टर महेंद्र नाथ पांडे जी, कृष्णपाल गुर्जर जी और हमारा मंत्रालय का सचिव कामरान रजवी जी, सह सचिव विजय मित्तल जी, मैं धन्यवाद करता हूँ आपको CMTI को अपॉर्चुनिटी दिया ये कॉन्फ्रेंस को होस्ट करने के लिए। हम बहुत खुश होते थे आप अगर इधर फिजिकली अटेंड किया होता, आपका मार्गदर्शन मिलता होता, बट ये कॉन्फ्रेंस ऑर्गेनाइज करने के लिए बहुत सारे मार्गदर्शन अलग अलग तरफ से हमको मंत्रालय से मिला हुआ है। हम CMTI की तरफ से धन्यवाद देता हूँ। प्रोफेसर Govindan Rangaraj and Professor Amrish and Professor Gurumurthy from IISc, they contributed significantly to organize this event, and thanks for accepting to host this conference jointly with CMTI at CMTI campus. So my sincere thanks to IISc colleagues. And we already know that robotics is no longer is an automation tool. Robotics being used as a capital goods, assistive robots, service robots. It is not surprise if a robot we find in our kitchen soon. All these associated with a lot of technology on various aspects, not only on the design, electronics, controls, then intelligence systems. In order to discuss, deliberate this, we are fortunate, or I convey my sincere thanks to all the panelists and speakers who have accepted our invitation to be a panel and share your experience in this occasion. And at the same time, I also convey my sincere thanks to all the industry colleagues, academic friends, research institutes, researchers, both scientists and some of the PhD students have joined this conference. But last not but the least, that is the idea is the competition. So competition we organized in parallel. There are about 49 entries, and that clearly shows that there is a lot of emphasis on interest amongst the professionals, both in academia as well as in industry. My sincere thanks to participate in this competition. Then at the end, my sincere thanks to my MHI colleagues who spent last 3 days with us and look at all the details and guide us with my core team, CMTI core team, who coordinated several activities. I convey my sincere thanks to all the coordinators of subcommittees, and then the committee led by my colleague Prakash Vinod. So my sincere thanks to you for hosting this conference. I hope these 2 days deliberations will definitely, it is not a learning platform, but it also is a networking platform, as our all ministers and our secretary has already said that there is a need of cooperation and collaboration amongst all the professionals who are connected to manufacturing and automation. I think that is where then only we can able to reach to the Atmanirbhar, which is as vision set by our Honorable Prime Minister, Dr. Narendra Modi ji. So thank you all. And once again, मैं हमारा मंत्री महोदय और सचिव साहब सबको धन्यवाद देता हूँ। थैंक यू वेरी मच।
सुंदर धन्यवाद ज्ञापन के लिए आपका बहुत बहुत धन्यवाद सर। I thank Shri Vijay Mittal, Joint Secretary MHI, and Professor Govindan Rangarajan, IIC Bangalore, for their presence, and I request them to kindly occupy the seat in the reserved lounge to view the next part of the program.
चल गया भाई,
चल गया, हो जाएगा ना। of the robotic technology, and the other comes from Siemens, which is one of the providers for the technology. So we listen to both ends of the spectrum of the ecosystem of robotics in manufacturing. And after lunch, we are going to have a number of panel discussions. There are 5 panel discussions, 4 today and 1 tomorrow. The first one is on robot as capital goods. Robots as capital goods is something that has become essential now almost in every factory floor, and what are the challenges and opportunities and how to lead that is the topic. Second panel is on human-cobot collaboration. Collaborative robots have become a reality and increasingly at the shop floor working with humans. So in what way can India leverage the use of robots both for and in skilling and collaborative activity in this area? We will have a panel discussion also on network enabled manufacturing, particularly the technologies that are enabling that to happen. How do we network better, faster, cheaper, particularly using 5G, including the technology of robots. The fourth panel discussion is on robotics in defense, another very important area. And there we have very distinguished panel, just as in all other panels, to discuss this, bringing in all the stakeholders in this important area. And then after that, we will be proceeding to the hotel and for dinner, Hotel Sheraton Grand. And the following day, we'll start with the panel discussion, the last one, on robot as product, which is something that is becoming ubiquitous, from warehousing to assistive robots. And then after a break, we'll have the competition where a large number of companies and startups and academic startups and researchers are competing. And with that, we'll be concluding the conference. So that's a very brief overview, and I look forward to having very interesting interactions in all of them. Thank you.
Thank you, sir, for the very beautiful and detailed overview of the conference. Now, information is not knowledge. The only source of knowledge is experience. So you need knowledge to gain wisdom. This was a saying by Albert Einstein. So let's listen from the stalwart in their field. We have 2 invited talk for this event. Now, I would request Shri Vijay Krishnan Venkateshan, Chairman, CII Karnataka, MD, Kennametal, to deliver the first invited talk on industry perspective on robotics. Sir.
Good afternoon. Firstly, let me thank the organizers of this event and CMTI for inviting me to this event. It was interesting to listen to the last 1 hour, especially from the ministry officials and the minister himself in terms of perspectives and their outlook for the robotics industry. And it's very appropriate to talk about robotics. Well, we always talk about robotics as part of today's, I would say, evolving manufacturing competencies in India. It's no longer a technology which is like far out. We today talk about as the integrated part of any capital cycle, what we do. What I thought, given it's 20 minutes, I'll probably speak for 15 to 18 minutes. Try and connect some dots on how, as an industry leader, we look at investing in robotics and when do we do that. But before that, what I want to do is talk about a little bit about Indian economy, touch upon the relevance of the growth of manufacturing sector in India to drive the GDP growth, then come to how industries look at when do we look at robotics and automation, what are the goes, no-goes when we look at personally, and what makes us decide to go for such kind of robotics. So that, and I'm going to speak mostly from a user perspective. I know today it's, if somebody of you or most of you might have read the comics Tintin, like Thompson and Thompson, we have Vijay and Vijay on the panel. So we have 2 Vijays on the panel today.
When we look at the economy, all of you know India became the fifth largest economy, and we're expected to become the fourth largest probably in another 5-6 years. And eventually it'll be the third largest and continue to become very large. We are anticipating us to become 30 trillion or $32 trillion economy. Now, when we look at that, one of the fastest growing sectors within that is going to be manufacturing. We are expecting manufacturing to drive a significant amount of growth. Now, I know always when we have a debate, when in the morning when the secretary talked about we have 140 crores population of 1.4 billion, the first thought comes to all our minds is when we talk about automation, when we talk robotics, what about employment? Are we creating employment? Now, I want to again pick from one of the sentences what the secretary spoke in the morning, especially on what are the 5 countries which are leading the robotics adoption. The first one is China, followed by Japan, then South Korea, then Germany, and then United States. Now, if you look at out of the 5 countries, except South Korea, the remaining 4 countries are not small population countries. The US is not a small population country. For Japan, the density of 180 million in a small country is very high. US is 370 million, and China is 1.4 billion. The country which absorbs the maximum robotics today in the world is China. And they became now number 2, but they were number 1 in terms of number of population. So it just answers the question, as I just want to leave with the thought, a country which has progressed so fast, driven by manufacturing economy, created maximum amount of jobs in the world was China, but also they added the maximum number of robots in the country. That should answer all of us how the addition of technology and automation has helped to create jobs, help grow manufacturing sector, help grow the economy in a country. And we are probably a few years behind, and that's what I would allude to in how I would look personally as a head of an organization which has transitioned from using a lot of labor in certain operations to completely robotized, mechanized, automated, modernized lines, just not in India, but also global plants. Now, just to give a little bit of history, there are 2 waves of robotics adoption we have seen in the world. First one was in the 1960s, 70s, when the automotive OEMs moved their welding lines. That was the first wave, which significantly broke into the barriers of what robots can do. And the next wave started in 2010, after several years. The reason for 2010 drive, that's when the robotics industry globally grew at 19% just till COVID. The primary reason was the cost of equipment of robots started coming down. So affordability was easy. Rising labor cost was one driver. Skilled manpower availability became another driver. Turnover of labor became another driver for people, and also requirement of higher quality and consistency. So far I'm talking just global in terms of why the industry grew between 2010 and 2018. Now, when we look at, if I'm basically a mechanical engineer, so when I look at an equipment addition, and I look at, okay, what would a process engineer, what would a manufacturing head, what does a company head look at? The first thing an operations head and an engineering head comes and tells us is, there are 3 things what one would look at. Is it simpler to apply? That means the robot is not complex to understand. It does the operations in a simple manner. So is it simple to apply, and it doesn't need massive change management which is required. The second thing what we look at is it simple to connect? Some of you will know that most of the existing factories where you automate or you add a robo. Now, when you're talking about an addition and not a greenfield project, there are not many greenfield projects which happens in the world. You're talking about, is it easy to connect to the line, connect to the existing processes? That becomes a second question from the operations head or the engineering head. Third one is most important, is it simple to run? You don't want several crores of equipment sitting and nobody in the factory or your office knows how to operate it, and we have to call, just to take a little bit on a lighter note, from like somebody like Siemens, keep calling, or any of the robo suppliers, we don't know how to figure this out, please can you come over? So you want to always have an operations which are very simple to run. So those are 3 which usually we get questions when we are the CEO or the CFO gets questions from the operations head when we are talking about decision to migrate to a robot or an automated line. Now, historically, if you look, where have the robots gone in the industry? The first one, obviously, all of us know, it would be material handling. Second one, as I spoke, was welding. Third was assembly. This is where the maximum concentration of robots have gone into industries. But we talk about industrial robots, like the industry where I come from. I come from a cutting tool industry. It's a little more complex. You don't have long, big assembly lines. You're talking about unique single cell manufacturing. So you talk about standalone robots. So it's a little more complex because you'll buy standalone robots. It's unique because it has to be customized for a line or a customer. So the adoption is always a little slower when we are talking about industrial robots compared to a large lines like welding or paint lines in a car manufacturing plant or an electronics plant like mobiles, where thousands of robots will be in lines after lines together because it's the same repeat jobs what it does. But to talk about general engineering industry, the robot is a very unique application. It could be one standalone doing a very unique job in a complex process. Now, the earlier speakers alluded a little bit to the types of robots from an industrial, as an industry leader and looking at purely industrial manufacturing applications, we see 3 types of robots which have already come into an industry like us. One is the collaborative robots, which we discussed earlier in the day. The second one is mobile robots or automated guided vehicles, which really makes high-speed process lines come through. We do have a plant which has a completely automated guided vehicles with multiple robots speaking to each other through an Industry 4.0 platform. And the whole line operates with a lights out factory concept. This is one of the plants within Kennametal where you don't even lights, you just switch on the program. You have the tool box available for the robots to pick. It picks which job has to be done, and everything is program driven. The robot just moves through railings, all through the plants, and it just picks a tool, picks a job, finishes it, packs it, and sends it out. So we have an extreme example in our own organization where we have done a lights out kind of an automation, 2 basic small automation. And the third one is, while we have not used in our own capability in our factories, but we do know that the manufacturing sector is moving towards what we call the exoskeletons. So that's the other area where the whole industry is moving. Now, coming to specifically as an industry leader, or let's assume as a CEO or a CFO or a head of a company, how does, as an end user, how do you one decide? So I'm going to step back and tell a story because it's exactly at lunchtime and I need to hold all the audience concentration. So I thought I'll tell a story of what I probably heard later in high school or early part of my college days. So the story goes like this. Is actually a story which was told to me. So it's not something I created in the last half an hour. There's a global CEO of a multi-billion-dollar company he's an Indian who comes back to his hometown and to meet his parents. And he was walking the street one day evening and he sees somebody walk in the opposite side of the pavement. A senior gentleman, looks retired, senior gentleman. And for him, it looks okay, he's somebody very familiar. And he walks closer to him and then he realizes that gentleman was his 10th standard maths teacher. And he was a teacher who taught him, who made him aspire. He was his mentor. So he was so thrilled to meet him after so many years. He ran to him. And in all that excitement of explaining to his beloved teacher, he said, I became the CEO of, let's say, $10-12 billion global corporation. I travel around the world. I employ 20,000 people worldwide and all that. And then he gets into more excitement. The teacher doesn't say anything. Then he gets into a story of, I've added the most advanced robots in the world. Each costed me 50 crores. I've added 10 of them. Each robot does what 50 people can do at a time. I don't have to bother. And I showcase this to everywhere. We present case studies on most advanced robots, what we have invested. And we have invested 1,000 crores on those robots in a single plant. So the teacher doesn't react to all that because in his excitement, the CEO is rambling, like still being a student to a teacher, that relationship. So after some time, and this CEO is getting very frustrated. Max teacher is not reacting for a while. So towards the end, he completed the story and frustration, he was like, okay, he's not going to say anything. He paused, the teacher looked at him, didn't smile, nothing. Typical Max teacher teaching a student in 10th. He said, it's nice you have done all this. I have only 2 questions to you. You don't need to answer me, but think about the answer for within yourself. 1, as a CEO, has it helped you to make more money? 2, by adding the robots, have you helped the society? He said again, don't answer me. It's a question you need to answer. Now, why I told this story is 1, to capture your attention. 2 is to explain how as let's say in my position as a head of a company, how do we decide? Technology is very good. As engineers, we get extremely fascinated when we look at robots and what it can do. When reading a white paper, concept notes, we look at expos, we go and see. I have seen robots in my own plant. I get really fascinated with what it does. But finally, one of the most important thing is how does it add value? And does it make sense? That's a question as an end user we always ask. So the things which we go in our mind is, one, does it reduce cost of manufacturing? That's one of the first questions. Or does it add cost? Two, will it improve quality and consistency? Three, will it reduce labor? Will it create unemployment, or it's going to create employment? Because a lot of people believe that the moment you talk about robotics and automation, you're going to downsize. In reality, I haven't seen that happen in my 25 years. What happens is the roles change. Skills have to be changed, but we don't see that we have to let go of people. In the morning, I think there was a mention by the secretary about safe working environment. It's an yes and no answer. There are environments where robots are required to make it a very safe environment. So we eliminate the human intervention in riskier operations, definitely yes. It also, in today's world, some of you here will realize, to attract talent and retain talent, we cannot be having manual processes. Even to attract and retain talent, we need lines which are highly automated, because today's engineers and workmen or women who come into the shop floor would prefer a more automated shop floor. We are moving towards a more diverse and inclusive shop floors today. And it's no more a muscle required physical hard labor. It's mostly programming, and we're expanding. Most factories, when you look, it's extremely diverse. We have equal amount of men and women present in the shop floor, and it needs little more automated factories. So it's all these are factors which are driving. But more importantly, the last one, if India is aspiring as a country to move into a global space, to become somebody who is driving a manufacturing economy and be ready for export market or winning some of the high quality products, we need precision, quality, we need the products to be right at the first time, and more importantly, consistency, which China has proven for the last 2 decades. And that's what we're moving in. That's what drives something like an adoption of robots in most of the manufacturing cells. But some of the pitfalls we have seen over the years of migration, especially last year, 3 years, is when we've added a lot of technology, or what we call the pseudo robots to full robots in our lines, is the migration of skill. It becomes a big roadblock, because you're talking of, you can't let go of people. Let's say somebody has worked with you for 20 years, 25 years, they have 10, 15 years to go still towards their retirement. You have to reskill the workforce, and reskilling becomes a huge task when you're adopting, and this has to be factored in. And I'm not sure how many of you are industry leaders, and if you have a unionized workforce, IR becomes another angle which one has to be discussed when you are adding such robots, because it's about training. You have to make sure that the industrial relations environment is conducive and positive. And I talked about what the teacher asked, is just not whether you make money, has your technology adoption of robots contributed to the society, and how it has contributed. If you're going to make 50 families suffer because they've added robots and they are going to be jobless, you've not added, in sense of purpose, you're not really added value. So all this has to be put in balance, and that's the process what we go through as a user when we decide on when we add robots in our line. Now I talked about how we decide. Some of the benefits, and that's the end of my conversation. What the benefits we see, what in our own factories we have seen is clearly improvement in quality and consistency, very high consistent, high quality products. That's one. Two is productivity significantly goes up. There is a possibility to elevate some of the workforce into a higher quality work, and that's how the world is moving. So we are also looking at how to elevate the quality of work which is being done, from tough jobs to a little more programming easier. So it's a quality of job and quality of life of our own employees improve. So that's something which we have seen. Be a contender for global business, even though I'm part of a global MNC. But between the plants, if the consistency is very high, your quality is very high, your cost is competitive, attract more business into the country. And we have seen this happen, and as a big benefit to driving higher amount of manufactured in India product being exported to especially US or Western Europe. So these are the benefits what we have seen, and we continue to automate lines. It could be a collaborative single stand robot to a completely industry 4.0 platform, lights out factory where you don't do anything and everything is completely automated. It's like the science fiction movie what the secretary spoke in the morning. And we have that type of one of our plants which does it. So it's very fascinating. And we have seen both the pros and cons of doing it. I'm going to leave a last thought before I hand over to the next speaker. In all this, one thing which we need to be clear, and as there are academicians here, there are industry leaders here, some scientists, one of the most important topics, which is a question which is coming in the industry, in the minds of the industry after going through many years of such automation, is what we call the man-machine interaction, or the human, which is MMI, or they call HMI, human-machine interaction. It's more and more getting very complex, because as the artificial intelligence and big data analytics are things which we pull out of the robots and we analyze and feed it back, the interaction between the workman and the machine and the software technologist and the machine becomes extremely critical. And I'm going from a technology to a software aspect. The psychology of a human being to how you interact with a machine becomes extremely important. I'm not giving life to a machine here, but how do you make sure that the machine listens to you, and what data you're pulling out gets very important. And this is a big topic globally today, or especially on the what they call the MMI. With that, given the limited time, I'll conclude my thoughts. Happy to be here. I'm looking forward to listen to the next speaker. Thank you.
Thank you, sir, for the insightful talk on industry perspective on robotics and stressing on skilling and reskilling and technology adoption of robotics in the society. Thank you, sir. Now, I would request Shri Vijay Pratap Singh, CEO Siemens Motion Control Business in India, to deliver the second invited talk on automation and robotics. Sir.
Thank you very much. Good afternoon to everyone. And firstly, many thanks for the invite from CMTI and the organizers. For me, the first learning, or let's say the really excitement, was when I heard the ministry officials speaking, and it really delighted me by looking at the closeness of technology with the bureaucracy. Really compliments to the Ministry of Heavy Industries, that the closeness with which you are following the technology and you are talking the industry language was really insightful and very reassuring that the people who are at the decision-making positions and the industry are talking the same language. On that note, since I'm not as good a speaker as the other Vijay, so I have to use some slides. So please bear with me. But I assure you one thing, that the slides will be simple. And my whole objective of this next 15 minutes talk is to try to demystify, try to simplify the topic of Industry 4.0 and robotics therein. Because for me, robotics is an element of Industry 4.0, is part of a bigger picture. Though I would like to talk a little bit more on robotics, as the topic is mainly focused on robotics, but I would like to at the same time give a broader view also on the technology space. So if you could click one next, please. Yeah. So I think Vijay also spoke about, or started his talk with the potential what Indian economy is looking at, and to just further what he said, I believe that we are at a stage of once in a lifetime opportunity which economy is providing us. It is happening because of many reasons. I think we all know them. We have a really good demography, which we had since some years. But what is changing is that due to geopolitical situations, world is looking towards us. And when world is looking towards us, either we can grab this opportunity or we can miss this opportunity. And if we have to grab this opportunity, then the key elements which we have to deliver to the world are some of them mentioned here, that what world will expect, what even our own consumers will expect from the manufacturers of Indian economy. I'll not go through them because all of them, because this presentation can take quite long. So I'll only touch upon the very key aspects of the presentation to try to weave a storyline so that we can get some messages at the end of the presentation. So for example, let me take the third one, reduce time to market. And this we all see in our lives. We know that if I go a decade back, we used to see the car models coming 5 years hence from each other. And now we see that every company is launching 3 or 4 models in one year. We used to see that the shampoo bottle which you used to buy, it used to come in one shape for years and years together. And now we see that every time the packaging is changing, the printing on that is changing, brand does a new endorsement, the Saif Ali Khan changes to Mahendra Singh Dhoni. All this, finally the technology behind actually enables that. And now going to, let's say on electronic side, we know that with Apple pushing many of the companies, now we are used to often every September or October that, okay, what new they are bringing. We need it or not is a separate matter, but they have changed the game. And if everyone has to really follow it, because consumers now expect it, it has to be enabled by technology. So just to give you a few examples of reduced time to market, that the development cycles for the products have become much shorter. And which means you cannot do your prototyping, production in series. You have to do in parallel. When your one product is running, you have to design your next product. You have to simulate that product. You have to simulate the production of that product. You have to simulate the quality of the output of that production, and then be ready for launching that product in time. Because if we try to do it in series, we'll never be there. And that's where digital twin comes into the picture, because the simulation happens through digital twin. With a show of hands, if I may ask, how many of you are using a digital twin since more than 15 years? Only 2, 3, 4. I tell you, you all are using. Google Maps is nothing but a digital twin. Google Maps is a digital twin of your streets. But point is that, these words sometimes confuse us. We believe digital twin is something which I don't know, I cannot understand. This is something for the European manufacturers or the US manufacturers. For us, it is simple. Come at it in the morning, do your production, go back home in the evening at 6. So these words sound complex, but they are very simple. Google Maps is nothing but a digital twin. You simulate your path where you want to go on your screen. It's as simple as that. You choose, this way should I take or this way should I take. Exactly that's how an industrial digital twin works. That you make a digital twin of your either product or your process, you simulate things, how you want to produce them, and then you take a conscious decision that, okay, should I go this way or should I go that way? So technologies are simple. At times, we are fearful of embracing them. I think organizations like us, if I say that for Siemens, what's our first objective? Of course, we are in business, we want business, but at the same time, how do you want to enable it? First is how we can make it as simple as possible for the users. How we can demystify it, how our technologies can be simple to adopt. This is one of our key objectives. If you could go to the next slide, please. So here you see, and now I'll start coming to a little bit on the robotics also. So now we know Industry 4.0, quite a very commonly used word since many years now. And we also know that what first revolution or second revolution, third and fourth were. Good thing for India is, actually you can see it as a challenge or an opportunity both. India is going through Industry 3.0 and 4.0 together. Because we are not so automation intensive industry as yet. We are using it, but we are not at a level of usage of automation as maybe the other countries, the developed countries are. The good thing because of this transformation going together is that you can think it through. We are not stuck with any traditional systems, old systems, proprietary systems, communication protocols which are not open. But at the same time, what we also do, and that's the challenge, we sometimes limit ourselves only to automation. We do some automation and we think, okay, we have done everything. No, that's a stepping stone. So here, one thing which I want to bring to your attention is that when you are planning your manufacturing processes, think it through. Thinking through does not cost. Deploying that costs. You may deploy it in a stage-wise manner based on your return of investments, your capability to invest, the benefits and the cost ratio you see, and there are many things available to find that decision. But nothing stops you from thinking. Thinking will not cost. And also, you will appreciate that you will not find in the world any example where you think small but act big. Opposite is possible. Think big, act small, or think big and act big. But thinking small or acting big doesn't happen. So please think it through. You may not go the whole 9 yards in one go, but thinking it through will help those 9 yards become simpler for you, because then you will not find roadblocks which you didn't think when you were starting on that journey. And Industry 4.0 is also not a product. Industry 4.0 is not a destination, it's a journey. It's a journey that how your tomorrow can be more flexible, more productive than today. And then let's continue. Even companies, if we feel that, okay, when they say, oh, this is Industry 4.0 done, there's nothing called as Industry 4.0 done. It's always an incremental step possible. And even companies in the developed part of the world are also on this journey. Even our own factories. Siemens as an organization is having multiple factories, and we are still deploying solutions of our own in our factories to improve our productivity. We are not done yet. There are still many processes to go. So this is a journey, this is not a destination. And what you see on the lower left side of this slide are the technologies which enable that. And there you see the robots, or here we have mentioned as autonomous robots, as one of the key ingredient of this journey. Also industrial 5G, because you need a communication network which is industrial grade, which is reliable, which has low latency, and so on and so forth. And that's where your industrial 5G comes into the play. So all the enabling technologies you see on the bottom side of it, but the big picture is that please think it through. You may deploy it stepwise. Next slide, please. So how does, let's say, future manufacturing system with robotics may look like? So these are the various forms which I think Vijay also mentioned about, different types of robotic systems which you can deploy. And he very well also covered the fear of losing jobs part. So I'll not reiterate it. I think Secretary MHI also mentioned about this, that how deploying robots or going for automation does not mean lack of jobs. And again, a comparison. Do we see more unemployment in countries who are not using technology, or do we see more unemployment in countries we are using more technologies? I think answer is simple. Countries which are not using technology have in fact more unemployment. And why? Because if you don't employ technology, then you will not get the economic growth which is needed to really develop the jobs market. As simple as that. So, but at the same time, as you know, here we are not having people who are really, working with their hands in a unionized manner. So we can talk about it easily, but let me tell you that when we go for a digital transformation, and this I'm telling you from our own example in one of our German factories, that when we did a digital transformation of that factory, our motors factory there, managing culture was as important an element as technology, because human are human. They have their insecurities, they have their fears, whether it's a German or an Indian or a Japanese or whosoever, and those insecurities need to be managed. But I think there are very good examples, there are very good ways in which we can take them along, because without managing this culture aspect, this technology transformation will be difficult. Maybe you could go to the next one, please. So this is my last slide. What you see here is that how the world is moving, how the future is looking like. We started with fixed manual, people coming every day doing the same job, going back home. Yeah. Then we have fixed automated, which means, yes, deploying robots, but robot doing the same repetitive job day in, day out, every day, just soldering at the same, or welding at the same point, and then that's it. We also have operations which can be flexible, but are manual. But the world is moving towards flexible autonomous, which means that on same line, same assembly line, manufacturing line, whatever you call it, depends on industry to industry, how you can manufacture different products. How you can design your line. Now, please go back to what I said, think it through. How you, while designing, you think that how I will use this line in multiple ways and not in one way. Tomorrow, if let's take example of a FMCG company. You never know whether a brand A will be sold more, or a brand B will be sold more, or brand C will be sold more. Let's say the requirement of one increases, one drops. What does it mean? Your one line running at a under capacity and one line requiring over capacity. And we all know who run the factories, and under capacity or underutilization is a big money drainer. At the same time, not being able to produce, with which you could have grown your top line and hence bottom line, is also not so money efficient. So how do you balance that your lines are flexible? So the world is moving towards flexible manufacturing and not fixed manufacturing. And one example of robotics only, with which I'll conclude my presentation, we are working on now how to merge AI and robotics in real life. Which means that today the standard procedure for a robot is, for a standalone robot is, you get a robot, you teach that, okay, here to pick, here to drop, this is the object, this is the gripper, and you decide a gripper based on that, and that's how it works. Example of flexibility now I'm giving you. We are working on a system based on AI where you don't need to teach a robot. It can pick any object. Of course, the gripper has to be accordingly selected, but it can pick any object. The shape and form doesn't matter. And how it is done? It is done with AI. Because you capture those images, you train the algorithm that how to identify images. In fact, we are also working on, and these are all real examples which we are developing, how to decide that even there is no human intervention for the robot to know that what robot should do next. This also should be possible through AI. So these are the advancements, or these are the cases which we are working on, especially in the field of robotics. But I would like to just conclude by saying that this topic is vast, but that vastness of that topic should not be seen as the complexity of that topic. When we see it in small pieces, it's very simple. It's easy to adopt. What we need to do for our Indian manufacturing, if I have to say one thing which I see that we still do little less, I think we need more R&D spends. Our R&D expense, and I mean, companies can do their maths that as a percentage of the revenue, how much we spend in R&D, and we'll get the answer. But I think our R&D spends are low. This will be possible only with more R&D spend, trying out it. No technology, will give you the result on day one as you perceive. This is an iterative process. You have to fine tune it to your purpose. But there is a way forward, and organizations like us, or even I would say our competitors who do the same work, please engage with them, and we are there to work with you. Thank you very much.
Thank you, sir, for another insightful talk on automation and robotics, and emphasizing on the importance of changing our future manufacturing systems with advanced robotics. Thank you, sir. Now, I would request Joint Secretary Shri Vijay Mittal, MHI, to hand over memento to both the speakers. First, I would request Joint Secretary MHI to hand over the memento to our first speaker, Shri Vijay Krishnan Venkatesan, Chairman, CII Karnataka and MD, Kenna Metal. Next, I would request him to hand over the memento to our second speaker, Shri Vijay Pratap Singh, CEO Siemens. Thank you, sir. Now, I would request Shri Naga Hanumaya, Director CMTI, to propose the vote of thanks for this session.
Good afternoon. Maybe it is a coincidence. Not two Vijay, three Vijays. Right. But the main session focus is that, particularly this session, I think the bigger or older Vijay covered that robotics is not, use of robotics is not a fancy, or it has a purpose, right? So as a CEO, definitely is looked at how the robotic benefits to the company or the benefits to the manufacturing line. So he explained clearly. And younger Vijay explained the technology and how these technologies, robotics technology, are relevant in the current era of like Industry 4 or digitized manufacturing. And then he also touched upon the coming like reconfigurable manufacturing or flexible manufacturing. So how these robots would help. And both of them also covered the social aspect. That is, it is not robots or automations are not to lose the job, but it's an opportunity that creates a new sets of skill sets about the job opportunity. Thank both the speakers and my colleague Amresh Chakravarti for briefing you. So now we break here. So we request all of you to join at exhibition site. Since we are running late, what we will request you is pass through the exhibition, have a lunch, and you come back by 2:30 still. At 2:30, again this room for the panel session 1. Thank you very much. Before that, I'm sorry.
Now, I request everyone to stand for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जन
Thank you. Now, we will break for lunch, and as we walk out, we can spend some time to take a tour of the exhibition stalls and learn various developments and initiatives taken towards growth of robotics and automation in the country by Government of India. Post lunch, we have 4 panel discussions on
Check, 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 check. Is the mic testing 1, 2, 3?
हाँ जरूर हाँ सर बिल्कुल सर हम करा देंगे। हाँ 4 सेंटर है, अब और भी बना रहे हैं सर अभी। तमिलनाडु में भी मेरे ख्याल से आई थिंक स्टार्ट हो रहा है, शायद स्टार्ट हो रहा है।
Let's start. A warm good afternoon, everyone. Welcome to the panel discussion session on National Conference on Robotics. Now we have panel discussion on robot as a capital goods. How to lead robot manufacturing in India. The moderator for this session is Shri Krishnamurthy Raman, CEO at Navtat Solutions, who is a prominent figure in leading R&D centers and industry. He is also heading Industrial Automation Division. The panel members are Professor N. Ramesh Babu, Department of Mechanical Engineering, IIT Madras, Shri A.K. Menon, Founder Director at Strategy Automation Solution Private Limited, Shri Vijay R. Salem, MD at Swaya Robotics, and Shri Pradeep Hegde, Regional Head, Lumax Industries. I welcome moderator and the panelists on the stage. I kindly request our moderator to take over the session now.
So good afternoon, everybody. After lunch, the first panel discussions. So want to ensure that the attention is there toward the panel. Because this first of all, I should thank MHI, CMTI, ISC putting together the conference and selecting the panel members for a wonderful panel discussions, robots as a capital goods. And MHI's vision, I'm really amazed with right from the minister to the secretary level and everybody in MHI is grounded and connected with the technology and the trends, what is going on. The theme of today's topic is basically on the adoption of robotics in capital goods sector, including MSMEs and the large industries, and how do we fuel the growth of manufacturing robots in the country. Means the goal of Prime Minister, the Atmanirbhar Bharat, how do we make it happen? That's what I understand by this. So just to set some context on the overall discussions, some of the challenges what probably for the robot manufacturing in this country is the hardware ecosystem. That is number one. And today's robots, most of them, you will agree with me that most of the robots are imported today and what is being deployed in various manufacturing sectors. And the potential to grow in this country, as many people mentioned in the morning discussions as well, we anticipate a very, the data and statistics, if you really look at it, last 5 years, the growth of robotics in the country has doubled. That's almost 100% in the 5 years. And it won't take another 5 years to double the current population of robots to increase its presence in the various industries. And if you look at it, you can see the technology like 5G, AI, ML are all getting entangled with the robotics, and the robot has become an integral part of the Industry 4.0 initiative, what the government of India is also trying to drive through into MSMEs. And today, if you want to propel the growth of robots, as I mentioned earlier, one is the hardware ecosystem. The cost of the adoption has to be lesser. That means we should focus on how do we manufacture this robot at a cheaper cost without sacrificing any quality of the robot, reliability of the robot, and get the better productivity. And we are all today, if you look at India is, I will say the population of cobots or robots in the country is very, very low. I was saying around 6 to 7 robots per 10,000 people in the manufacturing industry. But you can, as some speakers mentioned in the morning, the lot of areas where robot can penetrate into. I've been working with medical robotics. Healthcare is a very huge segment. Service robotics, defense, as well as other service robotics. And manufacturing sector, definitely the wherever the repetitive tasks are there, and how do we get deploy robotics, get the ROI what the manufacturing industries want. And with this sort of context, I would like to introduce the panel members. Already they have been introduced, but we have got a wonderful panel, starting with Seelam, Vijay Seelam. He's an engineer, entrepreneur, and a production visionary. Wonderful work has been done in manufacturing collaborative robot by him, a platform based out of Hyderabad. And none other than expert from IIT Madras, Professor Ramesh Babu. Sorry, I could not recollect immediately. Professor Ramesh Babu. He is a pioneer and well-renowned professor in the area of machine tools last many years, 36 years, and running the center in IIT Madras, AMTDSC. And lot of work, I'm sure that is being carried out in the center, which will help fuel robot manufacturing in the country. Then we have Pradeep from Lumax, one of the leaders in auto component manufacturers, users of robot. And he is heading and also leading the digital engineering industry 4.0 initiative in the Lumax and the various branches and factories of Lumax. They are the world country's leading auto tier 1 OEM product manufacturers for the OEMs. And we have none other than Arun Menon, who's a stalwart in again the automation, MD of strategy automation. And he is well connected with all the MSMEs, and he has got a very good, I will say, on the ground realities of what's happening in the industrial sector and how the robotics can be deployed in various MSMEs. So with this introduction, I think we will start the panel discussion. We'll start the question to Mr. Arun Menon. Arun, first question to you, would like to put forward, because I believe that the fueling the growth of robot manufacturers will happen only when MSME adopts robots in their shop floor. So I would like to ask you some of the questions. What are the challenges MSME is facing today for the adoption of the robots in the shop floor? And do you foresee the benefits of robots in the MSME sector, the ROI, and your views on those, Arun?
Thank you, Mr. Krishnamurthy. Good afternoon, everyone. It's a privilege to be here, and want to thank the Ministry of Heavy Industries and CMTI for having organized this conference today and tomorrow. It actually speaks volumes on the seriousness of the ministry and the government to kickstart robot manufacturing in India. And as you would have seen in the morning session, we have a responsive government who's trying to see that India becomes self-reliant in robot technology. So we are here to actually discuss on from the MSME's perspective. I represent a MSME, which is manufacturing machine turning robots. And I'll just share a few of my views on how we can, make robots as a capital goods in our country. So coming to MSMEs, I think all of you are aware that MSMEs are the backbone of Indian manufacturing. We have 63 million MSMEs in India, employing around 120 million people. So if you do the math, I think you can easily, realize that most of the MSMEs are micro, employing 1 or 2 people. Then there are small and medium. And they contribute approximately 30% of India's GDP, around 45% of exports, and also around 40% of Indian manufacturing. So MSMEs clearly are the engine of growth in India. How do we make our MSMEs more competitive so that they can, produce products of the highest quality, which can be exported all over the world? And I think the answer lies in adoption of Industry 4.0, which we know consists of artificial intelligence, M2M, machine-to-machine communication, also consists of robotics, advanced automation, and of course, IoT. So our case question to me is, what are the challenges that MSMEs face in adopting these technologies? So clearly, one of the challenges that MSMEs face is, are there successful case studies in MSMEs which MSMEs can straight away take and adopt in their manufacturing practices? Just want to step back and tell you our story as a manufacturer of machine turning robots. We started in 2017, and we make machine turning robots primarily for CNC turning centers. When we launched our product in 2017, we were under the impression that our customer is a large company, somebody who has maybe 500 employees, at least 500 or maybe 100 to 500 CNC turning centers in their shop floor. And we were pleasantly surprised that my first customer was actually an MSME, a person who could take a decision straight away whether this made economic sense to him or not. So MSMEs adopting robotics, adopting automation is something that, we have to understand that they're all there ready and waiting. The question is, do they get the right solution? Something which is reliable, something that performs at the highest levels, and are they price competitive? So which actually brings us to, our question of the day. Why should we manufacture robots in India? So the answer in my mind is we have to be self-reliant. We cannot be always depending on the outside for robots to come into India. I think in terms of percentage, it should be more than 95% of the robots are imported into India. Secondly, I think there is a myth that robots take away jobs. But what about if we do robots in India? What about the number of jobs we are creating? We are going to create a lot more of jobs if we manufacture these robots in India. The third thing is, as a country, we are a third world country, we are a developing country. We need robots at affordable prices. So when I talk about affordable prices, I've interacted with several MSMEs. There is an eagerness to go ahead and purchase and deploy, but there is a lack of financial capability. So if we can give them highly reliable products at good competitive prices, I don't see why MSMEs cannot adopt robots into their manufacturing, and why MSMEs cannot manufacture robots in India. MSMEs are known to be frugal in innovation. We do have quite a few MSMEs manufacturing robots in India, especially mobile robots. But on the fixed robots, there are still a limited number of manufacturers. So if we can give them support, which I think the panel will deliberate, I'm sure that we can have MSMEs not only as a consumer of Indian robots, but also as a manufacturer of Indian robots. We need highly trained manpower, adopt robotic technologies on the shop floor. I'm sure other panels are debating on this and how we can get qualified manpower to, operate these robots, maintain these robots. And we see that the moment you go to MSMEs and tell them about paybacks of less than 2 years, that's our experience. When we give them paybacks of less than 2 years, the decision making is pretty fast. So if you can bring that payback period to 18 months or maybe 12 months, I think the adoption will just accelerate. I think we have a very, very bright future in front of us. The government is making the right moves in encouraging robot manufacturing in India. And I think if we form a good ecosystem here, I'm very confident that India can be one of the leading robot manufacturers in the world. Thank you.
Thanks, Arun, for a wonderful background setting on how MSMEs can adopt. And you also touched upon some of the challenges. I would like to ask Pradeep, being in charge of digital manufacturing and industry 4.0 initiative at Lumax, I'm sure that he is involved in various implementation of robots in the shop floor. And how can the robot systems basically contribute in your manufacturing processes? And what sort of resistance you have to adopt the robots in the shop floor? And how it has benefited you as an organization? And would like to hear from you on those aspects.
Thank you, Krishnamurthy-san, and thank you, everyone. Thank you, CMTI, for giving this opportunity. It's a very important question that how manufacturing addresses robotics in the future. In fact, robotics is going to be the future of manufacturing. So we have various opportunities that we have basically in our approach. First is automation of repetitive tasks. We can do that. So this means that the repetitive processes in our assembly lines is replaced by robotics. Second is coming to autonomous guided vehicles. Basically, the material movements in the shop floor are going to be, it was very much manual based. Now today with the autonomous guided vehicles, it is easy that it goes to the destination on time as programmed, carrying the right amount of material to the required manufacturing place. Then comes the precision and quality in terms of quality control. With robotics, it is needless to say that the quality of production, manufacturing has been to the ultimate level. Because we have been achieving zero defects in our manufacturing when we are supplying to OEMs, and that was a challenge earlier. Coming to predictive maintenance, yes, with the users of sensors and programs, it has helped in trying to, when the number of shots in molding or when the number of shots in the cycle is completed, it gives an indication that this machine or this robo is to be undergoing a predictive maintenance. So it becomes an advanced signal for sudden breakdowns. Augmented reality definitely assists people to work in complex situations wherein the guidance is given by the system, AI to do the process right. And then we have the most important thing is the flexible manufacturing system, which is the ultimate. If you see in most of the automobile industries, you will find a lot of robots introduced for flexible manufacturing. It means based on the program that is defined, based on the processes that are defined, the robots conducts the activity with zero defect and zero failure. Coming to collaborative robots, I think this is one of the important things, the way forward. Having the interaction between human and robots. Because today robots are available on standard basis, but now connecting it with the process, with the human touch, human element, and the robo makes a big difference as a game changer. If many of you have visited Toyota, you must have seen how the seat, because I was heading the seat manufacturing plant in Toyota Boshuko, how the seat is the robo places the seat inside the vehicle and the man does the fitting inside the vehicle. So it's a fantastic thing which saves a lot of time and builds in accuracy. And finally, on advanced analytics and optimization, because robots generate a lot of data with respect to cycle time and the results with respect to the quality parameters. So with this data, we are able to do analysis and take countermeasures to how we can improve the productivity, how we can improve the quality, and how we can reduce cycle times and changeover times. This really gives an edge on cost competitiveness with respect to products in the market. Thank you.
Thank you. Pradeep, one more question is your touch upon the ROI and what you feel that the return on investment on the capital equipment when you invest from the automation or the robot in the plant, right? And is there a challenge to get management approvals when you propose automation for the shop floor?
Yeah, Krishnamurthy-san, that is a big challenge today because a lot of robots are available which are imported or maybe assembled on CKD basis. The cost of the robo will be almost half the or equal to a machine itself. So this is becoming, the return on investment basically becomes longer when people are wanting to go for a robo. The intent is right, but the cost per se is a real challenge which we need to address. I think with the robots being developed in our country with localization can give a lot of benefits and designing it to a particular process, because what is happening today, we are getting standard robots. So in the process, what happens, the adaptability, the change, the cost on change, the cost on training on people, then serviceability, all these things adds to the cost, which directly goes into the product and hence makes it a difficult game change. So I think this indigenization would really help in bring a lot of changes. I just want to give an example. Earlier in one of our units, we had 8 molding machines run by 8 people per shift. That is 24 people in a day. But when we introduce these robots, today we are running with 1 person per shift with 3 people running these 8 machines in 24 hours. And the efficiency earlier was around 75 to 80%, even though we are a TPM company. And with robots, the efficiency has shot up more than 92%. So I think that is the real challenge that we have as to affordability in terms of investing on robots.
So we have very few companies who are manufacturing robots in the country today. And the dream of the ministry and also the country's vision is how do we really accelerate this growth. So we have Professor over here, IIT Madras. And I would like to ask one question to Professor, that what we are seeing, Professor, is the import content today of these manufacturers are much higher. I was made to understand that is as high as 70%. So unless we reduce the import content, manufacture sub-components and systems like gearboxes, encoders, sensors, etc., within the country, it will be very difficult for, as Arun and Pradeep mentioned, to get the cost point wherein which the adaptability increases. Unless the population, the demand increases, the manufacturing companies, though they start manufacturing robot, the cost point needs to be bring in. I'm sure that IIT Madras has got a lot of initiatives towards this, Professor.
Thank you, Mr. Krishnamurthy. First of all, let me Ministry for supporting our activities at IITM Research Park in the name of Advanced Manufacturing Technology Development Center. which was also mentioned by both the ministers and the other speakers. I think before I go into it, I want to give a perspective on how an academician looks at the implications. I think when I started my journey in 1980, I was using a small robo with a few sensors. We just use it with the teach pendant or some programming. Teach pendant or a programming systems. Then we went into Indo-German collaboration, gave us an opportunity to get the robots from Germany, Siemens Manutech robo. It's a gantry robo. Again, we were using those robots. Then around 1995, one of my colleague who returned from USA, he said that why don't we use these robots for construction planning activities? And he returned from University of Texas, and he said, I want to collaborate with you because I am in the civil and you are in the mechanical with automation. In fact, if you look at the construction automation, agriculture, and all of them are at a very, very low level, even industry 2.0, I can say. Then immediately I jumped in, I said that, yes, let us do some work on path tools. In the sense, when you have multiple robots, you may ask why multiple. If you look at the construction activities, you require a huge robots. If you want to carry those robots from one station or one city to the other city, there's so many constraints. You have the bridges and you have the constraints on that. Normally, they split the work into the cooperative mode. That is a smaller robots which can easily be, and then you can pack them and then install them there, and they do the cooperative work. We did a lot of work on all of them. Many PhDs and many students have graduated it. So then at some point I said that we should develop the robots in India itself. That was in 96 to 98. And CAIR, Center for Artificial Intelligence Robotics, was manufacturing a multi-axis controller card. I talked to them because the head was our own student from IIT Madras. Then MTAB is a MSME. So I told him, will you be able to manufacture these robots if I give you the money and also the controller card? Then he said, yes, why not? We have been doing reverse engineering. We will do it. We did that. It's a different type of robot which you normally see it in the construction environment. It is a crane type manipulator, we call. So just boom is there, then hoisting is there, then hook at the end, etc. So we successfully build those robots with the help of a MSME who doesn't have expertise in forward engineering of a robot. I said it is a reverse engineered one, but they have built it and then given it to us, and we produce several PhDs in sharing the load, etc. Why I'm saying all this is how an academician looks at the robots to begin with. And it went on, and then companies from Japan also were using the robots for automation in sheet metal. When I saw all of them, they're not very great things that you need to import them. So when the MHI wanted some projects to be floated under this scheme for capital goods enhancement scheme, so we invited the partners through the IMTMA to the associations. Because if I have to go to the market and ask anybody that you please help me, so they don't have a faith in the academician for several reasons. I'm not saying that we are good or bad. So then I have already completed a project with the Micromatic, which is the ACE group, and we converted that into a next generation precision grinder, which is on par with the imported machine, using the forward approach, which they liked it. So why I'm saying all that is through collaborations with association, with the company, and with the academic background, we could finally build these robots with the help of MTAB, who has put in some money. Initially, they were quite apprehensive that whether anything will come, whether we should give 20% or not. But as it went on for 1.5 years or 2 years, they got the confidence. Now we have built the 6 kg, 10 kg, and without anybody's money, for some other turnkey project, we have built up to 25 kg. Why I'm saying this one is, how do we build the confidence with your team? So this gave us a pathways that we need to collaborate with many of them if you have to build all the units. Today we are working with several industries in order to make aggregates. And another one is the system integrators. And the third one is the end users. Okay, you build the robo. Who is going to use it? So hence, our approach is a consortia approach wherein the aggregate developers, wherever they are there, we have to identify them, we have to ask them to come onto the platform and ask them to work with the academia, wherever they are there. Whatever robo we want to develop it, we can definitely do it. In the sense, if you look at the machine tool industry in India, over the last 4 decades, they have gone to a level wherein we are exporting the machines. And when we can do that, why can't we do it in robotics? Though we have started late, but then if we have this sort of a collaborative platform, it's a physical platform on which everyone should come together with some interest of building these robots and then delivering it to the end users who can test, validate, and finally build it. So I have a great confidence in building these robots in India, provided we create an ecosystem, we create a platform at different locations in this country with the main focus on industrial use or service or anything, either for the agricultural applications. We are working it for fruit harvesting. We didn't want to take any money. The landlords have said that we will give you the money. Only thing is you give the directions, etc. So when we can do that project, definitely we can do many more projects. I think my perception is whatever you say, the import content, 70% we imported in the first project, 6 kg and 10 kg. Now we are trying to reverse this one. 30% is the import and 70% is going to be indigenously built. Mechanical, electrical, electronics and everything. I'm hopeful that in the next 2 years, you may see the range of robots which are meant exclusively for the industrial applications. I know many of them are developing it for various other applications like healthcare or medical, the surgery, etc., etc. I'm hopeful that if we all put our thoughts together and make a framework, which is going to really gel well with almost all the academicians wherever they are there, I think they can come together and then collaborate in order to bring out that sort of an ecosystem, which is going to reverberate in course of time. That's my perception. Thank you very much for giving me the opportunity. Yeah.
Thank you, Professor. I think wonderfully well said. And the academia's involvement in helping the industry to get the cost lower. That's the biggest challenge what both the panel members over here, Arun and Pradeep, both of them felt that the cost is at a high point. As a robot manufacturer, we have Vijay, who is manufacturing collaborator robot. So as a manufacturer of collaborator robot, Vijay, my question to you is, what are the challenges you are facing in the development phase, number one? Point number two is, when you go and approach industry to adopt your product, so what sort of pushback you are getting? Because you are Indian robot manufacturers, we have KUKA, Siemens, and many others, Universal Robotics and others. Whenever an Indian robot manufacturing company approaches a customer, first thing is, they ask you how many numbers you are in the field. 100? Impossible, right? We have to sell the first one. So that's the challenge probably, I think, the robot manufacturing phase. I would like to hear from you, Vijay. You have been successful in design, manufacture this collaborator robot. So over to you, Vijay.
Hello. Thank you, Mr. Krishna. And also, thanks to MHI and also CMTC for having me here. It's really an honor to be on this panel. Let me just start with a disclaimer here. I'm not a person who believes in lights out factory, although that might be a little bit a contradictory statement for somebody who's making robots. And let me tell you, let me substantiate why I'm saying that, and our own story of how it has led us into manufacturing, becoming a robotics manufacturer, Right. See, one is, when we say robots, right, it basically conjures both fear and excitement. One, fear in certain sections, like, policymakers or those who are in charge of creating the job in the country, right? Like loss of jobs. And excitement on behalf, when I speak to the businesses, right? I think robots can really fundamentally create new opportunities or new and profitable business models for them, So now the question is, what is, what is the truth, what is the fact and fiction, right? So let me just substantiate, we have begun our job. But, in the morning, I think Professor Ranganathan has said, robot by itself is pretty dumb. So what makes it intelligent? And not a single day goes by, at least for us, those of us who are engineers in the technical or even in the general media, not hearing about AI or ChatGPT or LLM and all these things, right? But now when it comes to robots, right, they're truly the ones which bring AI into the physical world, right? Make your factories intelligent, flexible, scalable, So robots can truly have a transformative effect on manufacturing, just like what computers have done for white collar work or office, right? Today, you can't even imagine a front office person not having a computer, you just simply can't imagine a person. You're handicapped without your smartphone or a laptop or a personal computer, Now, think about that, what robots can do in manufacturing. And one example for me to substantiate, I won't elaborate on this one, what ATM has done for banking. Has ATM taken away the jobs, or has it created more jobs in banking? And today, every bank you go, you don't have your relationship manager, the same relationship manager after 6 months. There's so much of attrition. So in fact, it has created more jobs, but more, right? Taken away, basically the teller job from the person, making their jobs more relationship focused. And the same thing in robots. Now, let me just come back to what got us started into robots, When we started in 2011, we didn't think about manufacturing robots. We went into SMEs. The first and foremost question that got us right, why our SMEs are not as competitive as the SMEs in Germany, Japan, France, or South Korea, why we are not able to get the same quality output or the productivity. And for a year, we spent in different trades, cataloging where and how people make mistakes, especially in skilled trades, like say in welding or in fabrication or even in woodworking. So we carefully cataloged all those. And initially we thought probably we'll bring some technology into the hand tools. But then we said why would a Hitachi or somebody would allow us to poke an outside technology into their products, right? So that's got started into what would be the most general purpose robot that we can put into the existing setups, And now, as Arun has said, articulated very well about the need for automation in SMEs, And if you look at manufacturing, 95% of manufacturing happens in SMEs, right from screws, nuts and screws, right? So, and it's not just in India, it's across the world. And SME is one of the least automated market segment across the world. And you see, there's been a lot of robots, especially in automotive and semiconductors and all that, but not much automation in SMEs. But now, this is very important. Now, robotics is at the cusp because the nature of manufacturing itself is changing. Now, you just imagine about what happened 30 years back to the computer industry. The same thing is happening in manufacturing today because there's a lot of modularization that is happening. That means a lot of power is getting into the SMEs. So what used to be manufacturing used to revolve around a lot of big companies and a lot of chain used to revolve around them. But now that is slowly transforming into product clusters. And today you see there are at least, by the last count, at least 250 to 300 EV manufacturers, be it scooters, bicycles, electric mobility, and all that. And that has happened because a lot of modularization and a lot of SMEs are becoming module players. And now, so today, product innovation and design is becoming very important, and the supply chains are becoming very dynamic. And now manufacturing has to play the role, because this is becoming an integral part of that strategy for the SMEs. And now coming to the difficulty of manufacturing robots or as a robotic manufacturer in India, definitely I think we lack in the ecosystem out here in India because we don't have a lot of quality component manufacturers, or maybe they have not just looked into that because we simply didn't have product as a viable technology that companies would adopt. So, and a lot of, and 75 or 80% or more than that is imported today, as an aggregate, right? As a robot, as a product itself. And it's predominantly systems engineering, what is happening here in India. And now I wouldn't be too worried about that. We don't have a system at this point of time, because any product innovation, if you look everywhere in the world, it hasn't started with the component manufacturers. It has started with the systems engineering, So systems engineering and product innovation has to be put upfront, because if you talk about components, this is putting the cart before the horse. And if the product innovation happens, because now this is going to be very unique to India, right? Because the Indian market is unique. The SMEs are unique here. Their needs are unique. So we need to focus on that and bring the products to the market. And if the market becomes substantial, then definitely the component ecosystem will automatically follow. And as Arun has said, MSMEs also can become manufacturers of some of these components, And just to give you some numbers to think about, because we go by like an incremental 30% increase every year. Okay, the robotics market is going, right? But I feel that's probably not the true metric that we have to look at if we want to look out at the potential of the next 10 years or 20 years. So think about this. There are 300 million manufacturing workers across the world and $4.5 trillion in wage costs. And by one metric, there are about 75 million jobs across the world, especially in skilled jobs. And skilled jobs is one place across the world where they have very difficult time getting manpower. And in fact, I was a couple of years back when I was talking to a lot of SMEs, one consistent complaint was they don't have skilled manpower, or they can't get skilled manpower, or they train and then they leave. So this is a perennial problem which affects their quality and productivity. And of course, absenteeism and a lot of issues, right? So this is a complaint across the world. And now coming to India, there are at least 3.5 million jobs in the skilled area. And one example I can give you is, I was in Kolhapur, we are looking at a foundry manufacturer, and foundry happens to be, especially sand casting, very highly polluted segments. And you were saying, I think the day will come in 3 years where people don't want to work in a foundry, but they would be very happy to work in a mall, in an AC showroom, where they would get paid better than in a foundry. So that's I think it's just a matter of days, because the service economy is going much faster than the manufacturing economy. So this is where I live, I think there's a tremendous potential for robots. And one last count, if we look at the numbers itself, even if we automate 5% or augment, even with manufacturing growing in India, there's no dearth of jobs. It can be a $4 billion market.
Thanks, Jay. Insightful discussion. Yeah, thanks, Vijay, for a wonderful discussion and insight into the challenges what you're facing, especially on the component manufacturing, etc., and the cluster formation of clusters, things like that. Good suggestions. So, Arun, a question to you back again. Now you heard Professor Ramesh Babu speaking, Vijay speaking, responding to a need of the MSMEs. But Vijay mentioned a wonderful point that MSMEs themselves can become manufacturers some of the critical components, right? So how do you feel collaborative initiatives or associations or collaborative research with academia, with the help of, I'm sure MHI is more than enough to come forward and help financially the MSMEs to become a very good what you call capable manufacturers of subsystem component. So what do you feel about the formation of MSME cluster and also adoption of the robotics to even to make the components of the robot?
Yeah, it's a good question, RK. Just to react to what Vijay said, my experience when I have been to several Indian industries is, they have machines idling because people are not there. So this whole myth of robots replacing jobs is actually non-existent in my opinion. Because I don't know how many of you have seen this movie of Charlie Chaplin of modern times in 1936. We are like now 100 years almost after 1936, and we are still expecting our workers to do a monotonous job every day. And you're saying that nobody shows up at your gate. Are you surprised? Come on, wake up. I mean, it's about time that you realize that people are showing up there because they don't have another option, another alternative. So I think the way to go forward is only to automate. There's no other way. It's staring you in the face. So the way that MSMEs will possibly adopt is when they see successful case studies of this having been done in their in their peer companies. So to answer what RK was saying, how do we encourage both manufacturing as well as adoption of robotics in MSMEs? So our company is a member of two industry associations, one in Bangalore and one in Mysore. But we see that the industry associations can do much more than only representing, tariff hikes to the government. Our electricity went up, our water bill went up, etc. How about having a member in the industry association who's in charge of Industry 4.0? And, you present almost on a weekly basis or on a fortnightly basis successful implementations of Industry 4.0 among your member companies there. If you have any component manufacturers, please ask them to come and make a presentation in the industry forums to say, hey, we are making this component. We'll be happy to supply it to you. This is the range of products that we have. So I think, in my opinion, industry associations can go a long, long way to promote the use of robotics as well as promote Indian manufacturers of Indian components. We are also a member of a cluster called Mechatronica Cluster. So similar clusters can be formed for robotics. So if we have a cluster which consists of manufacturers of robots, consumers of robots, end users like Pradeep, of Lumax, large companies, small companies, academia like Professor Ramesh Babu, research scholars, I think there are several in this room here, and students, it would be a wonderful platform to interact, share knowledge, and share experiences so that we promote this in a much, much larger way in our country. The clusters, I'm also aware that there are some places in Bangalore itself where they form clusters which have maker labs. So the maker lab can have prototyping facilities, it can have testing facilities, calibration facilities, simulation. So this is what encourages, see, for example, Vijay is a MSME manufacturer of robots, so are we. But it's very, very difficult for us to invest in everything from technology development right down to testing and validation. So if we have industry associations and clusters coming forward to do this, a lot of financial burden as well as administrative overload can be taken up by the associations and clusters. So I think this is a way that I would like to suggest that we can go forward.
Thank you. Thank you, Arun. As you all know that we are supposed to be very good in software, AI, ML, and all that software-centric tools. And the robot is becoming also a software-defined robot. So a lot of software content into that and things like that. A lot of advancements, unless we have some unique advantage in the robotic design, and we cannot compete with other imported robot manufacturers, apart from the reliability, manufacturability, and the cost. So I would like to ask a question to Pradeep that what does he think on the latest trends and in the area of the technology, cutting edge technology, what can be adopted in your manufacturing segment?
So the changes which coming. So the changes that companies should prepare to stay competitive in the market basically is one is to, I would suggest to embrace research and development, because investing in robust research and development initiatives to stay forefront of robotics and automation technologies is the key. Collaborating with universities, research institutions, and technology partners would really look into the access to expertise and facilitate technological advancements. Second is to foster a culture of innovation. Create an organizational culture that encourages innovation and embraces change. Employees, we need to promote to think creatively, experiment on new ideas, and foster collaboration and knowledge sharing between departments such as engineering, manufacturing, and IT. Third is develop a strategic partnership, especially with the experts. Get into companies which are innovative, which are already doing innovative products and processes. That is a technological breakthrough. Then we have upskill and reskill in workforce. There is a change, but as Arun San said, there's a dearth of skilled people. Getting skill in the future, even though India is such a populated country, we have manpower issues, we have retaining people issues, and we have people attrition going out. So from this perspective, I think having robotics and developing the skill in this line would definitely help. Focus on flexibility and adaptability in terms of robotics. So this includes design production lines and facilitate facilities that can accommodate changes in technology and adopt new manufacturing techniques. Enhance data analysis capabilities, monitor and adopt emerging technologies. So this really would help to bring in adaptation and change to face challenges in implementing robotics in the industries.
Thanks, Pradeep sir. Professor Ramesh Babu, one question to you. The academia is doing an excellent job in developing the skills and things like that. And the robot, one of the resistance of adopting robot in manufacturing industry is the cost of running the robot, and also once the robot is deployed, that is for a specific component. Now, how do we need to really create capabilities in designing different types of grips and adopt the cobot for multiple operations and things like that. And also on the skill development point of view, I'm sure that IIT Madras is doing a tremendous job. Would like to throw some light from your side. What is your suggestions to increase the skills and also improve the design skills on the accessories or robotics like grippers and things like that?
Hello. Yeah, I think it's a very pertinent question for the reason that we wanted to use the robots for different applications. Even though we built robots in the phase 1, we could not deploy it for many applications except for one or two, because MSME companies have their own reach to supply it to various institutions, academic institutions who are using it for training, education, etc. The second one is some of the companies like a building, the fabricators and others, need robots because of non-availability of people. So he started bringing out the applications around the robo, which needed some other elements such as the grippers. And maybe tomorrow you require the monitoring systems then you need to make the systems as autonomous, etc. In the sense, once you make a building block, that building block can help us to identify the variety of applications which can be built by many. Like these are all the various units which have been built in the any machine tool industry in manufacturing sector for either gripping, a component or something like that. So my opinion is the skill development can happen parallelly in areas where the focus should be on design, development, and proving rather than leaving it at the design stage, which is normally happening in most of the schools, thinking that, oh, we will bring out a creative designs. Yes, no doubt, creative designs are important, but creativity is not needed in such items, everywhere. You can adapt, those items which are elsewhere used in the machine tool systems for the automation applications, or there are many things. If you look at the strategic sector or defense sector, etc. So in my opinion, the skill development for building the robots for the applications is more important than developing the skills to design the robo, operate the robo, programming the robo. I think most of the schools are doing that for many reasons. In the sense, we don't have any other application in our hand. So at least let them understand what is a robo, what are the various elements of a robo, what is the kinematics of robo, dynamics of robo, which we can easily teach and educate the young students. So I think this is where the industry collaboration with the academia and with an end user having a specific application in mind should bring the problems to the table, to the academia. So then the problems will become more of interest. I'll give you one case wherein I think one gentleman came through Murugappa Group. I think most of you know about Murugappa Group. And he is a landlord of more than 120 and 150 acres in Andhra. So he came to me and then said that I have seen lots of Israel, Australia, USA, New Zealand, but those items are not useful for our Indian environment. So our fields are only small fields of 5 acres, 10 acres, and we don't need it. So I think the MHI also has promoted the skill development through the internships, etc. So we engaged about 10 interns in 2 batches. We just cracked the problems one by one. One is when you want to do the harvesting, the image, processing, identification of with ripened fruit is more important than plucking it and then putting it into the basket. So we did solve that one. Then he said that I don't need anybody's money. I'll give you the money for developing the manipulator. Now we started working with them. He will come and then sit with our guys. So the skill development should happen like that, rather than just giving a problem. We want to solve the entire world problem, not solve it. What is happening between the I think we always say that we have the capability and we can develop these solutions for everything. No. Generic to the specific is extremely important for making the students more stronger and easily making them as an entrepreneurial. Otherwise, they depend on the software jobs. They go to multinationals. They keep moving from one company to the other company without much stability. So this is where the skill development should start from school. And from school to the college to other places will naturally happen, which may happen in course of time. So my opinion is not making the designs for specific application or a generic applications, but then you have to bring the problem to the table, and then we have to work with both the stakeholders and also with the young students. So then the amount of knowledge and the amount of confidence that they get is going to be extremely high. That's my experience with all my students who have been trained. And they're not from IIT. Let me frankly tell you, they're all from Tier 2, Tier 3. I don't want to say that the IITians only will do the job. Tier 2, Tier 3 guys will come, spend 3 to 6 months, and they're doing a decent job. And finally, the customer is also very happy. So this is where we need to stretch out beyond our reach. Then I think we'll be able to do much.
Thank you, Professor. So I think I already got a chat that we have to wind up faster. So it won't be good. It won't be nice if I don't give opportunity for the audience also to ask some pointed questions to the panelists. So we have eminent panels over here with various expertise. So I invite a couple of questions from the audience so that we'll be able to.
Check, check.
Check, check.
Should I go ahead? Yeah, you should ask. Okay. But we'll move the question that was true.
Yeah, because actually I wanted to look at the ministry also. What we heard from these respected joint secretary was that there is a lot of funds available from the ministry also for the development of the industry. And to put the question then to Mr. Menon and Vijay also, because Mr. Menon made the comment that being resources may not be available for new developments. So I don't know, can these funds that are available at MHI, can they be used by the industry? That was my question, actually. I don't know. We have from representation from the ministry.
Is a question to the panelists or the MHI? So I am part of the phase 2 program of MHI, running by MHI on specific technologies on robotics, IoT, and things like that. And my experience is like this: MHI is already funding it through academia, and the industry has to put some skin on it. And always I found the industries has got some reservations. What will be the outcome? I think Professor Ramesh Babu also mentioned about it, about the MTAP, the reservations to fund. Generally, the mindset of the entrepreneurs, I mean, Vijay is here. I'm sure that he will also air some views after I complete this, is how much they can invest on R&D and how quickly, like capital industry, the manufacturing industry is expecting an ROI, how quickly the return investment on the investment is going to come, how soon. So there is a lot of skepticism into the outcome of the research. That's number one point. Number two is, it's a chicken and egg story, right? The consumption, if you look at the consumption of robotics in the country, right? Though everybody thinks that it's going to exponentially rise 5x, 10x, next 5 years' time, it's assumption. And it's based on some judgment and statistics and data. Unless we form, I think it's a wonderful suggestion Arun was mentioning about the cluster formation of robotics and also involving the users of the robot, the challenges that face, and academia and the robot manufacturers. I think we need to have a national level cluster, maybe multiple clusters, to focus on this. If we don't do that, even if the MHI funds it, and there is no visibility of fructification of the fund being utilized, I'm sure that Ministry and Government of India will also ask, I gave you 1,000 crores, what is the outcome? Nothing is happening. How many companies came out? That's a question to me. I went on asking, this country, though we claim that we are great in software, we are great in manufacturing, once it comes to product, the mindset is totally different. So that's what I will say. Ask Vijay to respond a little more.
I would like to respond to one or 2 points Arun also has raised it. See, in fact, if you look at the AMTDC has an ecosystem wherein I'm not directly interacting with only partners. The association is the one who is promoting it extensively since 2008. Because they are with me, backing me, supporting me in whatever troubles I face it. Because an academician cannot face the industry immediately, because see, your interests are different from our interests. You want to know tomorrow, but I cannot give you tomorrow. I need some time. So that is where the industry associations like IMTMA has helped us tremendously. Number one. Number two is the testing and validation cannot be done by us. CMTI having the AMTTF has supported us extensively to give the feedback on what we have developed it, how it is working, etc. So this sort of an ecosystem is built over 15 years. It's not in 1 or 2 years. 2008 when we started with some funding from the Government of India, from PSA's office, it was a pre-competitive R&D. It was not a competitive R&D. But when we succeeded, with the ecosystem built, we got the confidence that the same ecosystem can be emulated to make it much bigger and broader. That is where I feel that no, some people have to just look at it. See, with open eyes, without having any fear or see, the fears are always there. I'm telling you that every day I have a fear of delivering something to the industry. But then when you have an ecosystem supporting me, I can just leave the burden on them and get the solution from them also in whatever way it is. It is not that I'm going to perform a miracle. I'm also a human being, who has to sustain the pressures also. So that is where I feel that the ecosystems have to be built in different places with a commitment of delivering something, not utilizing the funds. This is where I feel that no, we need to have that sort of a change in the mindset of everybody so that the next generation can really benefit from all our experiences and then guidance, etc. That is my feeling.
So I'll just add a few points here. See, markets don't wait for us. And entrepreneurship is basically you have seen the opportunity and you want to go at it very fast. And for us, it took almost 10 years, to get to where we are, to bring really a competitive product to the market, and that's the kind of work that requires, especially in deep tech. And now no VC is interested in investing in a company like it. Yes, of course, once you are successful, everybody wants to come. But then it's a 10-year journey, not just for us. I think I'm sure for a lot of companies who are into robotics, because I think today you want to hear about the nice glossy story, but what's behind it, right? Yeah. Hello. Yeah. But this has to be a fortuitous collaboration between the company which is making the product, the end user, and also the institutions and the academics, right? And the institutions could be the funding agencies from government like MHI, DRDO, or your academic, where they bring a lot of the forward-looking research, like say, especially in AI, ML, or analytics, deep analytics, which can be converged with robotics. So I think they come at different stages. If you ask me on day one, no, probably I have to get into the market and prove my mettle even before I can approach the funding agencies, and obviously I have to, so we need some revenue stream, So I think these are like a bit of a catch-22 situation for us. And for me, right, I know the Joint Secretary is here and he's listening. So what I would say is, one, I think you can't just give a grant to the company just like that because you can't choose the winners. But can we, as an MHI, because the mandate is to help the industry grow. So can we increase the adoption? That could be actually eliminating one big barrier, in terms of the SMEs, right? I'm just out of the blue. I'm just giving, if he brings a certain amount to invest in the technology, will the government also help him to adopt that technology? This could be a big, because the other day, I think there was a company which asked me, do we get any grants or any help from the government if I'm going to introduce robots into my ecosystem, So this could be helping companies like us in an indirect way.
Nicely mentioned about it. I think Joint Secretary is also hearing all the comments. We'll put together all the suggestions of the panel members and send it across to you. The challenge, what I could, just to conclude the session at this point of time, we are running out of time.
Sir, may I add a couple of points, please?
Yeah.
Thank you.
Last question from the audience.
I'm not asking question. I'll probably add 3-4 points, which I thought will add value. Hi, Arun. Vijay, we met. So my name is Yogesh Kumar. I'm from De facto Robotics and Automation. I just wanted to put some numbers to the discussion that we were having. See, 2021, the post-COVID year, saw a rise of 31% in the annual global robot market. So out of which a majority of that went to China. Almost 30% of those robots went to China, 5% to Japan, 10% to Americas and the rest of the countries, the rest of the robots. So Asia being the biggest market, our share, the Indian share was probably 1/10 of China. I'll want to put in some other metrics. Globally, they measure the robot population with number of robots per 10,000 factory employees. So this is a very interesting metric. The global average is 129 robots per 10,000 factory employees. Europe stands at 129 robots. Asia 156, USA 117. Any guess from the audience how much would be India at?
Mentioned about it, 4 to 7.
4 to 5.
Yeah.
So sorry, I missed that. So we have a huge scope, on the robots. Also, Vijay mentioned about he doesn't believe in lights out factory. One of the major robot manufacturers, Fanuc, their Japanese factory is a model for lights out factory. Every Friday they turn off all the lights. The production runs. Robots manufacture robots throughout the weekend. So that might not be a very far off thing in India. Probably we are a few years behind, but that's something which will happen. Third thing is to answer to Mr. Rajesh Nath. You mentioned about the grants from the government. China, see, in India, we have about 8-10 most prominent global robot brands. Okay, and of course we have new brands like Swaya coming in. China alone has more than 100 robotic companies, and they're funded by the government. So this is something which our country, we should also look at, how our government can promote these upcoming companies and support localization of these robots. So you also mentioned about component getting locally from India. Now, this is a question that, once again, a point to ponder to all of us. We have Boeing, Airbus, all these guys getting components from India. We are able to deliver very high quality parts to these big players. Why not make it for ourselves, for our own products?
Okay, I'll just conclude the session because we are running out of time again. What works for China, Japan, US need not work for India. Please understand, that is not ape what is happening all around the world is going to work here. India is a diversified country with its own challenges. But I like the point what you mentioned about the government involvement in the Chinese industry, and hence the Chinese market share in the robot globally is much, much higher. I'm sure that Government of India and Joint Secretary who's sitting here will definitely listening to all the conversations. We would like to recommend, we'll sit together after this discussions, few minutes, and put forward our thoughts, points, what we already deliberated. And I'm sure that Government of India is very positive in ensuring that the country is getting into the manufacturing world and don't lose the race of the robotics revolutions. And with that, I think I should like to thank all the panel members on behalf of everybody, CMTI, ISC, and Government of India. Thank you very much.
Thank you for the panel discussion. I now request Shri Vijay Mittal, Joint Secretary, MHI, to present mementos to our esteemed panelists. Firstly, the moderator, Shri Krishnamurthy Raman. Professor N. Ramesh Babu. Shri Arun K. Menon. Shri Vijay R. Salem. And Shri Pradeep Hegde. I'm requesting all the panel members to kindly join on the dais for a photograph. Thank you, everyone.
Yeah. We'll start the next panel discussion in about a minute. Thank you.
Good afternoon, everyone. Welcome to the panel 2 discussion. Yeah. The topic. I welcome. I kindly welcome the panelists first. The topic of the panel is human-cobot collaboration, job creation and skilling for or with robots. Now, I kindly welcome the panelist, Mr. Rajeshnath Babu, Managing Director, VDMA India Services, Mr. Prashant Doreswamy, President and CEO, Continental India, Dr. Kingshuk Banerjee, Director and Head of R&D, Hitachi India Private Limited, Professor Sudipto Mukherjee, Volvo Chair Professor, IIT Delhi. And the moderator for the panel is Professor B. Gurumurthy, Department of Mechanical Engineering, IAC. He is a Chief Executive for Society for Innovation and Development Center, IAC. I request the moderator, Professor B. Gurumurthy sir, to take over the dais.
Taken over. Yeah. Good afternoon and welcome to the panel discussion number 2. The first instruction we received was that you have 10 minutes less than what was originally allotted to you. So, yeah, I guess we have a challenge. You are lucky. Yeah. Okay. The title of our session is Human-cobot Collaboration, Issues of Job Creation and Skilling or Skilling with Robots. So it's a slight mishmash of 2 topics, but I have a very versatile and eminent panel with me, so I'm counting on them to see me through, right? So I don't know, all timings are off, so we will see how it goes. I'm just going to quickly make 2 points as my opening remarks, and then I will pass it on to my colleagues here on the panel. Opening remarks, and then we will start the discussion. I think the cobot, as I understand it, and for the purposes of this discussion, I'm taking it as yeah, and one of the promises of robots and also cobots has been the flexibility that they bring, to the workspace. Unfortunately, I think that the big robots never delivered on that promise because they still need jigs and elaborate programming up front, for them to even start production. So one of the things that I believe cobots have a role to play, at least in the context of India, is that there is a possibility that they can allow you to tune the scale of production, right, to the demand that you want to cater to. Right? Typically, what happens is that for most products, the technology is frozen by what is practiced in the West. And those are driven by volumes which are in the millions. While India has billions of people, but it's a very fragmented market. Right? And so it's very unlikely that in most products of some complication, right, you will see a large enough market to justify investments in these kind of devices, especially for the small and medium enterprise. So that's one thing that intrigues me, and I hope that we will get some time to talk about that, is that what role cobots can play in providing that flexibility, of matching the scale to the market available for a particular product. So people in the literature and the business refer to this as high mix, low volume production, right? So I'll be curious to understand from any of my panel members as to what the challenges are in ensuring that cobots can actually deliver on that promise of enabling, this kind of high mix, agile, low volume kind of production. The other point, and that has to do with skilling, is this debate that has been right there with us from the morning between, automation and assistance, right? I come from the school that, the robots or the cobots must play a larger role in assisting than in automating. But I hear different voices from my industry colleagues, and I do defer to their views. But nevertheless, again, going back to this number of people that we have, I think that is a question that we cannot neglect, so lightly, right? It has to be taken very seriously. So there, one of the things that I want to put forth is that can we use, the inherent nature of cobots, the ease of programming that everybody promises, and, the collaborative, facility with the humans in the environment for skilling, right? So I see it as a two-way process. One, can we use cobots to improve the skills of the human operators, right? And two, can we, develop technology that downgrades the kind of skills that you need to program and use these cobots, right? One of the things that practitioners mention quite often is that, you don't want a robot to replace the need for looking for highly skilled welders with the need for looking for highly skilled robot programmers, right? So the need for skilled, labor does not go away just because you have a robot in. It's just that it changes the nature of that. And therefore, skilling does not go away. And I think that it might be useful to think a little bit about this problem of, can we use, cobots to train people, removing tremor in their hands when they do welding, right? Or any other such task that we can think of. And B, can we develop technology that makes interacting with a cobot much easier? Therefore, the skill that is needed to operate that also comes down, and therefore opens up opportunities for a much larger population of people than it is possible today. So that's what I would like to open with. Start from my question here. Remarks. I'm not going to pose a question to him, but feel free to make remarks.
Thank you, Professor Gurumurthy. It's a pleasure to be part of this eminent panel. Maybe a couple of open remarks from my side. If you look at the world today, there's a lot of transformation which is currently happening, irrespective of the domain which you come from. If I have to talk about 8 such transformation, certainly one is everything has become autonomous, automated. Yeah. Yesterday I was pleasantly surprised when I went in for a Zara showroom in Forum. I was really surprised, pleasantly surprised to see a automated checkout system where you can bill on your own. You need not have a dependency on the person on the other side trying to scan those cards. Yeah, which we have seen in only the airports and certain airports and globally where you can do a check-in process. Here, that was really good. Second is connected living. I think there's a lot of consumers who use many different services to experience compelling new services with a combination of video, data, audio. Yeah. Then third such one is certainly Industry 5.0. Already we are talking about Industry 4.0. World is moving about Industry 5.0 with more of human automated collaborations. And the fourth is the digital reality. So there's a lot of things which are happening, be it in the augmented world or the virtual world. There's a mix of digital world into the virtual world. And sixth is heterogeneous society. This society is remaining no more homogeneous. So this society is moving towards heterogeneous data. How do we capitalize on the data? And the seventh one is sort of a Uberization, sharing of assets. Today, you don't depend really to own an asset. And the last one is some sort of concept called zero defect, zero cyber attacks, zero accidents, zero fatalities, you name, every industry is talking about zero. These are the 8 different trends, I would say, shaping every single industry in this world. So with that as a background, I think we have an apt subject. So how do we capitalize on this automation? Yeah. When you talk about Industry 4.0, for me, the definition of Industry 4.0 is getting the visibility of material flow in the system. So if you are able to get that visibility of material flow with that data, you can do many things. You can become much more efficient. And that's where once you have that, the application of cobots or the virtual reality or the use of automated guided vehicles, all this comes into picture. So make use of the data and use this assisted function so that you become much more efficient. At the end of the day, I think India, as an industry, we have to move from cost arbitrage to performance excellence and also being much more competitive in terms of the cost. We cannot continue to depend on labor dependency. I think we have to move towards this thing. And that has to start from leadership. Actually, we as a leadership, we are driving this new initiatives within this company. That would be my opening. Right. Yes. Yeah.
Hello. So good afternoon or good evening, everyone. Actually, if we look at the manufacturing, only hardly 8 to 10% of the processes are automated. So there's a lot of scope for automation, enhancing automation in manufacturing. And when we are talking about smart manufacturing, the aim is actually to make manufacturing CES. Now, what is CES? Cost efficient, effective, safe, and security. So we want to have these functions in manufacturing. Now, looking at our country as such, India has this unique characteristic. We have 63 million MSMEs, and 99% of the MSMEs employ less than 10 people. So the challenge is, how can you bring in automation? How can you bring in robotics into this MSME structure? And MSME you cannot ignore because that's the backbone of our industry. Almost 40% of the output is coming from MSME. Now, if an MSME has to adopt automation or usage of robots, he must see a distinct advantage in it. So if we look at, like, our topic of discussion is this human robot collaboration. So in which ways can the robots collaborate with humans? Either we can have processes where robots and humans are coexisting, each one is doing their own work, or you have processes where it is a cooperation between humans and robots. Robots are performing the task and human is supervising the task. Or you come into the third factor of collaboration, where the robot is working closely or collaborating with the humans. So in a way, it is helping to aid the human. Now, why would we require this human-machine collaboration? Now, I would refer to the 5 Ds that are there, which will give the advantage for tasks which are dull and repetitive, for tasks which are dangerous, for tasks which are dirty, where you have polluting tasks. Also, one more D, let me just come to it. Yeah, for the tasks which are difficult in nature, especially we heard in the session about automotive industry. Now in automotive industry, or if you look at, for example, the steel industry or the metallurgy industry, you have dangerous metal, hot metal. So that is where it would work in. And now the 5th D is a little bit of the impact of the pandemic, where you are looking for distance among people. So when these 5 Ds are covered up, I think the combination of robot and human works well. Now, of course, as we heard in the discussion before, can India, being a populous country, would it lead to job losses? No, I think, as Honorable Chair also mentioned, Professor mentioned, that actually we are going to see a transformation happening. The jobs will transform themselves, and you will see job enhancement happening. So the mundane jobs, the repetitive jobs can be done by the cobot, and the humans would need to go a notch higher, the supervisory. I think that is, in a way, it will also give better utilization to our human power or human skill that is there. And I think in such a scenario, you will have a good combination of the cobot and the human working together in a collaborative manner. Yeah, that would be my say.
Yes. Try yours and see if it works. Yeah, you can switch it off.
Yeah, hello. I think it's not. Okay. Okay. So thank you very much for making me part of this wonderful panel. It's a pleasure, and thanks the audienceship. Now, we just heard about 5 Ds. I'll talk about 3 Cs. So one C, so C, cobots are collaborative robots, right? Now, what are the 3 characteristics of collaboration? And I'm just trying to make up the 3 Cs out here. One is you have to cooperate with the humans on the shop floor. You have got to counter sometimes. Sometimes your colleague is unreasonable. You have to come up with a rationale and say, so it's not always cooperation. Sometimes it is a counter. And finally, when you are done with this, in this whole process, you have got to communicate. You have got to somehow get your views heard to your colleague, and you have got to get the views back from the colleague. Now, when I'm talking about a cobot, I'm talking about a robot and a human being working as colleagues on the shop floor. And the robot, today, if you see most of the robots, and as beautifully said by Rajesh and by Prashant, that they have to be safe, they have to be competitive, price competitive, And of course, you expect them to do what they're expected to do. But robots of tomorrow are going to be intelligent. They're going to be smart. They will have their minds of their own. That's where artificial intelligence comes. First, we human beings program the robots. Then we human beings teach the robots how to look at the data. The next thing the robots do, they start collecting the data themselves and they get smarter and smarter. And then finally comes the wonderful thing that Professor Gurumurthy was talking about, the robots teaching it back to the humans. And now, if you look at it, this is already happening in Florida. The surgeons, they cannot move their hands completely, right? I mean, there is a human wrist can only go that much. But the robots, that can go all 360 degree. So they can do the sutures and the surgery, the sewing much better. And now that they have learned it, they are actually trying to teach the humans what is the best way they can do with given the constraints that they have at that wrist. So cobots, absolutely the future of tomorrow. Robots with emotions, robots which are learning, most importantly, robots which are connected and which are intelligent. Now, with that, we'd love to, defer to my colleague, to my co-panelist.
This works, so I take it. So I need to have my slides in there, and I have the automatic flashing thing. Hopefully it works. So which way did it move now? Okay, now numbers. So I don't know if you know about Anton Exupéry wrote a book called The Little Prince, and the airport in Lyon is named after him, World War I ace pilot. So he lamented that adults always want numbers. So this is his quote. I'm also an adult. I think we are all adults, so I'll give you some numbers. So the human machine is a 200-watt machine as an energy source. If you put him to work over 8 hours, he's going to produce 0.2 into 1 kilowatt into 8, 1.6 kilowatt hour of energy, which is 1.6 units of energy in terms of electricity. 16 rupees if you're an industry, right? Domestic, much less. And if you're unfortunate enough to be a solar power supplier, then you'll get only rupees 4 for that amount of energy that you put in over a 8-hour cycle. Okay. So even if you look at our minimum wages, we actually pay that for cognition. It is not for the energy that a human being puts in. And certainly minimum wage in the US, India is 350 rupees, somewhere there. US it is 3,000 rupees. So that is paid for cognition. So we have cognition going around. Otherwise, we would not have the lifestyle that we have even in India today. So this is the first point which I want to make. The second thing is we want to leverage either the flexibility of human cognition to simplify the interaction for the robot. That's one option. And then we replace biological energy with electromechanical energy. That's a simple solution. Others, we try to add as much flexibility to cognition into the robot system to simplify the interaction for the human. So you enable labor with lesser skills to work on it, so that the labor is bored, might be sleeping off, but the robot will keep on working, occasional poke. Right? After all, we all know that humans don't like to think. So that's the second thing. Now, the question I think which is here is, going forward, do we pick the low-hanging fruits, which is just pumping the energy into the system, make it easier for humans, or we try to make it easier for humans by not asking them to think? So the second one, I think, is a difficult proposition we need to look at. So this is called Human and Robots on an Assembly Line Van Gogh style, because I typed this into Bing Create and it created this picture. Okay.
In fact, the earlier picture was also from Bing Create. So Bing Create is very good at making this picture. But the reality is, even now, automated production is fully automated. Sequences carried out exclusively by industrial robots, or there are full manual assembly steps where humans worked on allied tasks. Close collaboration is extremely limited and usually not possible, right? And over the last decade, these what are called serial compliance robots are available, KUKA, LBR, then there are the Barrett robots, and then now there are several more. They're around and they promise that, even if you go into it, it will not push you, it will stop. All of that is programmable. The tech is there, right? So you heard Professor Ramesh Babu, I think even Guru Murthy were around. Yes, they can be made. Question is, will they be economically worth it? So we are here today, perhaps because we have become significantly better at integrating abilities of perception, navigation, all this stuff into decision making and learning. So we are at a threshold where we can build robots that interact with people in more flexible ways, right? So you have Google Maps, it can decide how to go from here to the airport, but you still need the driver. Driving a car, which is, largely automated inside, right? Temperature control, you can have, but you still need the human being to avoid the crashes. So we can have robots to coexist, right? Side by side, no shared workspaces, sequential collaboration, not the same part at the same time, same part at the same time, which is cooperation, and then responsive collaboration. You learn from each other, right? Progressively, the robot is getting better and better, watching a human being sees how the robot does it, and he just mentioned you learn from the robot. This is a better way to do that. So all of that is possible. So the catch is, I'll come back to the German part later. So there's a classic example of a car seat to be assembled. So this is a classic paper in our areas. So you see that seat, and then you see on the left-hand side, there's a plate that had 4 bolts, right, 25 millimeter diameter. Well, screw and the hole have slightly different diameter. We call it a tolerance. Keep that. But when you put it in there, there's a problem. See, you have to jiggle the seat around to make it fit into the sheet because there are 4 holes. It's only much later that they realize that the better design is having 1 hole, which is 25 millimeter, and a slot, which you see on the right-hand side bottom, and then 2 more holes, which are oversized. So this can be assembled uniquely and does not require skill on part of the operator to jiggle around. So finally, when you do this, it is this seat which is robot ready. Not the earlier seat version with 4 holes in it, which are the same tolerance between the pin and the hole. So why did I put this across? Now, this part means, it's a very famous saying by Hilbert, which says, we must know and we will know. And inconsistency, somewhere in the second paragraph, and unknown are 2 greatest enemies of robotics. You can do cognition, but if you have inconsistency and you don't know, you cannot do robotics. And now this is the phenomenon, is that our undergraduate education, at least in mechanical engineering, is almost completely focused on building components and manufacturing components. So in the years to come, as an academician, I want to tell out to this full community that we need to rethink a little bit so that we deal in terms of assemblies, so that we can actually relax the component manufacturing tolerances, but we can build a full system which performs better than the system with the hard tolerances. So this is the call. There has to be some re-education so that it comes in, and then we have to rethink the way we design the products and make the products to make this collaboration possible. So that's what I have. So, well, there's much more. Time limited. Thanks. You're welcome.
Doesn't, yeah, it seems to work. Yeah, actually, following up on what Sudipto talked about, Dan Whitney at MIT Draper Labs, he had once written an article titled "Real Robots Don't Need Jigs, but Who Needs Real Robots Anyways?" Right? And the tenor was exactly the same, and that's why I remembered that paper, which was that if you ask students to design a robot for washing plates, right? They will go into all kinds of circus trying to, find grippers and graspers and fingers to apply to hold the plates, to apply the soap and push it under the water, turn it around, and then, stack it. But then the real solution, of course, is an airtight compartment where you can actually hit it with water so hot that human hands cannot handle, but the plates get cleaned. Right? And so that's something what he is also talking about. And I guess I'm trying to find a way to weave it into the conversation that we were intended to have, and I'm still struggling. So let me not take that point further, but I just want to go back and ask, one question from Rajesh Nath, and this, I think Menon had also mentioned it in his in the previous panel, the role of associations in getting companies, especially SMEs, to adapt new technologies, and Cobot being one. So I was just wondering if you have any thoughts and any examples from your VDMA experience. Yeah.
Thank you for the question, Professor Gurumurthy. I think certainly the role of an association. What is an association? Association, in a way, is something like an aggregator. There are various companies, members of the association. So association actually plays the role of a networking platform. So you can have the association can certainly play an important role, especially when we are talking about new technologies coming in, giving awareness, especially in this case, like I can also, Professor Gurumurthy, I can give some examples, concrete examples. Like as VDMA, we have done we did about 4 events on smart manufacturing in various cities across India. We did recently 2 events related to OPC UA, Open Platform Communication, which is very important. So the whole aim of this was, in a way, to educate the industry, especially what we heard also partly in the first panel about Industry 4.0. Now, there is a misconception that Industry 4.0 is something like a black box. It's very tough to adopt. Now, there are certain aspects. So what we've tried to really bring forth to the industry is that there are certain components or low-hanging fruits, what you can actually adopt. Even the MSME can adopt that because the cost factor is not very high. For example, let's look at remote monitoring or condition monitoring. Now, actually, if a machine breaks down, the MSME is more impacted than a larger company. The larger company has deep pockets. He can withstand perhaps 5-6 days or 1 week, but a MSME cannot withstand more than 1 or 2 days of a breakdown. So using simple tools like condition monitoring, remote monitoring, if you get real-time data, you're able to assess the real-time data and take remedial action. So if bearing temperature is getting higher, you have the data, you can change the bearing rather than wait for the machine to break down. So these are certain simple measures that even the MSMEs can take. And I think for MSME, it is important that the ROI, he gets a quick ROI. Now here you're not investing big amounts, you're using simple methods, and the ROI for the MSME in this way, he can really reduce the ROI. Similarly, when we talk about the cobots, for example, now one of the advantages of the cobo is that the cost effectiveness of the cobots. They are not very costly as, let's say, a traditional robot. They're flexible. You can move them around if you're changing your manufacturing or changing the product line, as was mentioned earlier also. You can surely move the cobot from, it can be mounted on a table, you can move the cobot. And plus, I'm a very firm believer that actually cobots give a lot of opportunity for women. Women can really start working on the cobots because it is not very complex also, and we, especially in the tier 2 rural areas, I think this really gives a good opportunity. And as we know, Mr. Mittal is also here, we need to have more women coming into our workforce. And I think there are some statistics that say if we can get more women coming into the workforce, there's a possibility that GDP can increase by 1.5%. So I think this is a really a good advantage to get more women employed in the workforce in India. And especially in the smaller towns where the work opportunities are also limited. So these are the advantages I'm seeing, and this is where I think a little bit of education is required to the industry, especially to the MSMEs, that utilize technology. Because as an MSME, there are certainly a lot of apprehension, cost factor, then they are not very confident now if they adopt something, whether they will have the manpower available or trained manpower for automation. So this is the message that should go to the MSME also, and it is imperative, we need to move the next level up. We cannot be at the same level. If we are talking of our country, we are looking to increase our export. We are looking also to how India can add to the global value chain. You can only add to the global value chain when you are making products of better quality, more efficient, your whole processes are more efficient. And for that, you need to adopt automation, a certain level or certain degree of automation. And this should be right across the board. Of course, the larger companies can do it easily, but it is the MSME who really needs to get that confidence to adopt automation.
Thank you. Yeah. So to both my colleagues from industry, just building on this, the fact that cobots have some advantages. Both of you, I figure, are fairly large companies, right? But I'm sure you must be having vendors that supply into you. So I would like to have both the perspectives. You as a large company and your vendors' shoes, if you would travel for a minute. Where do you think cobots applications really lie? What kind of tasks they lie? And second, in terms of improvements in cobots as future features and future improvements in technology, what do you expect? What do you want?
Thank you. We started this Industry 4 journey about 6 years back. And after reaching certain level of maturity in terms of data acquisition, then we slowly started enhancing the implementation of the adjacent technology, one such as Cobo. We are into automotive, we do a lot of electronic embedded products. Today, if you see in our Bangalore facility, we have in excess of about 20 Cobos. And it works out very well. Today, for ROI is less than 3 years. Because a universal robo costs you about 18 lakhs. And with the increase in the wages, what you factor in, and more so, you also started seeing attrition in the blue collars, especially in the advanced industries. So how do you negate this? I think this is one area which we have found, and globally, Continental uses in excess of 5,000 Cobos. Wherever there is a repetitive in nature or with our sharp products or which are hot in nature or intricate fastening systems, we started implementing Cobos, and it has been very, very successful. And the best part is when a human is working, then you have to factor many other things. Whereas when the Cobo is there, you need not factor. So to that extent, it's becoming efficient. So this has been our journey, and we continue to see where the opportunities are to keep implementing on the Cobos.
Going forward, where do you see the opportunities and what kind of improvements or changes you wish to see?
So certainly, I think one is today's challenge is designing of grippers. Still, we see a bit of a challenge there because every design is different there are no common grippers. So that's one. And second is, and also when it comes to India, the service supportability. I think that's one area. I think all this, I'm sure with the number of Cobo implementations going up, I'm sure they will be able to go up. But today, that's the challenge. So what we have done is we have invested upfront in terms of training our own engineers so that we don't rely on the service providers if there is a breakdown. Because when you are using a Cobo in an assembly, and if the Cobo breaks down, the entire assembly shuts down. In the sense, you'll not be able to do. So that's one of the challenge we saw, and today we are able to cope up with that.
Sure. And Prashant, you stole my words. So all that you said, I fully agree with you. And on top of that, there's just a couple of things I'd love to add. So more and more smartness, more and more that intelligence that we talked about, because India we have fantastic digital talent. We have a lot of AI, ML, that kind of thing happening. So how can we get these things, get these components, the overall systems get smarter? And we work on that. And the second thing is, and that is exactly what our clients also expect. Like, for example, we have a project going on in a place called Pilabara in Australia. This is a 168-mile railway line for an iron ore company, Rio Tinto. And Rio Tinto's, like from dumpers, truckers, they put that iron ore on those trains and ship it to the port. These trains are completely automated, auto rail. They are driverless. Now, of course, you can do that in Australia where there is hardly any people. You try doing that in a junction here in Bangalore. You have to have a game theory engine probably embedded because everybody is negotiating who is going to go first, right? So this is not going to be tough, but nevertheless, this is what our clients expect. As a Hitachi, as a global company, how are we transforming the overall landscape, getting better, getting smarter? And naturally, we expect the same from our downstream supply chain. So smarter components, smarter people to work with, that keeps us going.
So to come back to you, I have a slightly different question. So I can get this one. This is what. So one of the things that we've been hearing both from here in this panel and in the previous panel was that there are two problems right now in India, despite the large number of people that we have, is that one, for the jobs you need, people are not there, and that is true both in rural areas and in the urban areas, it looks like, right? Agricultural labor, the skilled varieties is not there, and industrial labor also is not there. That's one. And the other one, of course, is the cost. I think he just mentioned that the costs are also, becoming a little skewed in terms of the economics of all operations. So given that, and the fact that you have to do something with these people, who are otherwise not, being able to enter the market or jobs in manufacturing, how can you use, cobots for skilling? Anything. Just to sort of throw this thing at you, I was more thinking in terms of like exoskeletons, for say welding, right? Like a gripper that acts like steadier for tremors and, train them to follow a line or a curve or things like that. Just a wild thought on my part, but your thoughts on, can it be used for training?
Yeah, so, I mean, I'm part of a driving training simulators, right? So you sell them. So what we realize is you can teach some skills through these kind of trainers. It's possible. And yes, it needs a level of intelligence to be built into it to give you the impression that it is reacting to what you're trying to do. So that is a learning element, which is there. And so they can be used for training. But at the same time, the operator is always aware that it's an artificial environment. So when you work with these kind of systems, cobots or anything which has artificial intelligence, human senses it and refuses to learn lots of things from the system. So you can pick up, but not all of it. So that's my take on it. So empathy. So I mean, the human being realizes very early that that system doesn't have empathy, and it's kind of like a pushback.
Okay.
So I don't know.
Well, some, yeah. But I think see the organizer standing there asking to wrap up. But so I'm just going to throw one question, at each of you. I have to wrap up, right? There's no secret. And then boss comes, something. Yeah. So one quick word from each of you, either on, what India can do to become a manufacturer of cobots. You mentioned a price point that an international vendor was offering. I think in the previous panel, there were a couple of companies that were manufacturing them. I don't know if they match this price or not, but if we have to be a big player in cobots, making of cobots and selling of cobots, what we need to do, that is one question. The other question is this whole skilling question that, India needs to skill at scale, right? Unlike AI and, Python and, other tools, this can't be done online. Right? You have to have the feel of the machine in your hands, and you have to be in a lab, right? So how do you train the millions of people coming out, effectively? So either question, we'll go with 1 minute each.
Actually, a couple of things. What, as a company, what we have done is we started about 4 years back something called Software Academy. We are finding it really difficult, especially these Gen Zs and the millennials, for them to make them sit inside a classroom and teach them. They will never learn. So how do you digitize this, some of their learnings where they can do on a go? So this is one which has been very, very helpful. Today we have a lot more than in excess of 600 plus course curriculum, so which they can learn at their own speed, at their own at their own time. So that is one which has helped in upskilling, reskilling, to some extent unskilling also. Second one is industry. I think industry alone cannot do this. So we need to have this partnership with academia. So that's where we are also cooperating with some of the universities, where unfortunately in the industry, what happens, we'll never be able to solve all the problems. There are certain problems which will be left behind because of time. So what we are trying to do is those problems we are getting at universities where they can work and come with the solutions, which is being a win-win situation. Through this, we are able to address many challenges. Number three, in today, manufacturing contributes about 16% GDP to India's GDP, and the target is to reach about 26%. I think if you have to really read that, I think we have to put more goods into the system, so there has to be more consumption. And if that consumption has to happen, then it has to be affordable. If it has to be affordable, then you should be able to produce products at a much competitive prices. I think that's where this automation comes into play. I think this is more of a front loading. Still, I'm sure today 85% of the manufacturing GDP is from MSMEs. Whatever the big industries does, that's only 15% contribution, but I think this has to start at the grassroots level. That's why I was talking about this starts with a leadership, where you have to do a front loading, where you should be able to see the picture 3-4 years down the line. Don't look at today. So.
Yeah, I'll take from what Prashant said. I think looking at your question, Professor Gurumurthy, about manufacturing of robots or cobots in India, I think it has to be a harmonious play between, we have the industry on one side, we have the research R&D institutions, and of course, I would like to add academia and the startups also here. I think startups can also play a important role. Now, what is the advantage of startups? Startups are much more flexible, agile, I would say. Smaller setups, they can undertake projects, as Prashant said. There are some projects larger companies may perhaps take a little longer, but then working together with the startups, they can find a solution. So it has to be it has to be all four factors. It's part of the ecosystem if we need. And perhaps another thought would be, which I would, maybe the government can look at also, we have PLI schemes in various fields. Maybe a PLI scheme for the future could be on robots or cobots manufacturing in India, because if we are able to attract this manufacturing, and I think especially for cobots, it's a big untapped market. We've just started using cobots and very few manufacturers are there. So it's a huge potential, and especially considering our MSME structure. So if the MSMEs can start adopting, if there is incentive given from the government, either direct or indirect, as was discussed earlier, whether the MSME gets the incentive if they are utilizing cobots or some level of automation, I think India can become an important hub for manufacturing of cobots. But it has to be supported by the government, and also we have to see how this whole ecosystem, at the moment, I think there are some loopholes. So we need to plug in these loopholes so that it becomes a harmonious play between all these stakeholders.
Very quickly, on top of adding to what has been said before, the upskilling part, let's take it. One wonderful way of skilling up, at a mass scale could be augmented reality and virtual reality. That makes a lot of promise. It is still in infancy, but I think people who do not have direct access, at least at some level, we can give. And of course, there is the 3D manufacturing with the next generation, learning things, how physics and mechanics work in real life. We can create some replicas, other sort. Thing. And the other part is how do you make this is a much tougher question, but there are two thoughts. One is probably it will help us to have an icon. Like in Finland when Nokia was there, the entire telco industry, it exploded. And probably we need more encouragement and funding like the way MHI is doing for PLI, for startup. He knows no bounds. So we should encourage our young people to invest more time in understanding mechanical engineering, electronics, mechatronics, as opposed to getting the next job in Goldman Sachs as an investment banker. So these are the two things that come up.
Okay, so this works. So okay, working. So I used to be a skilled batsman. I could cover drive because I had done that 1,000 times. I don't put my finger into the burner because my mother told me so. Right, so that's education. So the issue is especially with cobots, we don't have them. It's a future technology. We have to understand that we have to educate. It cannot be a question of skilling. And we have to raise levels of people so that they start believing when we give them the data. So we need a set of people who believe in numbers, who understand that, yes, there will be some glitches. And that variability is something that we have to live with. We all do it. When I came here today, I didn't know what this dais would look like, but I knew that I could push a view across. So all of this is possible because we embrace the uncertainty. So that's different paradigm of thinking, and classically it is supposed that when we go through our education system, we learn these things. So instead of skilling, which is practicing and expecting that we have to be future ready. So yes, it needs a attitude change also in our approach towards employing people and the training that we impart to them. We tell them, yes, there are these uncertainties, embrace it. It will happen. There will be some glitches, embrace it, it will happen. And then take it forward. Very drastic, but.
Oh, unfortunately. Okay, so I'm sorry I don't have, because this instruction said close by 4:50. And we are 5 minutes ahead, so I don't have time for questions from all of you to the panel. I hope there will be another opportunity for us to engage, but I would like to take this opportunity to first thank the organizers for giving us this opportunity and to my wonderful panel for sharing their thoughts and views so patiently. Thank you all very much. Huh? I can take 1 or 2 questions? Okay, so before you clap. There is no time there. Oh, so at the cost of tea, yeah, we can ask some questions. So please go ahead. Yeah. Yeah. So questions from the audience, please. Or any member in the panel. Yeah. There's one there. Yes. Yeah.
I'm Dr. Rajan. You can hear me. Nothing motors. No, I think they can hear.
It's good. You go ahead and use it.
It's good?
Yeah.
All right. So I think at different levels, the skilling has to happen at the managerial level, at the operator level, etc. So anyway, before I go to the question, thanks to the Ministry of Heavy Industries, CMTI to organize such a the ecosystem starts here right now, as we have already started doing that. So Athi Motors, we are OEM making autonomous mobile robot. Professor Yogendra Shima had come. He mentioned about you. One time the customer, German customer came and said that, I want these things. He didn't say auto rickshaw, he said tuk-tuk. I'll take the person, 2 days, I'll give training, after that I'll put him. Your machine should run. If there is something change, you know what to change, and then it should go. The ease of use, at the end of the day, people forget technology. People forget product. Whether it can be trained and put onto deployment and use. That makes that the most important thing. So at the lowermost level, that kind of a training. And then for ROI, etc., where the managers, kind of operating managers do that, they need to understand whether this all can be deployed, etc. At the highest level, I think when we go for large scale things, can we take that decision? Is it capable of doing it? At different levels, the trainings are required, just not, all have to be in sync with each other. Otherwise, top management may think that, fine, we can do that. When you deploy, then you think, no, this is not working. Oh, this is working, I want that. So I think skilling at different levels is what we need to think, right from whether a diploma or ITI person, we take it and we can train that. Or from an engineering perspective, they also want to know about it. They're busy with production, but they also want to know about it. But at the decision-making level, they also want to know what kind of a thing, real-time analysis, condition-based monitoring. I just want to know where our, OEE or uptime things of, why things you couldn't do it? Or can we really scale up how the automation is working? So everywhere, the level of training differs. So that we need to identify and do that. Then I think we can find the right ecosystem partners too. So observation is that skilling is must at different levels. Ministry is, Mr. Vijay is, keenly listening to it, and panelists have, without any doubt mentioned time and again that's requirement. So I think we'll start doing it. Thank you.
Any other questions or thoughts? Okay. So PE is relevant. Thank you.
Thank you all for the panel discussion. Now I request Sri Vijay Mittal, Joint Secretary, MHI, to present the mementos to our esteemed panelists. Firstly, the moderator, Professor B. Gurumurthy.
Everybody's looking at you, sir. Thank you very much.
Mr. Rajesh Nath Babu. Mr. Prashant Doreswamy. Mr. Kingshuk Banerjee. And Professor Sudipto Mukherjee. Requesting all the panel members on the dais to join for a photograph. Thank you.
Thank you.
Hello. As we're running late, there is no tea break, but you can always grab the tea and you bring back. You can bring it here.
Check, 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 check.
I request everyone to come back to the auditorium. We'll be starting panel 3 discussion shortly.
A very warm welcome again. The topic for the panel 3 is network-enabled manufacturing using 5G, including robots. Now, I kindly welcome the moderator and panelist for the session to the dais. Shri Radhakant Das, CTO of Network Solutions and Services TCS. Srimati Monica Gupta, Capgemini Vice President. Shri Satish K, Head of Asian Pacific Standardization at Nokia. Shri Uday Halangedi Prabhu, Chief Innovation Officer, Bosch Global Software Technologies Private Limited. The moderator for the panel is Professor Bharadwaj Amratur, IC Director at Art Park. I welcome you, sir. Mr. Bharadwaj is a distinguished professor at IIC Bangalore. He is a co-founder, director, and research head at Art Park IHEP for Robotics and Autonomous Systems Innovation Foundation since October 2020. I welcome all the moderator and the panelists on the dais. Welcome again, everyone. I kindly request the moderator, Professor Bharadwaj sir, to take over the dais.
Thank you so much. Thank you for organizing this panel and also the panelists. And we had an excellent pre-panel discussion a few days back with the Joint Secretary. I think it was really good. Hopefully, we'll have a good discussion today. So the topic is basically about how next generation communication networks can help manufacturing, right? As you know, India, I believe, is 17% of the GDP is from manufacturing, and we would like to kind of increase it. If you want to go to 5 trillion, we have to really scale up manufacturing's contribution to the economy. But how do we scale up? Because scaling up, one of the issues will also be labor. And that is where automation and advanced technologies like communication technologies can potentially play a role. But in what way, what are the challenges, what are the roadblocks, what are the promises? I think that is what we would like to discuss. And out of this meeting, hopefully we'll have better understanding of what we need to do, and especially for the ministry and the government, if there are a few things which they can take and help support for the industry, I think that would be really a good achievement for us. If nothing else, at least educate and inform and have a good discussion. So with that very brief preamble, what we thought was we'll have 2 rounds of discussions, and then we'll open it up to the audience also for further Q&A. So in the first round, we wanted to kind of really ask the question, is it really needed? Are these next generation networks really needed? Is it just a hype? Because we have some very eminent people here from industry who are consumers of such technology. Mr. Uday Prabhu from Bosch, one of the powerhouses of manufacturing. We have from TCS and Capgemini experts who have global visibility as to what the global industry is doing, right? So it will be good to hear their perspective. And representative from one of the leading vendors of next generation communication equipment, Nokia, who is also here, who can share his perspective from the equipment side of things. So let me start off first with Uday as to from a manufacturer's perspective, where do you see, if you want to really increase the manufacturing's contribution to the GDP, what are the best practices, and what do you see is the need from a communications perspective, right? Are these advances useful to you, and in what form? And what are the roadblocks?
Yeah, thanks. Firstly, welcome to all the panelists. It's a very complicated topic. Thanks to the institute to have us here. Any technological upgrade is a question of economics, right? It's fundamental economics, especially in manufacturing, where cost per unit plays a massive role in any decision that you make, right? Finally, it boils down to that. If you take network-enabled manufacturing today, it's not just the network that comes into play, correct? Network is one of the enablers. You need to look at how do I upgrade my equipment? How do I leverage data, right? How do I convert the data to productive use, right? Because it's a fact today that many industries are generating petabytes of data, but less than 10-20% of it is actually used, right? So how do you actually do a holistic calculation about networks, products, software and look into account the overall productivity that it's going to generate. In manufacturing terms, you have a concept of cost per unit of work, right? So how do you convert that when you bring in a new technology? So I think all these factors play a massive role to take decisions. Being from innovation, no, we love technologies, right? We love to build stuff. But as they also talk about in innovation, what is the desirability, right? I mean, your question is, do you need it? What is the desirability of bringing in networks like 5G? The desirability is very good, right? For example, if you're trying to up your manufacturing by a factor of 2, right? It's not easy. I mean, all the manufacturers can be testimony to that. You need to increase the amount of supplies that you bring into the factory. You need to increase the productivity of your machines. You need to improve the quality of your workforce. You need to improve the kind of maintenance actions that you take in, right? And this is where a technology like 5G can do wonders, right? Because it kills the latency between multiple processes in the factory, right? And that's what it brings in. Today, if you assume that the time taken for information from plant to go to your supplier and the materials to come back takes time X, it's primarily because of the latency that is involved. But if you're able to improve on that, then you can get more stuff done. You can create topics like just in time, which has been a buzzword for a lot of decades. We can actually bring it about. If you're talking about the previous panel of collaborative robots, it's also about timing, right? How can you decrease the latency between operations to operations to operations, right? It is also important that you identify the weakest links in your entire chain, because if you have a very fast process in one place and a very weak process in between, then the weakest link causes your entire productivity to go down. So I think it requires a holistic thinking process. It requires innovation at every element in the whole manufacturing supply chain. And it has to be done systematically. But in terms of whether it is going to add wings to your manufacturing, absolutely.
Thanks. I think you have. Yeah, I think this point of holistic view is very well taken. But I think what you're saying is that networks is an important piece of the whole, and so it's good to kind of look at next gen technologies. Let me turn to Shrimati Monica. She working with multiple and so we'd like to hear from you your experience with your clients and customers in terms of their adoption of these advanced networks. Is it happening, and why are they doing it? Are they seeing real gains, and is that something the Indian manufacturers should also think about?
Okay. So hello everyone, and thank you for having me here. Referring to what Uday mentioned about 5G being a good technology to be considered for manufacturing. The first point which I would like to make is we need to look at 5G with a perspective. While it's the 5th generation of mobile technology, it's the 1st generation of industrial mobile technology. So there's a difference between the maturity, but then it is a technology which has been specifically developed for the industry. So the only and only KPI by which we can actually measure 5G is the success by how industry adopts it. If it doesn't adopt it, then 5G is a failure. Of course, you can have 5G advanced and 6G, but very simply put, that's the KPI by which we telecom professionals measure 5G, and we are right now very faring not very well with it. to be fair. And the reason for that is it is not easy to develop such a technology. Uday himself mentioned that network is just one component of the entire enterprise architecture. And again, the purpose of 5G is not to replace the industrial Ethernet or other short-range technologies. It is to act as a converging technology. And hence, it's a journey and it's a process. Globally, what we see is there is a clear interest on 5G. First of all, a lot of industry forums have contributed to the forming of 5G. The biggest one being 5G ACIA, which is, by the way, chaired by Dr. Andreas Müller from Bosch. So Bosch is playing a key role in defining the standards of 5G and 6G. So just to give you a global perspective, I will just take the top industrial equipment manufacturers and give you a perspective. Starting with Bosch, they are literally the champions who are kind of leading the global industry in defining what industrial wireless connectivity would be, 5G and the future. And which is where Bosch has already now evolved into defining what 6G means. One of the key requirements of 6G being it has to be an evolution technology to 5G. The one clear ask of the industry is that there has to be a continuity, there has to be a shelf life of a technology, which logically then helps in the adoption. And of course, this is also a clear requirement because the adoption cycle itself is so long that it better have a shelf life. So that's Bosch. If we look at Siemens, we had the speaker earlier today. This February at Hanover Messe, Siemens launched its first industrial 5G product. It's going by the name of Scalance M. So Siemens again has a lot of industrial connectivity products. The industrial connectivity products come by the name of the Scalance product line. They have Scalance N, they have Scalance IoT. Scalance M is their new product which supports industrial 5G. It is already commercially launched and its first pilots will happen by the end of this year and then of course the scaling. The other industrial equipment manufacturer globally would be Schneider Electric. Again, Schneider Electric has a dedicated program on 5G. The key areas which Schneider Electric is looking with respect to 5G is one on all the material handling. And this was mentioned by the previous panelists also, how material handling is a key requirement in the industrial world. When you talk of material handling, you talk of mobile robots or you talk of hoists and cranes on all those operations. So immediately, all of these operations have a key role when it comes to 5G, and this is what Schneider Electric is experimenting with. The other area is process automation. Specifically, I think one of our panelists referred the 5Ds, specifically for the 5D tasks, oil and gas, chemicals, mining, all those difficult, dirty, dangerous, the 5D tasks. That's where 5G or any connectivity plays a key role. So that's about Schneider Electric, their focus being on key process automation tasks and key hoisting operations, which will then impact steel plants, ports, energy, and all other sectors. On the other equipment side, not the heavy equipment, but for example, taking the example of Honeywell. Honeywell already has GSM 4G compliant products, and they are now upgrading them to 5G ready. You similarly have many other providers like HMS Networks and then Fraunhofer, IPT and others who are now coming up with 5G ready. So globally, 5G products, 5G industrial ready solutions are coming, but again, their availability is just starting. And just for everyone's knowledge, and then kind of finish it here, it's a bit of a detail, but the industry perhaps needs to know that the 5G development itself has been a journey. We first had 5G non-standalone technology, which used 4G as an anchor. And industry was just not happy. They don't want any dependency. Industry is very clear. They want to be independent. They want to be in full control. So they did not like 5G NSA. And plus, the other issue with 5G NSA was the fact that 5G standalone would not be compatible. So it will require a device change, which again questioned the basic requirement of the industry of the longer shelf life. So it is only now when 5G standalone is available, and now when private network maturity, where 5G in a box, small compact solutions are available, that 5G is now commercially industry ready. And so 2023, we are actually globally seeing commercial deployments of 5G. You can refer to the GSA reports and other many global reports. The top sectors where 5G is being adopted is manufacturing, mining, oil and gas process industry, and public safety. public safety, especially in Europe, where you can now use multimedia, video calling, location tracking, and all of that. Public safety, sunset of Tetra, and moving into 4G, 5G is another of the top use cases. So that's the global.
Thank you. Monica, I think what you're saying is that already manufacturers are coming out with products, and so that means they do see a business potential for this. Let me turn to Radhakant. Kind of going forward in this thread which Monica started, I wanted to ask you a slightly out of syllabus question. Put you in a spot. Not too much out of syllabus, but I'm just kind of thinking about, Monica mentioned all the big names, right? Bosch and Siemens and so on and so forth. What about the small manufacturers? You think they can benefit? Like, if I have a Pina, I have something where I'm making, you think they can benefit from this next generation technologies? So just your thoughts.
They have nothing to lose. Okay. That's one word. There's a lot of technology debts with the biggies, the people who have been just upgraded 3 years back. The OI would have been like 5 years or 6 years. Typically, it takes 10 years. But in the current age, it's a 5 years of amortization that would take. So for them, it's a difficult thing. We really need to know where to do 5G, where not to do. Is it a stepwise or just a leap? That's very critical. So we have done a lot of survey inside our group itself, Tata Group. It will be difficult. Yeah. So we've done a lot of survey in our own group companies as well. The organizations have their cycles of business. And typically there is a technology refresh cycle when it comes in. Blindly go with what is latest. There is no point of leaving with the technology debt. Now, what is the delta cost of going with the NEM or the network, which is 5G, 4G, or wait for 6G? What you see is that in a 5G to 6G, serious modulation changes are happening in access networks. So if you can wait for 6G, it is like, would you like to wait for iPhone 17, not buy, stay with your iPhone 6? That's again, it's individual choice or business choice. But what we do see is it's a delta cost. It is, if it is a medium scale organization, maybe around 3 to 4% of your upgrade cost will only go to networks. Anyway, you are upgrading your robots, you are upgrading your automations. The network piece will be delta. You have to have networks. Either you put Ethernet or you put a Wi-Fi. And we have seen I have gone to a lot of labs in AT&T. There is a very clear-cut understanding. With Wi-Fi, we can do so much. Unregulated, unreliable. Security is always compromised. We need to do a lot of spending on the securities. Whereas if you go for 5G, many people would have put his brains, it's in the 3GPP, security is taken care, your spectrum is regulated, interference is understood. So there is a controlled environment where you can do the reliable manufacturing. Now, topic of scaling. Of course, it gives you a scaling. It makes you do a lot of impossible tasks, which you can't do with a Wi-Fi or a wireline or a network. It's just imagine 4 milliseconds. A roughly designed network can give you 4 milliseconds. A maturing network will give you 10 milliseconds. Imagine a communication you're doing inside that coverage area. A typical coverage area in a band 78, low band, 1.2 to 2 kilometers, it will give the 40 watts ERP. So within that communication, let's say it's a 10-tar leg is 4 milliseconds. I was talking to one of the booth I had been, so how much of computation time you're taking for image analytics, how much of the process 1, 2, 3, 4, all over 100 milliseconds, you can actually manage your entire process. Imagine the precision manufacturing you're going to do. So a lot of things we are discussing, like how it will change the image of India. Of course, Indian products will look much more nicer, much more consistent in the quality, because it's, when you have a 5G network, your manufacturing outcomes is a consistent, it's a precision. You always have a right of rejection in the first round itself, in the conveyor belt. So all these use cases are done, you can always get a benefit. Answering to your question, if a small, medium, or small scale enterprise, if is starting to automate, he should choose NEM. Okay, nothing to lose. Maybe a minor cost, not a really big extreme cost. Now, cost. If you see the OEMs, we are also doing some bit of it. Cost and value are two different things. Same OEM X, OEM A will give you price in either in one or half or 1/3 or 1/4. Price could be like, actually cost could be 1/4. And the value it could be giving more. So hence the final offering price is based on the value it is giving. So based on the structure, you can always get a price benefits. And the MSMEs should take a risk. The reason is all these OEMs in the 5G is in a new stage. It's many cases only on a POC and POV, and they will give their best. And you can actually get a really negligible or very small price to experiment in your network. And maybe large industries like BOSS may not afford it, but the small ones can afford, and they can do it in the name of experimentation. Thank you.
Thank you, Radhakant. I think you made some compelling points. One is that there is an inevitability, is what you're saying. So you might as well jump on the bandwagon, but there are some real benefits, is what you're also saying, and the incremental cost might not be that much, especially when you look at scaling up. And you think about, maybe 3, 4, 5 years downstream, what network you have should be able to handle what is needed there. So, yeah, I think very interesting points. Let me turn to Satish from Nokia. You have been in the forefront of selling this advanced networking equipment, and you have also worked in Asia Pacific region. What is your sense from the manufacturing houses, the powerhouses in Asia, in China, Japan, Korea? How are they? Are they adopting 5G? I mean, are they much ahead? And are they competitors to 5G? I mean, like here.
Namaste. Thanks a lot for this opportunity. Very pertinent question, as in, like, we need not always start from scratch. We can always learn from experience of others. So from that perspective, it is very pertinent to look at what's happening in the other regions in our neighborhood. Certainly in terms of, say, industries in, for example, Japan and Korea, which is directly under my area of concern, and China, we have separate teams. But there certainly, first of all, awareness that connectivity is a tool to improve productivity, to improve efficiency, to improve safety, is kind of at a higher level as compared to other geographies. So first, that understanding is there. So if an industry, say in Japan, is told that, come up with a plan to, say, for example, improve your productivity by, say, for example, 3x or 4x, of all the tools that the industries who have been running much before wireless technologies came, they will be using all those tools. For example, how they tweak their production lines, how they optimize supply chain, etc. But then connectivity and getting intelligence to drive improvements in productivity is an important tool that they consider these days. So therefore, from that perspective, awareness as well as adoption is very high. They're also participating with the technology providers more and more in terms of indicating what their specific needs are. So, like, for example, I mean, not to take offense, but for example, in like academia, we like solving very tough problems, right? We want to create latency of, like, for example, in the like in the domain of sub-milliseconds, right? If you come to technology providers like Nokia, we are also not as bad, but almost there. So we also want to create the most compelling technology so that we can justify that, it has to be very sophisticated, and hence you can buy new ones. But then sitting as a technology provider from the perspective of communications, we have also realized that it is very difficult to predict and like prescribe to people like Bosch, what is it that you need? So the collaborative approach that we see in these geographies and you did not take name of Europe, but there actually is where we have the most, you know, where we have the most dynamic ecosystem, where people like Bosch, Siemens, Schneider Electric, plus technology providers like, for example, Nokia, Ericsson, Capgemini, and then you have got startups, device vendors, all of these stakeholders come under a single roof, and then they discuss what are the problems that you are facing today, what are the problems that you anticipate tomorrow, and there what role can be played by connectivity. So we see such kind of collaborative approaches across different stakeholders in these geographies, which is also reflected in the way that we see adoption of technologies there. So I think the most important thing is, adoption. As Professor Subito was telling, education is, I mean, if your mother says, don't put your hand into the fire, I mean, that is education. So like that, nobody has seen 5G before 5G came. So we have to use our shared experiences to really anticipate what could be the benefits, and what are the problems that can be solved maybe by using 4G today, which can then be projected to see what benefits you can get from 5G. So that's the that's the perspective that we have from the other geographies, that there is more participation of the different stakeholders, and hence leading to greater adoption of network as a tool to improve whatever their KPIs are. It can be productivity, safety, efficiency, whatever. Yeah.
Thank you. And I think you have hit upon a really important point out here, which will lead into our next round of discussion, which is the collaborative approach, right? So the groups are coming together. Because I think the next, now that I think all of you have made a very compelling case that we need next generation networks, it's really critical. So the question then is, and already, the bias has been towards 5G. I think you already made some a strong case for adopting 5G. But what is the reality? I mean, can we go beyond the hype of 5G? Where are we in India? I'm not concerned only about India, because this is important, because this is the feedback which the ministry can take and then pass it on to the PMO and other important people. Where are we with the adoption of 5G? Is it really easy to adopt 5G? Can the costs actually be brought down? Can we have more players, or are we stuck with a few big guys? This whole thing of collaborative approaches seems to be missing, at least. I mean, I don't see that in the country, even though we have been talking about it. What is it that we can do to do the kind of consortiums which are happening in Japan, Korea, Europe, and so on? So maybe I'll start off with Uday again to share your perspective. And I want to also ask the question, are there competitors to 5G? Are we getting blindsided? Like, for example, Wi-Fi, right? I know there are some issues with Wi-Fi, but as an academic, if I want to do research, it's just much easier for me to get a Wi-Fi system. I can buy it over Amazon and get going, whereas 5G, I still haven't been able to get a 5G system, and Satish knows. I mean, it's much, much more complicated. So how will innovators even come in and develop solutions? I mean, what is needed? So,
yeah. I think I want to switch the conversation a bit away from 5G to what you, as I said, what are we trying to achieve? You need to look at it from a manufacturer's perspective, right? A manufacturer doesn't look at 5G as 5G, right? He looks at how can he manufacture something at the lowest cost, manufacture something at scale, at speed, and also look at how can he manufacture it reliably, right? So fundamental principles of manufacturing, whether Wi-Fi does the trick or 5G does the trick, is a matter of economics that you need to build into your design, right? And if you look at it on these points, right, scale is becoming one of the biggest challenges for manufacturers, right? Especially small and medium enterprises. Can they get the market to generate scale, right? And once that scale is generated, then the economics starts to fall in place, right? And so you need to, again, go back to the fundamentals of how can I create an ecosystem where I can achieve that scale at the lowest cost possible. And that's where I think the power of networks comes into picture. How can the industry come together for adoption? So the greater the adoption, then the lower the cost, right? It is difficult if a few manufacturers pick up the gauntlet because they have the ability to, right? The costs are going to come down for the whole population only if there is mass adoption, right? How can you enable mass adoption? That will become the next question. Can governments get involved to support that accelerated adoption? And then the question comes into how can you innovate on top of this speed? Now you have established very fast highways, right? Basically, you can consider 5G as a ultra speed highway, right? Now, do you have the cars to drive on it, right? Do you have the right tires? I think you've seen a lot of examples of great highways, and then you have tire bursts happening, right? So you need to add on to the networks with products that can actually use that network speed, right? So you have the ability to transfer gigabytes of data, but what exactly are you doing with the data? How can you use the data? So how can I bring in artificial intelligence? How can I bring in smart robotics? How can I use the data to do predictive maintenance? How can I use it to shorten supply chain latencies? How can I use it to collaborate with my OEMs and create just-in-time networks? So I think the fact that 5G can provide that infrastructure highway is understood. But what are those use cases that we can create? No, in Bosch, we have a concept of reliable distributed systems, right? So today we have a plant in Dresden, which does semiconductor chips. It's one of the most automated facilities in the world, right? We do the 300 so we do the silicon for autonomous driving there. And it's completely automated and it's wired. I think the stats are like 500 kilometers of cables, right? So why do that instead of 5G? But the point is that you look for reliable distributed systems, meaning you are looking for latency, you're looking for reliability, and you're looking for redundancy, which is currently offered by wired networks, but it is in the roadmap with 5G, where your low latency networks are going to come into play, right? And so once you have the reliable distributed systems, then you can introduce closed looping. You can introduce robots that can collaborate with one another because there is determinism in the whole network, right? Like you have in automotive vehicles today with so determinism is important, reliability is important, and this is in the roadmap for 5G, right? And so people have to make those bets. Today, already with release 15, 16, you are able to get more than 10x of productivity with 5G, right? You can get 10 times the amount of data transfers possible. So what are you doing with that? You can do much already. But if you lay the foundation today and then plan for automated systems, plan for collaborative systems, plan for reliable distributed redundant systems, then I think there's a huge amount of possibilities. But for that, the industry has to come together to do adoption on a common scale, right? If it happens in pockets, then the adoption is going to get slower, right? So how can networks, I think we have created certain networks, special interest groups on robotics and 5G and things like that. These have to gather steam to make recommendations to the ministries, create say maybe clusters as a panelist mentioned earlier, and create more buzz, more use cases that SMEs can take as examples, right? Once you create strong templates, then the templates can be rolled out faster. I think that's what is necessary.
Yeah. Yes, I think you have raised one really, I mean, among various points, I pick up on your point about scale. That is, you need to create large volumes to get the costs go down. So it's a chicken and egg problem. How do you create the volumes? And you're suggesting getting people, groups come together and so on. I wanted to turn to you, Monica, to get your perspective on what are the roadblocks for us in the country to adopt 5G at a much larger scale, especially for enterprises, right? If you want enterprise to set up 5G. Do you see some roadblocks which are there which can prevent them maybe, and other things which maybe one can suggest to the government to help, and support?
It's fine. Okay. I think I'll mention the roadblock, but I'll also kind of mention the solution because I'm working closely with the Department of Telecoms. I have some visibility as to the work being done. So I think the biggest roadblock, and to which I think Uday also mentioned, is the entire local availability of solutions being available at the price point and which our country operates. We are a price-sensitive country. We are a high-volume, price-sensitive country, and all the global solutions for any new technology will always be on the higher side price-wise. So basically, to cater to our Indian requirement, we need solutions which are one low in cost and even more better, which are localized, because then they can cater to our local demand. And that's exactly what Government of India and Department of Telecom is now trying to activate. First of all, the initiative of the Interministerial Committee and the 5G web program, they're trying to activate the Indian ecosystem to get more active and collaborative when it comes to new technologies, specifically 5G. The other one is the 100 5G use case lab program that is primarily only open to domestic companies. This is again to activate Indians solution providers to be ready with 5G industrial grade solutions, which can then be used for these use case labs. The third point would be, I think, the devices, which automatically, logically will flow both from the labs and also will flow from the telecom service providers, the CSPs, because once the demand picks up, and this is something which at least I learned today, that bulk of our manufacturing is through MSMEs. And one key thing which is there for MSMEs is the fact that the solutions have to be standardized. And the MSMEs most likely will either put a very lightweight 5G solution or will typically use 5G solution as a service from the telcos, because that's what will be easy to deploy, low cost, easy to maintain, and then also meeting their requirements of if you're catering to 63 million MSMEs, then you also need the pan-India availability of 5G, which only the telcos can provide. So in that regard, if you look at the situation today, the telcos are rolling out 5G, so that's the availability is there. The push towards 5G for industries is coming with the local ecosystem getting activated. That is also there. So I think it's now just a matter of time, and specifically a call out to Uday's point, we now need the industry to get activated to come up with these standard templates, use cases and all, basically create showcases, lighthouses where it works. And the other comment which I have with respect to 5G, and to which Uday also mentioned, is exactly the timing thing. If I already have a working Wi-Fi 4 or a Wi-Fi 5 solution or a latest Wi-Fi solution, why would I change? I mean, in the end, what I need is wireless connectivity. Does it really make a difference between Wi-Fi and 5G unless there is a compelling need? So in that regard, at least my understanding, given the fact that we are doing industry 3.0 and 4.0 together, and most of us, at least in the industry, don't use Wi-Fi, as well look and invest in new technology. And one caveat which I think we need to make the industry aware is, if you look at the old technologies of Wi-Fi, Wi-Fi 4 or Wi-Fi 5, they are not compatible with the later versions of Wi-Fi. Wi-Fi 6, Wi-Fi 7, you will have to change the device as well. So if you're investing in a new Wi-Fi 6, Wi-Fi 7, as well look at 5G also and do a cost benefit analysis. If still the localized solutions don't meet the price, please go ahead with Wi-Fi. Hopefully that would not be the case, because the local points will meet. Just to explain you this with an example, I don't know, many of you might have read up. It was a big news 2 weeks ago. Apple has opened up the entire Apple solution, the Apple devices, to 5G for industries. How? They have basically opened up Apple to support private network setups. So from iOS 17, any Apple device can latch to a 5G private network. Any Apple device. And they are now implementing industry-specific requirements like geofencing and so on and so forth. We perhaps need an equivalent of that in India.
Thank you so much. I think I want to pick up on 2 points and kind of pass it to Radhakant on those 2 points. One is, so I mean, the sense I get from you is that we don't need to ask anything more from the government. We are good. It's only the private people's job now, right? I mean, the industry has to drive it. So no work for you. But I want to come back to that because you also mentioned private networks. I think enterprise would like to have private networks. Is there, and then, from in terms of enabling more service providers to enter rather than just the big three, is there something we can do, the government can do to enable that to happen so that we have many more people who can offer such services? Is there any issue with spectrum? Are you happy with what spectrum policies are there? Does anything need to be changed? And I was told that we have only 10 minutes, so I request you to keep it, please. Yeah.
Your first part was the question, second part of the answer.
Okay.
Yes, government has to do on the spectrum. There is a lot of sensitive issue. So sensitive issues in the sense there is a lot of money spent by CSPs, the service providers, to buy these expensive spectrums. And whereas if they open it for the enterprises, there is a lot of money in the table which it will be considered. And I can understand the situation from the audience. I work with all of them mostly as well. The other part is there are two ways these spectrum works. One is on the FR1, which is actually below 6. Which has very high penetrations. It also means actually it can penetrate the walls, and it has much more propagation characteristics in terms of loss. But at the same time, it cannot go far. So if you have a small industry, it has, let's say your boundary is around factory floor is 400 meters or 600 meters. Better go with band 258, which is 26 gigahertz. It is very small form factor. Cost is very low. If you talk about your previous question, so what is happening? There are a lot of solutions available on the FR2, so which we call as density, densely populated 5G networks, all this stuff, it is there. On the device perspective, from the industry, we are not talking about handsets. The IoT devices, CPs and all, they are very much there. China, Taiwan, and India also coming up. And I think the voice ecosystem is doing very well. There are a couple of organizations which Mr. Modi's government has really done a fantastic job. I'm there for the last 3 years. They have been doing a lot of, this is the first time government has actually started giving to the private sector. It was always going to either academias, that too only IITs, not the RECs. Then it was only going to the CDOT or the respective government or public sector organizations. But private sector, it is the first time government is giving, and a lot of them are benefited. In this Bangalore, at least I can count 10 of them who have at least built some products, built some prototypes. And this, India-US, the Prime Minister's announcement, that gives the testimony that we have an ecosystem which is pretty much readily available. We are ready to deploy this in the US rural networks. So they want to swap their Chinese equipments, and Indian ecosystem is already ready. So your previous questions about whether India is ready or not, the ecosystem is available. In terms of the equipments, the CPs, they are there. Handset wise, there's a struggle. The price point has to come down. But yes, hopefully that answers.
Thank you. I think you're very optimistic, and that's good to know. I want to kind of pick up on some of the threats all of you have raised, which is creating a consortium, creating use cases with people coming together to drive the ecosystem. The government is also very supportive. And I want to ask Satish to again kind of maybe share his perspective with the learnings, what we have seen, how it works in the advanced countries. What can we do out here to really push it further? And can MHI do something, especially in some way, to help accelerate the adoption of these kinds of technologies?
Sure. So I'll take an example of how in other countries some things have been a success. We have a forum so we have a forum in US, NextG Alliance, which is working on 6G related pre-standards, concepts, discussions, right? So there, America realizes what its strengths are. It is in the web scalers, right? It is in the university research, and then it is in the big market. But then in terms of actual equipment providers, because of whatever acquisitions, mergers, I mean, that is now concentrated either in Europe or in China. I mean, so that particular organization will not, I mean, whatever success it has come, it would not be without participation of people with competencies who have been allowed to participate from other geographies. I can very humbly claim that NextG Alliance is actually nothing without Nokia and Ericsson's participation. So why I gave that example is here in India, like Uday and others mentioned, to promote network-enabled manufacturing, there are actually different things that we said. There is one part which is the actual network, then you have the devices, then the most important part is you have to create a software stack that allows network functions in a way that has to be exposed to the users. Because nobody wants to understand whether, there is a handoff that is going to happen when a robot moves from here to there and hence he has to stop or do something, right? So all those things have to be abstracted, and so that kind of exposure layer has to build. There is another layer of software that has to be built so as to make networks easy to deploy. So there are so many problems to be solved. And in these use cases lab, and I want to be a bit provocative, Mittalji here, is that, I mean, there is a specific thing where, government should do. So Monica said it is only, so all these use case labs are only open for domestic manufacturers. So which means that you want to attack all the problems at once with domestic stakeholders. One way or one possibility to look at it is you can have different of these 100 use case lab. You can have 25 use cases lab where you are focusing on, say, for example, devices, use cases. There you can get more mature equipment vendors from outside so that at least those labs get set up. Then in the other 25 labs, you get domestic vendors for the network equipment, and you get device manufacturers, software stack from outside. So that kind of a hybrid approach in a way that actually suits our strengths has to be seen here. Like in US, they are actually relying on their strength in terms of web scalers and software providers, Amazons, Googles of the world. I mean, those are the ones who are their strength. And then they are collaborating with others in the world to develop that ecosystem and develop all the products. So all I can say is that maybe government can take a cue, and there are many friends of India, and I think we should leverage that friendship. If we don't use that, then it's probably wasting that opportunity.
No, I think I personally really agree to what Satish just said. Another thing of what MHI can do is, so taking a cue of what other countries have done. So for example, when the Winter Olympics happened in South Korea, the entire South Korea gave a push to 5G deployment as an initiative for Winter Olympics. Paris Olympics are happening in 2024, and Capgemini is a French organization. The entire Olympic village will be 5G enabled. The latest of the use cases, be it smart campus, be it smart games, everything are being deployed as a showcase, and the entire campus will be 5G enabled. So similarly, perhaps MHI could look at some industrial corridor, which we have. We have industrial export zones and all. Make one as a 5G campus and use that. And at least our learning globally, and I hope all other panelists will agree, the journey from the labs to the industrial environment is the most difficult one. And that is where MHI can come and play a role. The labs is something which the Department of Telecom is pushing the equipment and the infra. You all push the demand. Hopefully the two will converge and magic will happen.
Great, thank you. I think that's a very concrete suggestion of setting up this real live use case centers in some sense, where it can be a great place for others to come and learn, and and vendors to come and showcase technologies. I think it will really spur the entire ecosystem. Now, I think we have a few more minutes left, and we would like to invite the audience to ask a few questions or comments. Yeah.
Can I? Dornath, my guru. Today is Guru Purnima. My guru is there. Okay, I am Chandramouli. I am zero on technology, especially maybe minus on 5G technology or telecommunications. The question I want to ask you, if the entire value chain, take for example an automobile industry, from tier 3, tier 2, tier 1 to the OEM, such as Tata Motors, Toyota, TVS Motor, etc. Can we look at a seamless integration of the NEM, as it were, and look at the project in a holistic manner, which I call as a hub and spoke model, right? And we made this proposal to Honorable FM also, a couple of years back. Various forums. Hello. Hello. Yeah, the moment I said this, it went off. Anyway, so how do we make sure that such a technology has a far-reaching implication and not look at point solutions in MSMEs, in a company, etc., etc. If the Olas and Zomatos of the world could exploit IoT, right? The manufacturing subsystem can exploit it only when the entire value chain of a given company and then multiplies over several companies can do that. So I could not get that in the panel discussion, so we can throw some light on it. Thank you, sir.
Would you like to?
Check. Yeah, I think that's a very utopian world that we are envisaging. Like I said in the beginning, it's all about economics, right? Network is just one infrastructure enabler. You need to bring down, you need to create new products, right? You need to innovate on new products. You need to make products smarter, capable of harnessing the power of 5G. You need to build software on top of the network for seamless connection between multiple supply chain vendors. You need open networks that will communicate with tier 3, 2, and build this basically what we're talking about is a just-in-time network, which is the holy grail of manufacturing. As and when I need material, it's available at the lowest cost. And as I produce, there is somebody who's ready to consume, right? If you're able to build that seamless network, also create demand, right? You need someone to buy the products also. Then I think it is a possibility. But market dynamics will always come into picture. Competition will come into picture. You will always have pressures on both sides. But it's what everyone aims for, and tough one, but it's a dream.
Hello. Just to add to that point as a follow-up question. Today in this country, Toyota is 100% on just-in-time. They got a third rank or consistently over 15 years. They physically went and saw it. So for the manufacturing subsystem, it is no more a dream. If the IoT subsystem can enable this, I humbly say, a project on this nature is very much possible. When we talk blockchain technology, we talk the same thing, right? Thank you, sir.
I think it's a very interesting perspective is saying, can we take a slice, end-to-end slice, and really showcase and, can I develop that? And it's something for us to think about. One last final question, I guess, before we go.
This is, can you hear me? And that the mic works? Taking the point on what Monica said and what Professor Yu said as well. 5G, you said, is the first mobile technology for industry. I don't know, but just say why you think, what makes industry friendly? That's the first one. The second one is that do we need to be worrying about cybersecurity if 5G is getting adapted? And the skill levels will be quite high, for 5G in terms of the usage as well. The last point, I think, Professor, would be kind of ask this question, I didn't get the answer. What are the alternatives we have for 5G?
Okay, so 3 questions. First one, why did I say that it's the first generation of industrial 5G? So the feedback from the industry and the enterprises all along to the mobile technology, and this is to the standard bodies of ITU, 3GPP and all, was that mobile technology has always been very consumer focused. And which is where IMT 2020 vision was set up way back in 2012 to gather the requirements from the industries, and which is where then, all these requirements came in from 5G SAI and many other. There was European Union's 5G PPP program and many other such programs where these requirements came from the industry, which constituted all the requirements which Uday and all of us have mentioned about, high latency, high throughput, low latency, data being on site, basically the concept of private networks, security, to which you mentioned, basically a security by design. Also industrial features like location positioning, deterministic latency, time sensitive or time guaranteed protocols over 5G. So this is the reason why it's the first generation. Prior to this, all other standards were more of consumer focus. So that's the first question. The second question was about cybersecurity. So 5G by design has this, and also, end-to-end enterprise architecture, including wireless communications. How to address security in that is a topic. I think that risk is higher with Wi-Fi because it's an unlicensed and unsecure technology. There are already solutions available with 5G. One, the technology supports security, and two, using quantum encryption and many other solutions. Security is definitely a key point of 5G. And the third one you said about...
That was more, I was looking towards it to say that you asked this question twice about alternative. Did you get an answer? So each must answer.
Yes, there are alternatives to 5G, the most obvious being Wi-Fi and even satellite in some cases. So just to add to your first thing, and then I'll come to your second question also. So why we call 5G as something as the first generation is that because even the earlier generations supported some sort of IoT. It's not that you cannot, the most widespread IoT network in the world is based on 2G because of the great reach that it has, because the spectrum it has. So each generation supported some specific use cases. But then when 5G was big, it was actually built in such a way that it scales from use case that Uday mentioned, a very broad highway, very high data rate, very low latency, plus all the other use cases which are having lesser requirements. So that kind of scalability is coming from 5G. And then, so, that's why it comes. But then, like any other technology, you started with voice, digital voice coming in 2G, but at scale, it comes only after some time. So that came in 3G. Data got introduced in 3G. At scale, that you can now sit and do your email sitting here can be done only at when we had 4G. Similarly, 5G is the beginning. Things will take some time to mature, and it will probably, by the time we reach 6G, 5G will be mature and it will be available at scale. Then in terms of other technologies, the way 5G approaches is that it is not taking them as alternatives or competitors. The architecture of 5G is such that you can leverage Wi-Fi with the same core network application infrastructure without any disruption to the users of the technology. Whether you want to use Wi-Fi as an access, satellite as an access, native 3GPP or 5G radio as an access. So that's why 5G, in some sense, at least conceptually, is a very attractive technology because it does not look at other technologies as competitors, but it is an umbrella which can encompass all these alternate / competing technologies for wherever it fits best.
I think we're negative in time, but maybe one last very quick question and maybe a quick answer if it's a question.
Hello.
Yeah.
Obviously, I think 5G seems to be a very disruptive technology, especially when it comes to manufacturing, because you see most of the manufacturing is running on field bus. Like you have EtherCAT, Ethernet, Profinet, and all of these are being the companies who have
promulgated the standards, they're very protective about it. So how do you see, I mean, in a way, you are trying to compete and disrupt the existing field bus networks, which have been implemented almost all in, like, if you go to the bigger companies, almost 100% of them are either on one of them, and there's an entire ecosystem that's being built in terms of like the standards, the conversion from one protocol to the other one. So how does 5G play out in this?
See, 5G and access technology, okay? All the protocols you have mentioned, they're actually connecting sensors. But you have to cluster the sensors. Then between the sensors, you can have this access technology through, it is called G node B in the 5G. So you can always have NB-IoTs, you have IoTs, you have a cluster of sensors, and they can talk to each other. So you can always have a hybrid way of, we call it as a multi-RAT technology, multiple radio access technologies you can always use. And you can embrace each other and coexist as well. Yeah. And security will work very, very well. As long as end-to-end is an IP, you will have a security is also managed.
You're not really talking about 5G as a period.
No, you see, you can have a 5G end-to-end. You can have NB-IoT or IoT in the final access to the sensors. Let's say you have a furnace. In the furnace, you have some 100 sensors, temperature, pressure, and your all the chemical measurements, everything you are doing. That you can cluster it, you can sensitize all the data. Like somebody was saying, I think, say petabytes of data, out of which not even 10%, is actually 1% is useful. All this data crunching and everything you can do on the edge and bring it on the 5G and start working on it. So there are various architectures based on which you can creatively use this technology.
Can I make just one comment? Also, just sharing it for the industry, 5G ACI has a publicly available document where how does all different industrial protocols get supported over 5G. I can share that document also. It has examples, designs, and also examples of companies in Europe, Fraunhofer, HMS, and others who have developed these industrial protocol converters, gateways, and all. So that document, I think, is very helpful because obviously you will not rip and replace. So this document is publicly available by 5G ACI.
Thank you so much. It was really wonderful discussion. I think it's great to have all these experts share their view and also really nice set of questions. I think with this, we'll close the panel discussion, but hopefully you can interact with the panelists after this and maybe during dinner and probe further. So thank you.
Thank you everyone for the panel discussion. Now, I kindly request Shri Vijay Mittal sir, Joint Secretary MHI, to present mementos to our esteemed panelists. Professor Bharadwaj Amritur. Shri Radhakant Das. Srimati Monika Gupta. Shri Satish K. Shri Uday Halangadi Prabhu. Requesting all the panel members on the dais to join for the photograph. Thank you, everyone.
I would like to make, hello? Hello? Yeah, I would like to make a quick announcement that after the end of panel discussion 4, we have dinner arranged at Hotel Sheraton Grand. I request everyone to please try to make it for the dinner. And for this, we have arranged 2 Volvo buses. Hotel Sheraton Grand is approximately 3 kilometers away from here. So those delegates who want avail the transport facility, they can avail the Volvo buses at 8 o'clock after the end of the 4th panel discussion. Thank you.
Check, check, check. Check, check. Check, 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 check. Check, 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 check. Check, check. Check, check, check. Ladies and gentlemen, is the mic testing?
Ladies and gentlemen, our next panel discussion will be on the topic robotics in defense, challenges and opportunities in the strategic sector. It's my truly an honor to welcome the esteemed panelist to the dais, Dr. Srinivasan Dwarakanath, Strategic Advisor in Aviation in Aerospace, Adjunct Faculty at IASC, Dr. Vipinik Roy, Scientist, Division of Remote Handling and Robotics, Baba Atomic Research Center, Air Commodore N.K. Praveen V.M., AOC AFS Kanpur, Dr. G.A. Ramadas, Director of National Institute of Ocean Technology, Mr. A.N. Chandramouli, Chief Executive Officer, ANCM, Management Consultant. We welcome you on the dais, sir. And the moderator for this panel discussion is Dr. Srinivasan Dwarakanath, who has more than 2 decades of experience working for the Airbus in Europe, American, Middle East, and Asia Pacific. He is currently an independent strategic consultant, actively mentoring startups and in the advisory board of companies in the aerospace and aviation, driving strategic development. Now, I request the moderator, Dr. Srinivasan Dwarakanath, to kindly take over the panel discussion. Over to moderator.
Just mic check, mic check. Thank you, Janani, for your kind introduction. Yeah, excuse me. Okay. Thank you, Janani, for your kind introduction. I'll start again. Good evening, Joint Secretary, Director of the Ministry of Heavy Industries, distinguished colleagues from academia and industries, ladies and gentlemen. I think we are entering the last session. I know we are between you and dinner, so we'll keep it sharp and then on time, for you guys to be there. The topic is very interesting. This is, robotics in defense. I know they have kept the important one for the last. Okay, so we heard a lot about robotics today, several aspects, human-robot collaboration, robotics in manufacturing, and all that. If you look at defense, currently, the many types of robots are being used. I'll focus on the ones predominantly used in defense. The ground robots or unmanned ground vehicles. Aerial robots or unmanned aerial vehicles, or the underwater robots as well. So if you look at ground robots, I think, but a couple of years ago, Indian Army, procured, Pinnace from Estonia. That's one of the highly automated ground vehicle. And these are robots, that can be used on a variety of tasks in terms of reconnaissance, surveillance and bomb disposal, etc. on aerial robots, unmanned aerial vehicles, we've been, I think, the last 2 to 3 years, seen a surge of startups working in the drone environment. And, if you look at Prime Minister Modi's visit to US, he signed a deal with General Atomics on the MQ-9B. That is the high altitude, long endurance drone as well. So this is extremely important, for the defense side as well. And you can see that drones being used widely in the warfare as well. Case in point, Ukraine-Russia war, how they've been effectively being used as well. And they can operate in hazardous and inaccessible areas as well, providing real-time data for military, aiding in situational awareness. Underwater robots, we don't hear much about underwater robots, and we are hoping we'll hear a little bit more during the panel discussions, like the other aerial as well as the land cousins. These are extremely useful in terms of the underwater warfare as well, and we'll talk about this a little bit more. In terms of the opportunities and benefits, clearly we heard a lot about robots and the benefits in terms of reduced casualties in the defense. They can really help where humans can't go and fight. And moreover, these robots are becoming the first line of defense more and more as well. They can reduce the casualties as well. Increased efficiency, I don't want to dwell on that, and improved situational awareness as well, because we can send robots front in terms of the defense as well, and we get a lot of data so that we can use the soldiers to do much more on strategic decision making as well. Okay, but these robots are not without challenges. We heard from the last panels the cost. The robots are becoming more complex, and the costs are increasing, which means that that's going to be one of the critical things what we need to look at in terms of reducing the cost. The vulnerability to cyber attacks, this is going to be one of the key things, because these are becoming much more of embedded systems. There is hardware in robots, but there's going to be a lot of software in there as well. So that's something we need to take care. Otherwise, these robots can be used against us. And last but not least is that ethical concerns as well. There is always a question about, do we use robots to kill human beings? If the robots have started taking autonomous decisions, what will happen, and is that ethical? These are some of the questions we would touch upon as well. But coming back to the future of robots in defense, it's extremely promising. As technology continues to advance, robots will become even more capable, and sophisticated. We will see, autonomous robots with artificial intelligence and machine learning. This could also lead to development on areas such as swarms of robots, that can work together autonomously to accomplish complex tasks as well. All right. So with this, let me introduce you to the distinguished panelists we have here. We have a great panel. I'll start with Dr. Ramdas here. He is the director of NIOT, the National Institute of Ocean Technology from Chennai. And I'll probably, for want of time, I'll do a short introduction with the people as well. And we have Dr. Debonik Roy. He's a senior scientist at the Division of Remote Handling and Robotics in BARC, Baba Atomic Research Center. And we have on my left Air Commodore Praveen. He works in Air Force, and he's a proud recipient of the President Award, Vayu Sena Medal as well. And at the end there we have Mr. Chandramouli, who's from manufacturing, and we work together quite a lot as well. With that panelist we have here, one who's a user of these technology, and we have a couple of the people on my right who do a lot of research as well as who develop these robots as well, and we have somebody from manufacturing as well. That's a great set of panel speakers we have to deliberate this topic. So let me kickstart with you, Air Commodore. From an user perspective, could you talk about the current state of robotics technology in defense or defense manufacturing, and the role in defense operations as well? It's all.
Check. Thank you, Chai, Joint Secretary, CMTI, and IISc for not networking us through 5G, networking us manually. Thank you. Disclaimer before I start any presentation, views are mine personal, not of the organization. First, this is one of the standard disclaimers we do in the Indian Air Force. Robotics in the Indian Air Force primarily, robotics primarily is limited for it is suboptimal. It is suboptimal. It would have been fine amongst this allied panel, 4 experts, 1 user. It would be nice if HAL and other government manufacturing industries would have come on board. So that is where we can drive, because commonality, repetitive task is in HAL and in the defense industry. It is suboptimal primarily because of reasons. Variance in tasks. None of our tasks in the military is common. It is not repetitive. For example, bomb disposal. Bomb disposal, there are only 5 methods. I got the Vayu Sena medal primarily for disposing a 1,000-pound bomb. It was done manually, and it's a dirty job, but someone has to do it. So I did it. Someone has to do these dirty jobs. But this is where robotics can expand. So where the dirty job can be done by robotics. So we have this technology, robotics. At the current state, we have something called as a robotics machine. It is primarily used for recreation. It is a Swiss machine. Approximate cost is around 7 to 8 lakhs. So suppose one of the speakers said our cheapest robotic machine is around 18 lakhs. If you do the ballpark, a simple manipulation, we pay around our general structure for skilled worker is around 15,000 rupees. Annually 1.5 lakhs to 2 lakhs. So return of investment for a 4 crore machine will be approximately more than 10 years. So this is one of the points we have to keep in mind. For military, there is no scalability. First, there is no scalability. So if the industry goes specifically for military, you will get it in spurts. Russian-Ukraine conflict, you will get a spurt in production. So what the industry has to do is, it has to make it doors. You have to run a normal production robotic line for a particular and tailor it to defense use as and when the requirement. Then will the industry survive? And availability of low-cost manpower is one of the issues. Out of the 30 lakh robots that are in existence as on date, more than 30% is in the manufacturing sector, other than defense. So I have excluded drones primarily because drones have picked up in the last few years. Government defense manufacturing companies, HAL, BL, Munitions India Limited, Armored Vehicles Nigam Limited, Avani, Advanced Weapons, they're doing robotics, far and few, very limited. This is where the government can crank them up. They're doing repetitive tasks. Similarly, private, here is where you can push them across. They're making uniforms, they're making ammunition. It is the same ammunition done in bulk and series production. So it is repetitive. Here a government can give an incentive and probably crank it up. This is one of the areas where we can crank up. Specifically to drones, MQ-19B, which Dr. just mentioned, Professor just mentioned, we just made a deal of 31 exorbitant costly drones. These are high endurance drones. It was sometime in 2016, if I remember right, AD started the Rustam 1 project. It was supposed to be a long endurance UAV. As of now, it was recently used, Kapas, which is a tactical aerial platform for aerial surveillance. It is a Rustam but is at a very nascent stages. It is just done its flight trials. So our cycle time is too long and too far. Therefore, the defense industry per se, because there are no innovators per se in our country, we are adapting what is available from the foreign sector. So this turnaround time has to be made quicker. I don't know how we can do it. The in the defense sector are also used for kinetic action. It is primarily used for something called MUNT, man and unmanned teaming.
that is of fighter pilots in a manned aircraft, go along with a unmanned drone for kinetic action. Probably unmanned drone lights up the target through a laser designator and the pilot can fire. So this human robot interface or cobots, which is primarily called, is a very good option. It is moving in this area. Another area which we are in force per se and the Indian Army also is unmanned ground vehicles. Daksh, very common, used for unexploded ordnance. This is another area which we have moved forward. This is primarily what Indian Air Force does. It is similar in the Indian Army also and in the Indian Navy also. It is very limited. Nascent stage robotics can be cranked up to exponentially.
Thank you, our Commander. And I like your point on this commonality and the dual use. How do you use it when it is necessary for the warfare, and how you can use it on civilian applications as well? That's a very good point. Maybe I'll turn towards you, Dr. Ramdas. From underwater robots, we don't hear a lot. Probably, we think submarines and then something more. Can you enlighten us a little bit more on what sort of underwater robots you guys are working on, and also what sort of things we can expect as well?
Thank you, Mr. Chairman. Good evening, and I thank the organizers for this opportunity. Before going into what sort of vehicles or what sort of robotics we use underwater, I want to tell actually how different they are actually. If I have a decent telescope, I can see Saturn rings sitting on my terrace. If I'm allowed, I can control Mars rover sitting in my laboratory. But if I drop something at 25 meters water depth, I cannot see. And if I put an equipment at 25 meters water depth, I cannot control it. Simply because electromagnetic waves don't travel long distance in water. Where GPS doesn't work, radar doesn't work, you cannot have communication. It is dark, 40 meters. So you have to carry lights if you want to see anything. Even if you see only 5 meters from the camera. It's very small field of vision. So you have to sound for seeing or for communicating. Sound is 2 lakh times slower than the light. And the information carrying capacity is limited, and it doesn't travel always in straight lines. Depending on the temperature and density variations, it actually refracts and it goes away from the target. So it's almost, there is no communication. So it's very difficult to conquer the inner space than the outer space. So that way underwater robotics are quite unique actually. And every 10 meters there is 1 bar of pressure increases. Okay, so at 5 kilometers we operate unmanned vehicles at MOT for other purposes. The pressure is 5 bar. If you actually, it's like a headhunter. If you send 1 liter thermocol can, actually it comes like a thimble actually. So it's actually, and we have seen this recently titanium imploding really. We always tell our students that and our young scientists that it takes 20 milliseconds for it to implode. Now we understand how the pressure can be. And again, the density variations, temperature variations, and corrosion, it actually, they call for different kinds of materials. And the actually, if you want to use, you cannot send the electromagnetic waves, so you use cable. Then the drag on the vehicle as well as the cable, so you cannot even move it. So what is a dense medium? It's a more viscous medium. So it's actually very difficult to move a vehicle. And if you want to send autonomous vehicle, then you don't know what it is doing. When it comes back, if it comes back, then you can retrieve the data and you can just see that it is rudimentary communication with acoustics. And we lost vehicles at 5,000 meters. We have lost robots at 5,000 meters depth. So it's not very uncommon to lose. Even this recent Titan search also one ROV was lost. So it is actually, we have to strike a compromise. Then power supply. You cannot have solar panels underwater, and you can have underwater batteries, seawater batteries, but they generate very small power. So you have to use batteries. These batteries, they become efficient at some efficiency, at least 10% efficiency, 20% efficiency at very high depths and low temperatures. So these are all challenges. Okay, so biofouling happens if the vehicle is there at long this thing. So they make actually underwater robotics. They are actually total different actually ball game altogether. What sort of vehicles we use? Or what sort of robots we use? We send tethered robots. They are called remotely operated vehicles. They can be light for only just observational purposes. They can be work class with some kind of robotic arms and other sampling devices and all. They carry their own lights, cameras, sonars, and sampling devices, etc. And there is a long cable which can take the weight, which can supply the power, which converts the electrical signal to optical signals and sensor controls, and again brings them back actually. And this actually we can, from sitting in the ship, actually we can control. Second one is autonomous underwater vehicle, where you can program the vehicle and you can leave it in water. It does the work and comes back, and then you can retrieve the data and you can see what's happening. Third vehicle is actually we do some kind of mining operations. At 5,000 meters, the soil is very soft. So when you, it's very difficult to locomote on the soils actually. So this kind of mining machines with special tracks are there, and underwater drones are there, which are equivalent to terrestrial drones. And gliders are there, which collect the data and oceanographic data. So there is actually a gamut of underwater vehicles that we use, and we need to develop more and more of such things actually, because 70% of the ocean, Earth is covered with the ocean. That means 70% of the Earth resources are still unexplored. If 30% can sustain you for some thousands of years, 70% can really sustain you for any length of the time, but we have to learn to use it judiciously. For that, you need underwater robotics. Thank you.
Thank you, Ramadas, for enlightening us on that. Coming back to you, Mr. Chandramouli, from the manufacturing point of view, in terms of manufacturing robots, where do we stand on them?
Thank you and good evening. The question of manufacturing a robot should be considered along with robots for manufacturing. I think I put it a fantastic thing, which perhaps talks about both aspects. But I would like to restrict not to the manufacturing of the robots, but I'll touch upon later on, but how robots are coming into manufacturing, because in the case of defense industry. Let's look at what is the defense industry in India. The major missions of our Prime Minister in terms of power in India. Much has been said about it. But when the country and the ministry delisted 101 armaments and weaponry, when the whole industry woke up, my God, these kind of science products, what I call in your jargon, mission critical products, they cannot be considering affordability in manufacturing, which private sector will look for civilian products. In the case of military products, what is more important is not the budget affordability, but the mission critical nature of these products. And therefore comes a very, very important theme, namely the consistent quality. And there is another terminology, precision in quality. These are two different things. When I was heading a Swiss-German multinational, 160-year-old company, which still manufactures, the only company manufacturing 1 micron precision in the form of a jig boarding machine. When our largest aeronautical company in this country went for it to produce helicopter gearboxes with this kind of automated equipment, needless to mention, we have arrived as a country. And therefore, I can proudly say the Indian defense manufacturing has woken up to the levels of automation that we need to achieve consistent quality. The second case study I would like to proudly mention is a flexible manufacturing automation implemented in manufacturing of T92 and T94 tanks. Maybe it's on record, it's okay. And this project was commissioned in a record of 3 years in our Chennai. And this manufactured 40 different types of engines. Since morning, ladies and gentlemen, we have been talking about flexibility in manufacturing. Even in defense manufacturing, sir, I would like to submit that there is a huge requirement of flexibility for the primary products such as engines in the armored vehicles, but also for the spare parts. What do you do when you are dependent on other nations for the spare parts of these vehicles? You know what happened after the recent war in the Eastern Europe. To minimize the dependency, we need robotic automation to manufacture these spare parts at the distant in a remote location. Suppose an armored vehicle is broke down, together with additive manufacturing, 3D printing, and a robot placed in the nook and corner of this country, in the borders, they can come bring this manufacturing at the remote side also. So both on manufacturing in the factories of the ordnance factories, etc., which have been recently corporatized, and after-sales service of this equipment in the field, be it an aircraft or be it armored vehicles, or even for that matter a naval ship, which we require automation and especially robotics. Why robotics? The dull, dirty, dangerous, difficult, and social distancing have been discussed ad nauseum. But now comes the most important mission-critical requirement of quality. I would like to close by saying one statement. When you implement it, we should not look at only robo or equipment or other devices, including 5G network, etc. We have to take a holistic approach of looking at multidisciplinary robotic program. What I mean to say, small example, we have friends here who do what is called robot tending CNC machine automation. Even in our skill development programs, we are talking about a student should be trained on implementing a project on robot automation. So if we do look at this kind of an approach, a multidisciplinary approach with multitasking machinery, with a multi-skilling human being, I think we would have arrived as a true nation building a robotic manufacturing. Manufacturing of robots, I will reserve to another day. Thank you.
Thank you, Mr. Chandramouli. I really coming back to you, Dr. Roy, you've been working in BARC, you've been working on robotics for a long time. Looking at, the research you guys do at BARC as well on defense robots as well, could you enlighten us what sort of things you work on?
Sure. Thank you, Dr. Dhalakanath, for your question, and also chronologically things. See, I am there for 24 years in DAE, and for the last maybe 10 to 15 years, we have several interesting defense projects, like collaborative projects with DRDO to be specific. I would like to mention a couple of those things where I took part. The first one was very interesting. It was for Ordnance Factory Jabalpur. Okay, it was basically a explosive detection system through a robotic arrangement. It was a mobile robotic system that was, because those engineers came to us and say, sir, we want to have a automated system, kind of a mechatronic system. They didn't, in fact, mention about the robotics. If I remember correctly, it was something around 2008, 9, something around that time. And I was pretty young engineer and scientist joined. So what we did a very specific mobile vehicle system for them, and which is having a very big kind of a tongue type of a gripper. I mean, those explosives are there in the boxes, and you do not know what is there and how delicate those boxes are. So those are actually black boxes for us. So we have to, that robot has to take those boxes, put it in a safe place, and then probably the bomb detection arrangement will be done. That will be done by the Ordnance Factory. So our technology was how to design that mobile robot, how best we can run it on a planar surface. Fortunately, there was no problem of any inclined surface or anything in that Ordnance Factory problem. And I am quite proud that we did it very successfully and it was accepted by the Ordnance Factory, then officers and technologists. The second one was a kind of a very interesting mechatronic solution for another small unit of, again, a Ordnance Factory defense activity in very near to Mumbai, a place called Kalyan. So there is a factory which they need some kind of a automated solution from bark. So we understood the problem and then we took our indigenous solution. Why I am mentioning this thing, all our solutions to the so-called users, like in this case, defense, ordnance factories, etc., these are all indigenous, including all our R&D is indigenous. The one reason is, as you know, that BARC and DAE is still under embargo, US sanction. We cannot buy any single product, whether it is a hardware or a software, from US and UK. So it is still there. So think of the difficulty that we are facing, think of the problems that we are facing. And we cannot even publish something which is related to some softwares that is US products. So these are the paradigms, but I always consider these are bone in disguise, so that we learn something to how to do it. So these two problems were actually kind of a benchmark problem. Later on, another interesting problem came something around, I think, if I remember correctly, 2012-13, that is from RD Pune, the research and development establishment in Pune. So they came to us for another collaborative things for a very nice mobile robot development program. And that time it was essentially for an inclined surface. In fact, finally DRDO developed the Daksh for the staircase, climbing system. But the initial thing for us, they actually wanted something on an inclined surface, whether the technology can be developed by BARC, like our robotics system divisions. So we took up a challenge and formed a team. I was also very much part of that activity. And everything there also indigenous, starting from the wheel designs, the braking system, the motor, whatever we could do at that time. In fact, it was quite a heavy structure because that sophisticated systems were not there and we couldn't buy also. See, that is the point I am mentioning time and again. This is the difference between our activity vis-a-vis any academic R&D activity, because you can buy whatever the motors you want, probably that is not a problem if the fund is there. But for us, although fund is not a problem, but these embargo issues are there. So these are the quite three successful case studies. There are other small activities also. There was some collaboration with INS in the Lonavala with the Navy, Indian Navy. There was some. Of course, I was not fully involved in that. But there are small activities also. But these three projects are really path-breaking for both DAE and I think DRDO. So these are the background. Now, secondly, the futuristic research or other activities that can be planned. See, my solution is there should be 3 S, 2 A, and 1 IA. Let me just explain. These are quite, I am quite fond of telling this. What are the 3 S's? One is surveillance. We must develop R&D in-house technology for all surveillance kind of systems, definitely for defense activities and for our own things also. As you know, in the nuclear power plant system, we need surveillance. And especially some critical surveillances, I want to mention especially the internal surveillances, like inside the pipe or inside some conduit, some channel, how to do it. These technologies are not easily available in India. Even people in overseas countries, they are doing good research. So that is the surveillance. Of course, surveillance, it is, I am telling about on ground right now. Of course, there is aerial surveillance, as you know, that people have already, other panelists have told about drones, and Dr. Ramdas already told about the underwater. So I am just considering on ground things. Then the security. All these robotic technologies, especially for defense, must have a component of security. That means they should perform some of the operations that we need to have more secured, activities by the defense staffs or the defense technologies as such. And third S is self-reliance. So this is very, very important. We cannot afford to have some technology bought from outside and then it remains as a black box and finally we cannot do it. This is a totally no-no for me personally, and I think as an Indian citizen, we should avoid buying the things, except some specific fundamental things like some basic servo motors or something. We have to probably still depend, but we are having a lot of collaborations going on with our technology collaborators in some of the cities of Maharashtra, especially Pune in particular. We are doing those things also. The two A's are affordability and applicability. See, unless and until these defense robots or whatever robots we are doing, they are affordable to the Indian community, these are all no use to me. I consider these are totally useless unless and until it is affordable. If we cannot produce a solution which is affordable, it is not of no use. And definitely it must be applicable. This is a high time that we all researchers or academicians come out of our lab and go to the field and see what India needs. Though that is very important, these two are the applicability and affordability. And another very interesting thing, with full regards to my computer science peers, inverse of AI is required. We are listening AI too much, but how the implementable AI is there? How many of us has really tried that AI in a robotic system, robotic hardware? They are doing the computer science algorithms, etc., fine, publishing papers. How many of us have done anything in India where AI is getting implemented in a robotic hardware and they are really becoming an intelligent substance? So this implementation of AI, this question I have asked many computer scientists, I think the answer is not very forthcoming. Now, what are the parameters? How do you benchmark? See, you have written a program on AI, deep learning, DRL, everything. How you are benchmarking it? How you are validating it? What is the proof that it will work for a robot? See, I am a mechanical engineer. See, I have developed a robot, or with an instrumentation engineer, I have developed the controller also. Now I want to apply AI. Now, how do I prove that your AI is working with my robot? So this is a big question. So I think we should all think of that, and probably Government of India, MHI, and other ministries, they should do. In fact, MeitY has already done a very good project of driverless vehicle with IIIT Delhi. I am a part of that committee. So I consider that is a very good project. At least they have done something, and I have really seen that things working in their campus. So hopefully they will take it in some Delhi streets also. So these are the points that is important. Then there are some path breaking. See, as a researcher, one should think out of the box. How about a concept of reproductive robot, which is very much important for rescue, surveillance. Surveillance already I have told. Another important point is rescue for defense. Or even it is good for agriculture. Can a robot be reproducing? Which sounds a little funny, but some designs, some thought process are going in my lab. Hopefully we'll be able to produce in another 1 year or 2 years, some kind of a prototype for that. Then definitely wearable robots, X-limbs. See, exoskeleton, etc. is already available. Those things are required for defense activity. No doubt there are so many CSIR labs also are doing. CSIR in Chandigarh lab, they are already started doing very good thing. But X-limbs, extended limbs, those are also very important for defense activity as a research activity. Rescue robots, of course, firefighting robots, in general, assistive robots. These are the programs what probably Government of India can take up. And biorobots, especially the rolling type and crawling type. These are very important for defense activities. As you know that different terrains are there. Can we deploy those kind of a small miniature kind of a semi-miniature kind of a rolling type robot in a high avalanche area? Crawling type robots, some technologies are there with us. At BARC, we have developed with my fellow researchers and young colleagues. So those things are available. If someone is interested, I can give the details. So these are the research perspective. Thank you. I think.
Thank you very much. I'm really, appreciate the passion with which you have, talked on the subject, because you have a lot of experience. And then, as you said, constraint, throws up challenges, which throws up opportunities as well. So that's great, from what I've seen. And coming back to opportunities in Air Commodore, from an IAF point of view, for the industry, what could be the big opportunity in terms of defense robots, you might have? And, how do they contact, if there is an opportunity,
I'll answer this in two parts. First, Industry 4.0 lists autonomous robots as one of the 9 pillars. 3D manufacturing. 3D manufacturing, IF being at the forefront of technology absorption, we have absorbed it to an extent, and we have put metal 3D additive manufacturing facility at our Nasik plant. For the industrialists and the entrepreneurs over here, it is a matter of opportunity. As I keep quoting it famously, Steve Jobs says that the consumer doesn't know what he wants. So let us give him something more, which he can't imagine. We are at a benchmark level that we don't know what we want. I will quote you an instance. The army decided that they want 600 armor shield. They just went, Googled it, found it. All the researchers all over the world couldn't get anything more than 550 That was the best which was available. So you ask for something which is not available. Yes, it'll come up sometime later. As of now, it was not available. For the industry and the entrepreneurs, the game is open. Let us start with simple. A simple Pathankot attack cost the Indian Air Force approximately around 10,000 crores. So what you did was, you started building physical obstructions. You raised your walls to 10 feet, put concertina coils all over your high-value assets. So you think about it as an industry. How do you provide surveillance? We have a very large land border, 15,200 kilometers, 5 countries. So how do you provide surveillance? As of now, the guards, trained professionals are doing the guard duty in the Indian Air Force. So I can weave them off to do their core jobs. You give us security. You have a solution, say, Post Station Kanpur has around 1500 acres. How do I protect this vital asset? What can I do? Through drones, through perimeter camera security, through robots? What is the first tier of security I can provide? So starting with that basic, then you can crank it up to the extreme. IF was sensitive to the task. We organized something called as a drone competition, swarm drone competition in the year 2021 in Kurnool Range, while I was a CNGO at Jaisalmer. The winners were Flare Unmanned Systems Delhi for the best communication architecture, and Daksha Unmanned Systems Private Limited for the best drone architecture. So the technology is available, and they were at par at that time amongst the best with the industry. We had benchmarked it and given the parameters. So they won the competition indigenously. Indians are famous for something called Jugaad, frugal innovation. This is where we have to come in. We have to pitch in. It is frugal innovation to the best. Typical case, best case scenario is our Mars mission. Frugal innovation to the limit. High-end conflict zone, I said MUMT, manned, unmanned teaming, scope is endless. Unfortunately, our testing and ratification cycles, we have something called RCMA and DGQA. So the testing and everything is up to standard. A split pin which costs 10 rupees in the automotive industry costs around 400 to 2,000 rupees in the aviation industry, primarily because it meets a standard. That particular split spin holds a complete nose wheel of an aircraft. If the nose wheel of the aircraft is not there, you lose an asset worth 700 crores. So that is the implications of quality. So that this is where robots come in. You can ensure a human can make error. On a lighter note, I thought Sophie the robot will welcome us during the robotic conference. It didn't happen. And mistakes which we made. We tried to make this mistake. So it's on a lighter note, hybrid mode of engagement. The first line of defense is a soldier. So the soldier can go and follow. As of now, we have donkeys carrying our equipment and the weapons in high altitude areas. Robots can do this task. Exoskeleton was something else which we talked about. Normally, an air-to-air missile weighs under 100 kg. So imagine us trying to put it on. One man, we are not heavily built like the Russians. The Russians, unfortunately, our inventory is more of Russian aircraft. So the Russian missiles which we try to load for our Indian frame, it is very difficult. You tend to do errors. You have an exoskeleton, you can load it easier. One area which we neglected is in our BRDs and in manufacturing setup. These robots can do wonderfully in QS jobs, defect detection, DIs. They can classify faults very easily. They will never make an error. 100% fail-proof, dents, scratches, nicks, because any small error, any dent or a nick in any of the blades can be catastrophic in an aircraft or an aero engine. Search and rescue, well known. Robots I already covered. Like sir was asking, how do you contact any institution? For IF, you can contact Headquarters Maintenance Command, or we have opened up a new organization, something called as a Department of Aerospace Design, DAD. You can Google it. It is available in the website. IF indigenization cell is proactive. Similarly, is a Naval Design Bureau and the Army Aviation Bureau. If you have any idea, like there is something called as a Technology Development Fund. We fund you if your idea is acceptable to us. The industry, the DRD, government funds you more than 90% of the cost, so that you can, if your idea is ratified through a committee. So we are welcome to ideas. We are open to ideas. The contact points I've already mentioned. I hope I've heard.
Thank you.
There's one more issue I forgot. Loss. There was someone who asked ethical, non-ethical. War is unethical. My existence is unethical because we are. It is meant on a mission. I am here to defend my country. Period. It is ethical, unethical. It doesn't matter. I will kill. I have been trained to kill. So that is how we work. So lethal autonomous weapon systems is another one, another area where we can explore. Thank you.
I think the debate on ethics and not ethics are for people who sit in the boardroom without uniforms, Kumar. So coming back, now before I get the white shit from the organizers, I'd like to get a few quick questions done. If you could do a quick answer, Mr. Chandramouli. There are three parts of this question. What are the three prime drivers in defense manufacturing, for automation? And how do you see the opportunities for modernization of our existing defense factories, for example? And then if you can also touch upon the skill sets required there as well, that could be good. 2 minutes, please.
I have to become a robot to complete the answer in 2 minutes. Thank you, Dr. Vartut. I think, as I already mentioned, the number one driver is consistent quality with precision. The precision being the accuracy and the consistent quality being the zero defect in the mission critical components, be it land systems or air systems and naval systems or the weaponry thereof. How do we achieve this? One has to look at the 4M concept. The non-machine material and methods is more than a cliche. We are able to develop fantastic technology through robots and AI and 5G and whatnot, and the man is not correspondingly developed, you are finished. Or conversely, you do a lot of skill development on the people. The whole country, we're talking about skill development over the last 12 years, right? But the equipment is still not in place. And we are talking about an Atmanirbhar manufacturing of robots. Now I come to that point of manufacturing of robots rather than for robots. We have a concept called local content indigenization program, which came up and it was more emphasized during the 101 listing of the weaponry equipment. It was already there in some format, it again came back. And there is a 20% indigenization and there is a 50% indigenization, 2 levels. My friend Arun will vouch for me on these percentages. I think to make these artificial percentages is not going to bring in localization speed up. I humbly request through MHI, which will also go to MOD finally. Once I told this to Mr. J.R.K. Rao, MOD, at that time, I don't know who it is now, that we need to look at a progressive incentive concept. Even if 10% localization is done, we have a friend there in Hyderabad. He is raring to go with the cobotic production, but we're still importing from Denmark. So let us look at a progressive incentive for a progressive localization rather than artificial cutoffs like 20%, 50%. Until cows come home, we talk about the tendering process, etc. Right? Little emotional on this, but I'll come back to the point. The Chinese robotization, why it is went up galloping. They have a L1, T1 concept. Being a multinational corporation, I know this from my friends in Switzerland, how they're winning so many orders in China, but not in India. Then I realized that the L1, T1 concept is giving very high importance to the technology aspect and not just the tendering L1 aspect. We have tried to do some reforms, but it is still not enough. And we talk offline on this point. And the third point is the modernization of the equipments. I have visited several ordnance factories across this country. Except naval, I visited all other places. HAL, almost alternate days we have been going there and participate in many tenders. And there are few public sector defense PSUs are looking at technology as a priority and not as a cost of it, right? If they can afford, that's why I said affordability is not the criteria, but the zero defect production is the criteria. Maybe I'm differing a little bit on the panelist here, but this is very important in the case of defense sector. Now, when they did it, the closed loop quality control, now I come to the mechanics of this. The closed loop quality control cellular manufacturing concept with a robo sitting in the middle and many equipments all around are producing a gun shell device, I don't know the exact name of it, in Calcutta. The Calcutta factory was started by the British in 1800. Even now you go there, in Kashipur it is written 1800. I asked the customer, what is 18? That is when the factory started. Can we modernize all our companies? There are 35 OFB companies now corporatized as 7 companies. And there is a 90% modernization project still pending. And once they asked, there is a 10,000 crore in the bank, can we put them in modernization? I think all the consultants should participate in doing a white paper on it and aggressively modernize all our plants. I visited a plant in Kanpur. There are 300 CNC machines all sitting idle. Right? I'm not criticizing the government. I'm saying just bring those CNC machine. We have great friends here who will bring machine tending automation and put a robot with a cellular manufacturing. Completing the point, the closed loop quality control is done by the robo. How does it do it? There is a metrology 4.0 built in that. Right? CMTI is a great in talking about metrology 4.0. If some of you have time, please visit the Smart Manufacturing Samarth Udyog Lab. What does it do there? There is every equipment is driven by a robo. The robo carries a vision-based technology to measure the product. There is a what is called a portable robo, which goes and measures the component. A huge component in the shipbuilding, I think they cannot bring it to the CMM room. These robos take these portable measuring instruments in the probes, and they go and measure at the basement of the ship or whatever. So there are so many things happening in the metrology 4.0. That's the third subject. So to come to the 3 drivers, to summarize, it's the most important. Quality, quality, quality. I don't want to say all the 3 drivers there. The second driver is flexibility. Defense industry require highly flexible manufacturing system. Let's just discard all our requirements of the traditional manufacturing approach when we are producing one single component all through the year. I visited the Kanpur and Lucknow factories of the gun, small arm, big arm, whatever. Everywhere varieties come in a big manner, and we are still importing. Atmanirbhar will happen when we bring in flexibility. The setup change requirement from one component to another should be minimized. Not the productivity of the machine, sir. It is the time lost in setup changes, right? I think moderator is looking at me. I'll just make one last point. Very, very important point. I already talked about the man because he asked me 3 questions and he gave me time for 1 question. Sorry, right? I have to be a robo now, yeah? 2 minutes. Yeah, now that 2 minutes is almost over. The last point. Coming to the manpower skill development, sir. We are doing some work across this country on a national body mission, NSDC and other things. Very, very important is please develop multidisciplinary, multitasking, multi-skill students. Which means if somebody knows robo, he should also know vision-based technology. He should also know about the CNC machine control and look at a holistic picture on the skill development. How do we do this? Unless we have all these training providers are talking to each other and we enforce through our famous capital goods enhancement projects, compulsory, please make the laboratory multidisciplinary. IIT Delhi, CMTI, Indian Institute of Science, famous examples and role models. Now, how do we take them to the defense industry? All defense industries should visit these famous Samarth Udyog centers, 5 in phase 1 and another 10 in phase 2. We must make them visit all of them through RPL program, sir. Last point. reinforcement of the prior learning certification should be made mandatory by MOD, and thousands and thousands of people. We have done an aerospace skill council for the aerospace industry, Air Force industry, but we should do it mandatory. They go through all the Samarth Udyog centers. They're waiting for people to visit. I know it for a fact. Dr. Amaresh is here. I think he will vouch for this. And therefore, skill development for the defense industry, where there are 36,000 people now, it's constantly shrinking. The manpower recruitment defense industry is constantly shrinking. I think our DRDO will confirm that. But now we have launched a MTech in defense manufacturing over 25 universities. Great approach. Let's do a BTech also. Let's do a diploma also. Let's do ITA also. Focusing on defense manufacturing. And then the Atmanirbhar will happen. Not only robotics, but also the people aligning with that. Thank you very much.
Thank you, Mr. Chandramouli. I think in terms of the 3 points, as you said, quality, flexibility in terms of manufacturing, and then multi-skilling. And earlier we were talking about multi-skilling, saying that today nothing happens without a digitalization, for example. So whether you're studying mechanical, electrical, everything, everybody should be made compulsory. They should study, as a minor computer science, for example. The appreciation of it may be slightly different from what Dr. Roy said. But coming back, now this is back to some of the questions, MHI was asking. So what are the, what I would like you to answer, probably, 2 sentences, please, is what future trends or advancements do you expect in your field of robotics? What do you see? You can pick one technology, but along with it, could you also look at timeline for India? When do we need to have it? That's one of this. Maybe we'll start with you, Dr. Ramdas.
Yeah, actually, as far as underwater robotics are concerned, I can think of some things like swarm robotics. Actually, you can see how the fish and birds actually, how they make the shapes and how they actually while flying or while swimming and all. So if we can have that kind of swarm robotics, actually, they can, it's not that everything is controlled by a central node or every particular individual is actually in touch with all other individuals and all. This in swarm robotics, they just see the nearest neighbor and the environment, and then they react. Actually, this can be really an effective thing especially in underwater asset inspection or surveillance, etc. And another thing is biomimetic. Actually, we can imitate to prolong the life of the underwater robots and actually the survey time and all. We can have biomimetics, so we can just imitate the fish and other things and all. And navigation is very important. So we need something like a non-GPS based navigation, this thing. And self-healing and self-maintaining robots are very important in underwater. And one thing which we badly lack is sensors. Even if we make our vehicle or robot very inexpensive, because we cannot compete with the international market because the sensors are very, very costly. And so we have to really make this thing on this thing. So one thing I say is that in institutes like us, where we are doing R&D, we always joke that our R is small letter and D is capital letter. Whereas in IISc, IITs and all, they have R is capital and D is small letter. So we have to collaborate with one another, and we have to work together. I'll just conclude with saying one thing. For example, we are now making one manned submersible called Mascha 6000 as a part of the deep ocean mission announced by the Honorable Prime Minister of India. So it can take 3 human beings to 6 kilometers water depth. Definitely, we don't have all the skills required. So we are taking help from ISRO, Navy, DRDO, IIT, CMTI, Durgapur, many other CSIR organizations, industries like L&T and all. So this is another thing, actually, that man-robot interaction is required. And I think till we really know more about the oceans, we have to use man there, actually. These are some of the future requirements or development I can foresee. Thank you.
Yeah, I just compliment Dr. Ramdas' words that in my opinion, the fundamental thing is indigenous development. Whatever the new research angle we are thinking, it can be rescue robot, it can be a bio-inspired robot, whatever we can think of, whether it is for defense or maybe extended defense activities, But fundamental thing that is many times missing in our country is indigenous effort or the knack of doing indigenous thing of my own by my own hand. So this trend has to be there, and there can be. Government of India, MHI, they can enforce some programs for doing that kind of a project where those things will be implied. And there can be regular monitoring. If we have a regular monitoring, definitely we can come across the way we have, taken over those problems of ours in Department of Atomic Energy. Definitely the whole country can do it. Only the good efforts are required. In fact, I just want to mention one thing. Around 8 months back, I was requested by the CII, Joint Director of Confederation of Indian Industry. Probably Government of India had some questionnaire to CII, and CII came back to me for a roadmap for robotics. And I have given them a very detailed work plan for a long-term plan and short-term plan and a medium-term plan. Questions are very specific. So the gist of that document is basically a project with indigenous effect, and that should be monitored by persons from industry, not from academics. Although I am a part academic, part industry person with a research effect, but even I am telling these new projects must be controlled by a person from industry, from a practitioner. Either he can be a defense person, he can be a manufacturing person, but that must be. The committee must not be chaired by an academician. The way it happened in all our, I am there in several Government of India committees, starting from DST, DAE, MAT, and I have seen the same fate. See, this is the thing. If India has to grow with Atmanirbhar Shilata, Atmanirbhar Bharat, if we want to take it in another 5 years, this is one of the key points that I must say very promptly and very openly. So this is one very, very important thing, that formulation of those monitoring committee and regular monitoring. Every project is good if it is monitored properly. Every good project can go bad if it is not monitored, not taken care of. So let us do the things, and definitely we will win over. Thank you very much.
Thank you. Thank you. Maybe I'll pass that on in terms of a technology. If you think we need to really have it for Air Force, for the robotic technology, what would that be, and what sort of time scale? I know it probably is yesterday, but I'd like you to give us a realistic one, please.
As doctor said, see, we made a fantastic roadmap. Additive manufacturing. It's a Government of India document, 2020. It's a beautiful document. You have to read it to believe it. Made by the Government of India and the roadmap completely. But unfortunately, as the doctor said, it went wrong. We didn't catch up even where we are now. It was not even in the first page. So we are at that stage. So I've given you the benchmark and the parameters. It is only how we crank it up. For that, it is, I'm no one to give an opinion, but we must give some incentive. Like what we did, I remember riding motorcycles. We used to have something called Alpine and Alpine jackets, high grade, military grade jackets. Courtesy our Honorable Prime Minister, we put a ban on it. Now we better jackets than Ox and Alpine jackets. So that is how we have to. Similar with electrical vehicles, we gave them an incentive, we cranked it up. Robots, even if I want to manufacture, I want to buy robots, I don't know what is the classification, whether it is a manipulation robot, whether it is a universal, single-use robot, what is the type of robot, fabrication robot, I don't know the classification. So we must have a site where they tell you, this is a robot which is available, buy it. I don't have something of that sort. So I, as a user per se, can't say where, though I have aircraft painting, I have aircraft welding, which is phenomenally intricate. Each of our airmen who does that welding task has to undergo a ratification every 6 months. So it is such a critical activity. If this can be done on a machine, there is no ratification, there is no, because the repeatability is assured. Whether I do it 1 time or 1,000 times, I will produce the same weld in the combustion chamber. I don't require. So that is where we need to crank up our effort. For subsidy is a must for the industry to grow. This is my personal opinion.
So, as I said earlier, I want to summarize as 3 points. Number 1 is metrology 4.0, quality inspection robo, which I seen in CMTI. Tomorrow, I think we should be able to see it. Is required across the 35 OFB and all the public sector PSUs, and automatically, I think private sector, Tata, Mahindra, Godrej, everybody is falling in line, or maybe they already advanced. Number 1. Number 2 is the equipments, majority of them are underutilized for a variety of reasons. Overall equipment effectiveness goes up from 65% average to 85% average. It has been proven in the global robotic industry because it is not man-dependent utilization of the machine. The uptime guarantee comes from the maintenance. I come to the third point, maintenance 4.0. Here, how do we bring in the robotics, augmented reality, IoT, and field maintenance? The remote maintenance is today happening in mining industry, earth mover industry, fleet utilization in the tractor industry, which are in the farms and fields. These gentlemen are struggling across the borders. Maintenance 4.0 is a mature topic today. It is taught in many colleges already, abroad as well as in India. So quality 4.0, equipment 4.0, OEE utilization, and thirdly, remote maintenance 4.0. Thank you, sir. These are the 3 trends which are happening, will be driving this industry, especially in defense industry. Thank you.
Thank you very much, and thank you very much, all of you as well. And if we have time, maybe I'll take a couple of questions from the audience, and then we'll close that up. Any questions from the audience? Sure. There, yeah.
Hello.
Yeah.
Good evening, everyone. I am Pradyumna. Am I audible?
You're audible.
From Quantum Point. And I'm directing my question to Dr. Ramdas. So you said that communication is a big problem when it comes to underwater robotics, and acoustics has its problem. I want to know, is there a way where you can, this comes under biomimetics as well, where we know that whales and dolphins have their own language of communication, and that is through sound. Is there a way where we can mimic this kind of communication for underwater robots? And could this be like a practical use for AI to, say, encode signals and send it through sound underwater?
Yeah, it's a good question actually, but we have already been doing it. So for example, we use chirp signals, okay, to actually take the maximum bandwidth from the available frequency. Okay, so already we have been imitating this kind of communications and all. But the main problem is you cannot improve the speed of sound, which is 1500 meters per second. And second thing is the bandwidth is limited. So you cannot improve that one. Maybe some coding can be done. Or you can make it near vertical so that mothership can be just above the submerged robot, so that actually there won't be much of inter-symbol interference and that kind of things and all. Research is going on already in those things, but basic limitations of latency and the narrow bandwidth, they remain. Okay. But no animal, no underwater means like our sea mammal or any, nobody can actually can overcome this latency and the small bandwidth problems.
Just out of curiosity, so what sort of range have you seen? What's the maximum range you've seen in this kind of technology?
See, acoustics, like they can travel sound waves in principle, they can travel tens, if not hundreds of kilometers in the ocean. There were actually experiments being done actually across the oceans. People heard the sound and all. So it is, means range is not a problem. But for example, if we are working at 6,000 meters, it takes 4 seconds for the signal to go down and another 4 seconds to come back. So if you miss one ping, 8 seconds delay is there. So that sort of problems are there in that. Yeah, thank you. Thank you.
Last question, please.
Hello, everyone. So a quick question from my side would be, so what are the future requirements for the aerial robots in generic, not speaking about drones? The reason is we have drones and we know what it is capable of right now. One is existing drone, something we could. And the second thing is, if
too high.
Some other people come instead of drones. So just want to give some highlight on the requirements. What are future requirements?
Future requirements of aerial robots. Maybe I'll not necessarily take the requirements where you can think in the meantime, maybe. Coming back, it's not going to be any more individual machines, robots working, whether it's drones or things. Future will be system of systems, right? So you're going to have, manned aircraft versus drones versus the satellite navigations, all of this. So the combination of that architecture is going to be more prevalent. It'll not be the capacity of individual machines or the capability of those things. That's what I would say in general, but specifically, if you want to add anything more to it.
Specifically, the limit is to up to only that swarm drones and drones. Aerial for the Indian Air Force per se, it is this. Subsequently to ASAT and other one, it is a different technology. So we are mixing issues. We end with drone. Drone is also a higher version of robots. So we'll bring it into this sphere. Drones and swarm drones are the basic IF requirement. These will do the purpose.
With that, I'd like to thank MHI, CMTI, ISC for giving the opportunity, and I'd like to thank the audience here for staying, quietly so far. I know it's time for a dinner now, and I'd like to thank all the esteemed panelists here as well, for at least showing their passion, which kept you all awake, for this in the late evenings. And thank you very much.
Thank you, panelists, for sharing such insightful information in this panel discussion. Thank you. Now, I would like to request Shri Vijay Mithil, Joint Secretary, MHI, to kindly present mementos to our esteemed panelists. Firstly, to the moderator, Dr. Srinivasan Dwarakanath. To Dr. Dibanik Roy. To Air Commodore Shri M.K. Praveen VM. To Dr. G.A. Ramadas. Last but not least, Shri A.N. Chandramouli. I request all the panelists to kindly join for a photograph. Thank you, sir. It's time to conclude the program. We cordially invite all of you to kindly join for the dinner at Sheraton Grand Hotel, and for transportation, 2 Volvo's buses are arranged. Delegates who need transport support can avail this facility to reach the Sheraton Grand Hotel. And thank you everyone for being such a kind audience. See you all again tomorrow on this national conference on robotics. Until then, wishing everyone a great evening. Thank you.